Hello everyone and welcome to today's session on data science by Intellipaat. Do you know that data science is a field that combines statistical analysis, machine learning and programming to extract insights from large and complex data sets? The goal of data science is to use data to solve real-world problems, make informed decisions and identify patterns and trends that might otherwise go unnoticed. At its core, data science involves collecting, cleaning and processing data to make it usable for analysis. This might involve gathering data from various sources such as social media, sensors or online databases and then transforming it into a format that can be easily analyzed. Once the data is prepared, data scientists use a range of techniques to explore and analyze the data, including statistical methods, machine learning algorithms and data visualization. One of the most important aspects of data science is being able to communicate the findings in a clear and meaningful way. Data scientists need to be able to tell a story with the data and convey their insights to a broad audience from executives and stakeholders to technical teams and data analysts. Overall, data science is a rapidly growing field with enormous potential to transform industries and improve decision making across a wide range of domains from healthcare and finance to marketing and sports. So if you want to learn about data science end to end, stay tuned with us till the end of this session and make sure to answer all the fun quiz questions in the comment section below. So without any further ado, let's take a look at the agenda. We'll start the session with a quick introduction to data science. We'll understand what is data science and how you can master the concepts of data science. Moving forward, we'll discuss topics like statistics and probability. We'll understand the concepts of probability distribution. From there on, we'll move to the NumPy, Pandas and Matplotlib library. We'll understand what are the various types of plots in Python. From there on, we'll move on to an introduction to machine learning and then understand what are the various types of machine learning algorithm. We'll cover in depth the concepts of supervised learning, logistic regression, unsupervised learning and reinforcement learning. At the end of this session, we'll cover a completely hands-on data science capstone project and then we'll discuss various data science interview questions that can help you crack your next data science interview. But before we begin the session, make sure to subscribe to our channel and hit the bell icon for regular updates. Let's now move on to our first topic.
Data science. In a world that is increasingly becoming a digital space, organizations deal with zettabytes and yottabytes of structured and unstructured data every day. Evolving technologies have enabled cost savings and smarter storage spaces to store critical data. Now, organizations can analyze this data to understand global market trends and enable their business to thrive. Data science can also predict future events based on the present and past data. Data science is a field of computer science that involves creating algorithms and models to extract, process, visualize, and find hidden patterns from the raw information. Data extraction and transformation, statistical analysis, data manipulation, visualization, machine learning, and predictive modeling are some of the most popular fields in computer science that utilize data science techniques. Every day, 2.5 quintillion bytes of data are generated, and it is more accelerated with the growth of IoT. This data comes from all possible sources such as sensors used in shopping malls to gather shoppers' information, posts on social media platforms, digital pictures and videos captured on our phones, and purchase transactions made through e-commerce. Now this data is known as big data. Companies are flooded with colossal amounts of data. Thus, it is very important to know what to do with this exploding data and how to utilize it. Amazon needs data scientists to find out customer mindset and enhance the geographical reach of both e-commerce and cloud domains among other business-driven goals. Similarly, Visa is an online financial gateway for many companies. Visa does transactions worth hundreds and millions in a single day. Due to this, the need for data scientists is huge at Visa to generate more revenue, check fraudulent transactions, and customize products and services as per customer requirements, etc. Now we have 5 stages of data science lifecycle. We have data discovery. It includes ways to discover data from various sources, which could be in an unstructured format like videos or images, or in a structured format like in text files, or it could be from relational database systems. Next stage we have is data preparation. It includes converting disparate data into a common format in order to work with it seamlessly. This process involves collecting clean data subsets and inserting suitable defaults, and it also can involve more complex methods like identifying missing values by modeling and so on. Third stage we have is mathematical models. These models are planned and built by the data scientist in order to suit the specific need of business organizations. Then we have getting things in action. Once the data is prepared and the models are built, it is time to get these models working in order to achieve the desired results. And the last stage we have is communication. The data scientists need to be liaison between various teams and should be able to seamlessly communicate his findings to key stakeholders and decision makers in the organizations so that actions can be taken based on the recommendations of the data scientist. In India, data analysts with 1 to 4 years of industry experience earn an average salary of 4,14,000 per year. Expert data analysts with experience of more than 10 years can earn 9 lakhs per year. In the USA, at the entry level, you can expect around $66,994 US. A data analyst with 3 to 5 years of experience would take around $74,860, while an experienced data analyst with 10 plus years of experience would be around $83,673 US.
Now we look at how to master data science. Step 1 is learning the basics. The first step to mastering data science is to learn the basics. This includes learning programming languages such as Python or R, understanding statistics and probability, and learning how to work with databases. So the first step is programming languages. Python is one of the most popular programming languages for data science. It has a large and active community and a wide range of libraries and frameworks and is easy to learn. Some of the key libraries for data science in Python include NumPy, Pandas, Matplotlib, and scikit-learn. Next is R. R is another popular programming language for data science, particularly for statistical computing and graphics. It has a rich ecosystem of packages and tools for data analysis and visualization and is widely used in academic and research settings.
Hello everyone, let's have a quick quiz question right now. And the question is, in linear regression, the mean squared error is a measure of, and your options are, the accuracy of the model's prediction, the variance of the model's prediction, the bias of the model's prediction, or the correlation between the model prediction and the true value. Please mention your answers in the comment section below.
Next we have SQL. SQL is a language used for managing and querying data in relational databases. It is an important skill for data scientists as many data sets are stored in relational databases. SQL is relatively easy to learn and is widely used in the industry. Next is statistics and probability. Statistics and probability are foundational concepts in data science. Descriptive statistics involves summarizing and visualizing data using measures such as mean, median, mode, variance, and standard deviation. Inferential statistics involves making inferences and predictions about a population based on a sample of data. Probability theory is also an important concept in data science as it provides a framework for dealing with uncertainty and randomness. Key concepts in probability theory include probability distributions, conditional probability, and Bayes' theorem. Next is databases. Databases are used to store and manage large amounts of structured data. SQL is a language used for managing and querying data in relational databases, which are the most common type of databases. NoSQL databases such as MongoDB and Cassandra are used for storing unstructured or semi-structured data and are often used in big data applications. Big data and distributed databases such as Hadoop and Spark are used for storing and processing large amounts of data across multiple nodes in a cluster. These technologies are becoming increasingly important as the volume of data generated by organizations continues to grow. Step 2 is working on real-world projects. Once you have learned the basics, the next step is to work on real-world projects. This will help you apply what you have learned and gain practical experience. There are many websites that offer datasets for projects such as Kaggle, UCI Machine Learning Repository, and data.gov. You can also work on projects for non-profit organizations or volunteer for data science projects. This will not only give you practical experience, but will also help you build your portfolio. Datasets and sources. There are many sources of datasets that can be used for data science projects. Kaggle is a popular platform that hosts a large collection of datasets and also hosts data science competitions. The UCI Machine Learning Repository is another popular source of data for machine learning projects. Data.gov is a government run portal that provides access to a wide range of public datasets. Open data portals maintained by governments, universities, and other organizations are also good sources of datasets. These portals provide access to datasets on a variety of topics such as healthcare, education, and transportation. Second is types of projects. There are many types of projects that can be done in data science. Classification and prediction projects involve using data to predict an outcome or classify an observation into a category. Clustering and segmentation projects involve grouping similar observations together based on their attributes. Regression analysis projects involve modeling the relationship between a dependent variable and one or more independent variables. Time series analysis projects involve analyzing data that is collected over time, such as stock prices or weather data. Natural language processing projects involve analyzing text data such as sentiment analysis or text classification. Third is project lifecycle. The data science project lifecycle typically involves several stages including problem formulation, data collection and pre-processing, exploratory data analysis, feature engineering, model building and evaluation, and deployment and maintenance. Problem formulation involves identifying the problem to be solved and formulating a clear research question. Data collection and pre-processing involve acquiring and cleaning the data to be used in the project. Exploratory data analysis involves visualizing and summarizing the data to gain insights and identify patterns. Feature engineering involves selecting and creating relevant features that can be used as input to a machine learning model. Model building and evaluation involve selecting an appropriate machine learning algorithm, training the model on the data, and evaluating its performance on a test set. Deployment and maintenance involve integrating the model into a production environment and continuously monitoring its performance. Moving on to step 3, specialize in a domain. Data science is used in many domains such as healthcare, finance, marketing, and sports. Specializing in a domain can help you gain domain specific knowledge and become an expert in that field. For example, if you're interested in healthcare, you can learn about electronic health records, clinical trials, and healthcare analytics. This will help you understand the data better and make more informed decisions. First, industry specific knowledge. Developing domain specific knowledge is essential for data scientists who work in particular industries such as healthcare, finance, or marketing. This involves understanding the business context and relevant regulations, as well as the specific data sources, data types, and data quality issues that are common in the industry. For example, a data scientist working in healthcare might need to be familiar with electronic health records, medical terminology, and HIPAA regulations. A data scientist working in finance might need to be familiar with financial data sources, financial models, and regulatory requirements. Second is subject specific knowledge. Subject specific knowledge refers to expertise in a particular area of study, such as biology, economics, or social science. This can be particularly valuable for data scientists who work on interdisciplinary projects or who collaborate with experts in other fields. For example, a data scientist working on a project involving gene expression data might need to be familiar with molecular biology and genetics. A data scientist working on a project involving social media data might need to be familiar with sociology and psychology. Third is soft skills. Soft skills are essential for data scientists who work in collaborative environments or who interact with stakeholders such as business leaders or clients. Soft skills include communication skills, teamwork skills, problem solving skills, and project management skills. Effective communication skills are important for data scientists who need to explain complex technical concepts to non-technical stakeholders. Teamwork skills are important for data scientists who work in interdisciplinary teams or who collaborate with experts in other fields. Problem solving skills and project management skills are important for data scientists who need to manage complex projects and navigate ambiguity. Step 4 is staying up to date with latest trends and technologies. Starting with continuing education, Continuing education is essential for data scientists who want to stay up to date with the latest trends and technologies. This can include attending conferences and workshops, taking online courses or certifications, and reading relevant books and publications. Second is emerging technologies. Emerging technologies are constantly changing the data science landscape. Some of the emerging technologies that are currently being used in data science include deep learning, natural language processing, and blockchain. Deep learning is a subset of machine learning that involves training neural networks with multiple layers. It has been used for applications such as image recognition and natural language processing. Natural language processing involves analyzing and understanding human language and has applications in areas such as chatbots, sentiment analysis, and text classification. Blockchain is a distributed ledger technology that allows for secure and transparent transactions. It has applications in areas such as finance, healthcare, and supply chain management. Third is ethical and social implications. Data science has ethical and social implications that data scientists should be aware of. Ethical issues in data science include privacy bias and transparency. Social implications include the potential impact of data science on society and the workforce. Data scientists should be aware of best practices for handling sensitive data such as de-identification and encryption. They should also be aware of potential biases in data and algorithms and take steps to mitigate them. Transparency in data science involves being transparent about the data sources and methods used in data science projects. Data scientists should also be aware of the potential impact of data science on society and the workforce. For example, data science can be used to improve healthcare outcomes, but it can also perpetuate existing health disparities if data is biased or incomplete. Similarly, data science can automate certain tasks, but it can also lead to job displacement if not managed responsibly. The final step is building a portfolio. Starting with personal projects, building a portfolio is an important step for data scientists who want to demonstrate their skills and expertise to potential employers. A portfolio can include personal projects that showcase the data scientist's ability to solve complex problems and work with real-world data. Personal projects can involve working with public data sets or collecting and analyzing data on a topic of interest. For example, a data scientist interested in environmental issues might collect and analyze data on air quality or carbon emissions. Second is Kaggle competitions. Kaggle is a popular platform for data scientists to participate in competitions and showcase their skills. Kaggle competitions involve solving real-world problems using data and machine learning algorithms. Participating in Kaggle competitions can help data scientists improve their skills and gain recognition in the data science community. Kaggle also provides an opportunity for data scientists to collaborate with others and learn from their peers. Finally, open source contributions. Contributing to an open source project is another way for data scientists to show their skills and expertise. Open source projects involve collaborating with others to develop and maintain software or data resources that are available to the public. Contributing to open source projects can help data scientists improve their coding skills and gain exposure to new technologies. It can also demonstrate their ability to work collaboratively and contribute to the data science community. Now we'll look at what is the demand for data science professionals. The demand for data science professionals is high and continues to grow rapidly. According to the Bureau of Labor Statistics, employment of computer and information research scientists, which includes data scientists, is projected to grow 19% from 2020 to 2030, much faster than the average for all occupations. This growth is driven by the increasing use of data in organizations across all industries, from healthcare and finance to retail and manufacturing. This is indicative of the growing importance of data-driven decision making in organizations of all sizes. Overall, the demand for data science professionals is high and is projected to continue growing in the coming years. This presents a significant opportunity for individuals with skills and expertise in data science to pursue rewarding and impactful careers.
So let's take a look at some of the tools that the data scientists are using and the tools that they need to understand to perform their tasks. So firstly, where they take a look at something called IDEs. IDEs stand for Integrated Development Environment. These are basically softwares that allow you to write and run code quite easily and efficiently. They complete some of the code that you're going to write, and they help you avoid errors and make mistakes. So they save you a lot of time. And having a good grasp of the IDE, of the programming language that you're using to create your own data science pipeline is very important. So if you're using Python, the IDE that you could use is Anaconda. There are many other IDEs for Python as well, like PyCharm, so on and so forth. And if you're using Java, there's Eclipse. If you're using R, then RStudio is probably the best. But depending on your taste, you could try out multiple IDEs and figure out which one suits you the best. Then comes data visualization tools. These tools can be used quite sparsely or quite heavily depending on the kind of data that you have and the kind of visualization that you're trying to perform. So if you have a lot of data and you wish to visualize them efficiently, data visualization tools come in quite handy. So tools like Tableau make it really easy to perform really advanced visualizations on your data. Then comes data processing tools. So data processing tools allow you to process massive amounts of data that you would have from customer interaction or from any other data source. Tools like Apache Spark or many big data technologies come in handy when you want to perform some sort of an operation and process a really large amount of data set. Then comes data analytics tool. So there are many tools that allow you to analyze the data that you have processed and understand or extract some key information out of the results that you get from those tools. Tools like SAS, RapidMiner, so on and so forth. Now this list might seem a bit exhaustive, but you don't need to know all of them. You need to understand that these tools are available at your disposal, and you need to understand that you can use them whenever you wish to choose. So now let's take a look at some of the key skills that you require as a data scientist. So what are the things that you will be expected to know? So mathematics is quite an important thing. Mathematics isn't just understanding the basics of how numbers work and how to get things done. Mathematics in data science especially involves really really advanced topics like statistics, probability, calculus, and there are many others, but these are the general ones. And when I say mathematics, you don't need to be an expert in all of these technologies. You don't need to do PhDs in mathematical concepts. What you do need to do is you need to understand the basic concepts of statistics. You need to understand the basic concepts of probability. You need to understand the basic concepts of calculus and how they can be used in your data science process. There are other fields like linear algebra as well that can also be used when we're trying to represent data in our computer programs. But for the most part, understanding probability, statistics, and calculus and having a really good foundational knowledge of these things can really help you move ahead in your career. Then comes databases. So databases are again one of the most important aspects or key skills that a person needs to have to become a data scientist. The main reason for that is that databases are one of the fundamental things that people use to store data. And since you want to be able to gather data from multiple sources, you're going to encounter databases quite often. Again, as I've said earlier, you don't need to be an expert in all of this. Databases are quite important. You need to understand how to use them, and you need to understand how to use different kinds of databases and make them work together. So you could have an in-memory database like SQLite. You could have a NoSQL database. You could have a graph-based database. You could have a document-based database, or you could have a simple legacy SQL database like SQL Server, MySQL, MariaDB, so on and so forth. So you need to be able to understand how to use those database systems in conjunction and extract data based on the kind of data model that you're using. The main difference and the main problem here is that different kinds of databases use different kind of modeling techniques to store data in them. So for instance, a NoSQL database would be having data sets modeled differently than an SQL database, and a graph database would be quite different from how data is stored in a document-based database. Then comes programming. So programming is one of the core competencies of a data scientist. And it's okay if you don't know programming as of now, you can always learn. And you don't need to be an expert in how to structure massive applications, but you do need to know how to write code to get things done. So programming is something that gives you great flexibility to allow you to define your own data science process. So how do you want to extract data? How do you wish to visualize it? What are the parameters that you want to take? What are the data sets that you want to extract? How do you want to process them? What to do when you encounter null values? Every one of these things could be written into a program, and this would be automated for you. So this could be a really good thing for you. Another thing is when you work with tools like SAS or Tableau or any other data visualization or data analytics or any tool that a data scientist might use, they allow you to do something or write something called a script. So a script would basically mean some program or some lines of code that will interact with those software and do some common tasks for you. So if you know that you will have 15 different files and you want to open them one by one and then extract some sort of information from all of them, instead of doing it manually, what you can do is you could write a script that would run that program, get the information from those files, open them one by one, and do it for you. So these are the kind of things that programming is good for. Now, when it comes to programming languages, you have many choices. Data science is so popular nowadays that you could do it with almost any language that you can think of. However, the most popular are still Python and R. Now, R is mostly used in academic and research areas, and Python is mostly used in business environments, in IT industries, and so on and so forth. But these things are not set in stone. So if you are in a business environment, you can also choose to use R, or you can also choose to use Python, even if you are performing data science for some research or some statistical analysis. Now, this does not mean that you could just mishmash the technologies, but you do need to understand why you're choosing one over the other and how to get good grasp of what are the libraries and what are the tools available for me in these languages. Python is far more popular than R in terms of data science, mainly because of its expressive and clear to read syntax, but you could use other languages like Scala or JavaScript or Java or C++ as well. Just make sure that you read the syntax, you understand it, and you get a good grasp or solid foundational knowledge about it. Then comes data analytics. So data analytics or data analysis is the thing that allows you to be able to extract key insights from the data that is available to you. So to give you an example, let's say that you have a lot of data. Let's say that you have gigabytes of data and you wish to extract some common knowledge out of it. You wish to extract the kinds of products that people around the age of 18 are most interested in, or the age group that is interacting with your product the most. So since you have large amounts of data, you need to be able to process it and then analyze it correctly, because if you're not able to analyze it correctly, then it's quite possible that you're going to get an incorrect result or an incorrect response, and that incorrect result is then going to lead you to make incorrect decision about where the business should move and how the next step that you need to take should be taken. So now let's take a look at the learning path of a data scientist. So in the learning path, we'll take a look at the things that you can do in order to become a data scientist, even if you have no experience. So even if you are someone who knows nothing about programming, even if you're someone who knows nothing about Python or statistics or any mathematical knowledge, even if you're a complete beginner, you can still follow along with this data science learning path and understand how to get things done. So the first thing that you need to understand is mathematics. Now, mathematics isn't the most easy thing to understand, but it's quite easy to understand once you get the basics. So I would recommend that you understand the statistical part of it first, then understand probability, then calculus, and if you have time, take a look at linear algebra as well. These things allow you to perform some really important tasks. You can combine your knowledge of programming with these mathematical skills that you've acquired, and these will allow you to make some really, really good decisions based on the insights that you've gathered. So statistics is mainly used to make sure that we are on the right path and the data that we have actually represents the real world. Then calculus is used to make sure that we are on the right path and our model is performing correctly. It allows us to evaluate our model, it allows us to train our model, and probability is used in many algorithms to make sure that we are make sure that our predictions are matching up with the reality. And then linear algebra is also used, and it's used to represent data in a computer science linguistics. So to understand how to model data that we extract from real world and store it in computers, this is where linear algebra comes into play. Then there's programming. Again, as I've already told you, there is no need to learn one language over the other if you're not comfortable with one language. So you can learn many languages. I would highly recommend that you start with Python or R because these are the most popular ones. You could learn any other language, or maybe you are familiar with one language and wish to start learning data science in that language. That's also possible. So languages like Java, C++, Scala, JavaScript, all of them have good support for machine learning. However, the most popular ones and the ones with the best support for any data science related task that you have are still Python and R. Again, as I've already told you, Python is mainly used for a data science task in a business environment. So if you're working in an IT company, if you're working in an e-commerce company, if you're working in an environment that has business rules, then maybe using Python is a better choice. And if you're working in an academic environment, if you're doing data science for research, for extracting information out of some data set and then use it in a research paper or a journal paper, using R is quite easy, and people around you might know R better. But there's no rule set in stone that you can only use R in academic environment and only use Python in a business environment. It's totally up to you how you wish to use it, and that's totally going to work. Then comes building a portfolio. So building a portfolio basically means creating small projects, solving small tasks that data science could solve. Many people have come up with many ingenious solutions to simple problems that the traditional programming could not solve. So to give you an example, there is a hand digit recognition system that was built using data science concepts. So what it does is that it takes a look at a person's writing, analyzes the things that he or she has written on a piece of paper or on a digital pad, and then converts it into text. So it takes a look at some of the digits that you've written. Let's say that you have handwritten 271. The computer will process the image and then extract the number that it thinks that you've written on the image. It could be 271 or it could be 272, depending on what you've written and what it performs, and the kind of data that it extracts. But this has been highly successful. Many real world projects or real world products use them. Things like Google Lens also uses it to take a look at a photo and extract some text out of it, and many other applications of it are available. Similarly, things like the facial recognition, facial classification. If classification and recognition are two different things. Recognition basically means taking a look at a photo and understanding if that photo contains one specific person, and the classification part is just taking a look at a photo and understand if it contains one person or not. So if it takes a look, a classification system will take a look at a photo and just return yes, this photo contains one person, and the recognition system will take a look at the person's face and tell you whether that person is who you wish it to be. So building small solutions and then moving on to medium scale or large scale solutions is quite useful for you, because if you build these solutions, then that helps you prove to the recruiters and prove to the people who are looking for a job that you're interested in these kinds of things and that you have the skills needed for them to hire you. Then getting certified is one of the most important aspects, mainly because many people don't do this. They do a lot of learning. They learn a lot of concepts about mathematics and programming. They build small projects, but since they're not certified, then people are not really sure whether or not they know the things that they claim to know, whether they have built the project that they claim to build, whether they've got someone else to build it, whether they possess the skills that they actually need. So once you get certified, it becomes really easy for the developers and any other technical person to evaluate you, because they can just take a look at the certification, take a look at the things that are being taught in that certification, and can tell the person who's trying to recruit that this person is a good fit for our team. Or maybe they can tell you to improve your skills, maybe get the newer certification that's available, and then they can give you a call. Many HRs and headhunters look at people's resumes for a specific certification as well. So just make sure that you understand what kind of role you're applying for, what kind of company you're applying to. And once you understand that, then you can move ahead and understand how to do the things that you want to do. And after you get certified, you get a competitive edge, and your chances of getting shortlisted improve greatly. And then comes apply for the jobs. After you have performed these steps, you are well on your way to becoming a data scientist. Depending on the experience that you have and the skills that you have, you could get really good paying salaries. And what you can also do is you can solve some real world problems that you see on a daily basis, and you could use data science skills that you have acquired to solve those problems and understand how you can improve upon those and could build your own products that are useful for other people as well.
We are going to introduce some basics of statistics, as well as introducing you all to these statistics before we start any probability, anything on probabilities. First, when I say statistics, what exactly triggers in everybody's mind? So you might have seen your daily newspapers where people talk about how much pollution is there in northern central part of India, like Delhi, and what is the percentage of carbon content in that. And also you see that how many people, and also coming to the sports, you might have seen that how IPL is going on nowadays, and how many runs that particular batter is doing. So all these numbers, okay, actually shown that who is performing better. Or if I take an example of one batsman, how his record has been from past several years, how many runs he made, what is the average he made, and what is the best he made, I mean to the maximum runs he made. So all these things, actually all these measures generally describe the data or the performance of that particular batsman, or anything, the situation or the scenario that you are expressing in the form of data. From that data you are actually trying to tell some numbers out of it. Let us look at this example. An university is actually trying to show that who are the people who are graduating into chemical engineering, and there are many graduate engineering graduates are there, out of which how many of them are chemical engineers in 1998 and in 1988. So if you look at this one, from within 10 years, 1988 to 1998, what is the ratio of these chemical engineering graduates are changing? For example, here in 1988, if there are total graduates are 140, out of which 120 of them are chemical engineering graduates. Now in 1998, there are, let us say, 130 engineering graduates, out of which only 90 of them are chemical engineering graduates. So now what this chart will give you, what is this actually talking about? This is actually talking about the data of engineering graduates, out of which how many of them are chemical engineering graduates. So you are representing the complete data in the form of simple charts or simple measures. Here it is just in a number. Okay, based on that you are actually describing the data. Let us talk about this figure 2. Here, what exactly this is representing? It is representing that you are having some stock price of Facebook, all right, and how it is varying from 2009 to 2018. And since we are in the year of 2016, it is projecting that is the projected stock price, okay, projecting the stock price in 2017 and 2018. So for example, if a person is at this time instant, let us say 2013, he has the history of the data 2009 until 2013, and he is projecting this data, means projecting the sales or the stock prices, okay, in the future years. So I'm not going to talk about how Facebook is performing and all these things, but this is an example I'm just taking to explain you that what anybody expects out of the data in the simple charts to describe about statistics of the data. So in this session, I'm going to talk about more about descriptive statistics. Okay. Descriptive statistics is the term given to the analysis of data that helps to describe or to summarize, okay, in a meaningful way. For example, if I'm giving you this particular sheet of data, Excel sheet of data, and I would ask you that what exactly this data is representing. Okay, so for an analyst, okay, who is going to sit down and looking at this data, he will first try to understand what is this data all about, and when he is going to communicate, he would actually start analyzing this data in this way. For example, if I'm looking at population projection of Delhi, okay, so this is the year, okay, and these are the as of 1st March, okay, these are the males, these are the females, and urban, rural, as in 1st July, similarly the values. So as in 1st October, this is the value. If somebody comes and asks you about this data, forget about statistics. If somebody comes and asks you about the data, the first and very important point, a very important way to describe this data is, hey, this data is talking about the number of males, females, okay, in urban and rural areas. They have recorded in 1st March of every year starting from 2002 to 2026, okay. Since we are in the year of 2016, these are all the projected values, okay. That is what the population projection of Delhi. So we are actually trying to predict what could be the population in Delhi. I don't know how they have predicting and everything, but this is the data I got it from the survey department. Now I will have to give some kind of summary of this data. So whenever you are trying to give the summary of this data, then you have to then the particular field is called descriptive statistics. Okay, as I mentioned earlier, descriptive statistics is the term given to the analysis of the data. So you are going to do the analysis of the data, and here you are not going to do any projections or any predictions, any estimations. No, you are just, you got the data, you are actually giving the summary of the data. So now it is very important because you are going to take the raw data. This is called raw data. What I mean by raw data is that which is in the very basic form. No analysis has been done. No pre-processing has been done. What I mean by pre-processing, most of the data that we get out of all these surveys or any kind of experiments, the data will contain a lot of unnecessary information that is called noise. So when we have this noise, okay, so before we conduct any analysis, we try to remove that noise. But here the question comes, how do I discover that noise? That I'm going to cover in the later sections. But to explain you that what is raw data is the data that you are getting in the very basic format on which you are going to perform some analysis, okay, and to describe the complete data in a very descriptive format. Is that clear? So now, in simple sentence, if anybody asks us what is descriptive statistics, which means that descriptive statistics enables us to present the data in a more meaningful way. Okay, in the simple way, I can say it is a simple interpretation of the data. All right. So simple interpretation, just now the way we have done here, this data is actually explaining about the population data, population projection of Delhi from 2002 to 2016-26. Okay, and on March 1st, 1st July and October. Okay, so now similarly, yes, if I talk about this particular table, Okay, can somebody interpret this data by yourself? Please look at this table and try to see that what exactly can you interpret here. Yes, if we interpret this data, okay, this data is talking about near about 22 languages, okay, and people who are actually talking, of course the table title itself is showing, but let us only from the data itself, let us interpret this data. And okay, in 2001 and 1991, how many people are speaking Assamese in 1991 and in 2001? Okay, male, female, and the percentage it is showing, right? So now this is simple what the data is. Now I'm going to ask you that what is the percentage of the people who are speaking Hindi, okay, and those are males? Another question, how many people who are speaking Manipur, okay, who are females in 2001? And I also asked the questions that from 1991 to 2001, what is the percentage growth of people who are speaking Bengali in Delhi? Are you getting my questions? So all these questions can be answered from this data only. But in order to answer all these questions, first of all, we have to do a very simple operations on the data, which means that so simple measures that we have to find out. For example, if I'm taking an example of Sachin Tendulkar, I would say Sachin Tendulkar is a very good batsman. He is maintaining a very good average. What do you mean by average? The average is a simple measure that is completely describing his performance from the past 10 to 15 years. Similarly, if I say that one particular simple, what is that simple measure that I can get out of this data to explain, to interpret this data in a more meaningful way? That is what we are actually talking about, the descriptive statistics here, right? So the questions that I have asked, can anybody able to answer those? For example, what is the percentage of growth of the people who are speaking in Bengali from 1991 to 2001? Those are especially females. If I'm asking this question, then I will go to 1991 female, and in 1991 female who are speaking Bengali, and 2001 who are speaking Bengali. Then what is the percentage of growth? So the percentage of growth is nothing but the difference between these by the original. So that is one measure. Percentage of growth is one measure that gives you the complete understanding of the people who are speaking Bengali. But from this data, there can be many questions can come out of it. So let us represent all of them in a simple form, so that that particular form, it may be a visualization graph, a plot that can provide you the complete set of information. This slide is mainly talking about collecting the data, understanding the data, finding the useful information in the data, interpreting the data, and visualizing the data. So somebody has collected this data, okay, and we are trying to understand this data. And after understanding the data, we are trying to find out what is that useful information that is needed. So useful information means those are patterns in the data. There can be many patterns. There you can retrieve many information out of it. I mean, it's many information points out of it. But from the business point of view, if a person asks a question from the business question, how do you really interpret it, find out that pattern? The pattern may be, I wanted to know the people who are, okay, this is the question perhaps I can ask you. I wanted to know how many people are there from South India. Okay, so South India, here in this data, South India is not well defined, but that is the question I'm asking you. So you know some of the South Indian places and you know some of the South Indian languages. So you filter out those languages, okay, and then for example Tamil, Telugu, okay, and any other languages here you can see Malayalam, okay. So for example these some of these South Indian languages I filter them out. After filter them out, I will call all these Telugu, Tamil, Malayalam or any other language into one particular bucket, and I would say that yes, these are all South Indian languages. How many of them are there? I filter out their information. So how do I represent that one in this very simple form? Okay, that means, see, it's not a pattern, but it's a kind of information that I'm trying to get out of this data based on the business question that was asked, right? So based on that business question, I found that information, and then I'm interpreting the data. Interpreting means I'm doing some operations on the data, and then show it in the same visualization format, maybe bar charts or simple any other charts. All right. So here, what I wanted to emphasize is that whenever you get this data that is in the raw data form, and you try to get all this raw data form into a very simple descriptive statistics form, or a simple measure like average or percentage of growth or a maximum, minimum. So these are all some terms that generally people use to communicate or to interpret the data. Okay, so what is statistics? Okay, as I mentioned, that is an example here. Descriptive statistics means it's a collection, presentation and description of sample data. So descriptive statistics are used by researchers to report on population and samples. Just now that's what we have seen. And in sociology, right, and it is a kind of a tool that we use to comprehend the complete raw data in a more meaningful format. Okay, that is descriptive statistics. So you got the data and you're explaining about the data. Very simple. Okay, so what is inferential statistics? Inferential statistics are those from that data you make decisions or you draw some kind of conclusions out of the data. For example, I'm going to the same data here. Okay, I was talking about number of people, maximum number of people, percentage of growth and all these things. Now suppose if I want to take a decision that as the population is increasing, right, that first of all, yes, whether the population is increasing, yes, it is increasing. That is how do you know that population is increasing? That we can find out from the descriptive statistics using the univariate profiling. I will show you what is univariate profiling, bivariate profiling, okay, in the later parts of the course. But just for now, to understand that whether this number of males is increasing and females are increasing. Now the question I wanted to ask here is that I wanted to I wanted to see, suppose I want to take a decision that that is more relevant to female population. Okay, so now I'm going to take a decision. All right, first let me answer this question. Male is increasing the most or the female? Is it in urban or in rural? If it is in urban, what is the projected growth rate? If it is rural, what is the projection growth rate? So the questions that I'm asking, okay, those are all some kind of, I want to draw out some conclusions out of this data. I want to take some decisions out of this data. Should I focus more on the urban? Should I focus more on the rural? Okay, so the descriptive statistics just give you the information about the data, but inferential statistics is the one that helps you to infer something from the other. I want to infer that, okay, I will put it like this. So for example, in the rural area, okay, in the rural area, this is the population that is increasing. Okay, and this is the population of female, those are increasing. Okay, now I wanted to ask this question: as the female population is increasing, is it increasing at the faster growth than the male growth? I'm repeating my question again. The female growth rate, okay, I mean to say the projection, what it may be, is increasing much faster than this. Yes, I will answer that. Okay, in order to do that one, first we have to see the velocity of the population growth rate in each year. What I mean by velocity is nothing but the number of for example, from 2016 it is 11,827, okay, and 2015 of the same time, okay, I'm calculating the velocity in 1 year. 11,827, okay, minus 11,481 by 1 year, nothing but the difference. Okay, how much it is changing here, how much it is changing within the same year. 9,458 minus 9195. You can do simple math by yourself, okay, on a simple paper, and see that which one is increasing in 1 year. Now, if I ask the same question for the complete like this 2002 to 2026, you actually find out the difference between this and the number of years. Similarly, here, okay. So then you can easily answer that which one is actually growing at a faster rate. All right. So these are all some kind of I'm actually giving you some examples here, but what we are trying to achieve here is that to introduce all of you then from the data. Okay, once you get the data that is in the raw data form, fortunately this data is very clean. What I mean by is that there are no missing values, okay, which has a very clean numbers. So we can draw we can actually describe about this data in the more descriptive form, okay. And if I want to draw out any conclusions or any kind of decisions, then I generally do some analysis that is called inferential statistics. That is what these are the two different segments, I would say two different segments that describes about statistics. Is it clear? Now, for example, from the industry standpoint of view, generally you might see different kinds of every day you see these e-commerce sites, right? There you will find out different types of products and everything. But from the business point of view, let us say you are hired by one big e-commerce site where you are going to give some kind of suggestions to the management to take decisions, okay, in terms of revenue growth. Let us take this particular example, okay. Look at this particular page and there are 4 products, okay. Samsung Galaxy S3 Neo, that is blue and white, and there is Core 2 Samsung. So there are different products, and now everybody looks at these prices, EMI, and the specifications of these. So now the question here is that tomorrow, given the market changes, dynamics of the market, and as well as what I mean by competitors and the product values, so how do I design, how do I come up with the optimal price? Okay, how did they come up with the 7,180 instead of 7,200? How did they come up with this number? Why did they come up 12,480? So how do you decide, okay, the optimal price of these products, okay, so that your sales will be maximized?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So I had shown an example of an e-commerce site where we wanted to decide the optimal price of these 4 products. Those are shown here. Defining the optimal price is one of the business problems. Similarly, there can be many business problems like how do we maximize the revenue, or how do we increase the, of course, maximize the revenue through sales only. And in order to maximize the sales, there are many ways. One is the optimal, how do we decide the optimal price, or which products are more interest to the users, and what are the features that customers are looking for. So there are many dimensions that we have to consider in to maximize the sales. For any business problem, whether it is maximizing the sales or for deciding the or understanding the customer intentions. What I mean by intentions, customer intentions are what exactly he is looking for in my e-commerce site. So for any business problem, we have to start collecting the data. So how do we collect this data? So do we collect this data from Monday to Friday, or during the weekends, or for continuous periods of months? So what is the time frame that we are actually looking for collecting this data? That is very, very important. Perhaps I wanted to look at this data as per the quarter level. In the first quarter, what are my sales? In the second quarter, what are my sales? So whether my sales have been improving or not. So these are some kinds of data points that I'm actually looking for. So now, if we take these 4 products, and before I start analyzing or taking any decision, I would like to take the help of descriptive statistics to understand the data. Let us take a very simple example here. In this example, I am showing product 1 sales, product 2 sales, 3 and 4 in different months starting from January 2015 to May 2015. So looking at this data, what can we really infer? Okay, before we infer anything from this data, let us get the summary of the data. Okay, so what is the summary of the data? If you look at this one with a naked eye, I can say that all right, there are very good number of sales in February. Here product 2 also there is good number of sales in February, whereas in product 3 in March there is a good number of sales, and in product 4 in February. So not only like that, okay, so we have to use some kind of measure that we have to use before we summarize the data. Let us take an Excel example. Okay, so these are the 4 products that I'm talking about and their sales. So when you want to summarize this data in Excel, okay, because everybody is having a good exposure to Excel, so that's why I'm taking the example of Excel here. So if I want to see, if I want to get the summary of this data, so I will prepare another table for each of this product, okay, within this time period that is having these are the measures. What are those? Which is, what is the minimum number of sales happened? 220. This one. What is the maximum number of sales? 542. What is the sum of the total sales? Okay, which is nothing but in this given time period of this data that I collected for these products, out of these products, for the product 1, the total sales are happened in 1753. Okay, and also mean. What is mean? Mean is nothing but it is the average of the sales those are happened. Average is the sum of all the sales from January to May and divided by the number of months. Okay, since I am looking at the data at the months, then it is the sum of these product sales by the number of months. Okay, that is nothing but 1753 by total 5, which is 350.6. So the average number of sales happened is 350.6. And what is the median? Median you calculate, okay? You just keep all these values in the increasing order. What I mean by increasing order, which is starting from 220, 224, 311, 456 and 542. This is what the increasing order. Okay, just for your information, I'll write down here 220, 224, 311, 456 and 542. So when you calculate the median, okay, you have to just start moving from left 1 point as well as right 1 point. Okay, again left 1 point and right 1 point. So which is nothing but the center of the all these arranged ordered numbers. So which is nothing but this is the median. Okay, so here what we have to keep in mind is that when I'm going to discuss about the distributions, okay, whenever you want to see the profile, what I mean by profile is that any variable, okay, I'm going to explain about variables as well very soon. Any variable that is going to, I mean to say here, the variable is sales of the product 1. Okay, for example, any variable, let us say this is the variable. In that variable, that will have mean and median. Okay, so that, okay, first I want to describe about the profile. Profile is nothing but any variable that will have certain characteristics, okay, that can be represented in the form of min, max, sum, mean, median and standard deviation. This is called profile. If somebody comes and asks me, hey, what is the profile of the sales of product 1? Then I would say, hey, the profile is, it has a minimum number of sales of 220 and maximum number of sales of 542. The total number of sales of that product from January to May 1753. And the average sales happen to be 350.6. And the median is around coming out to be 311. So whenever I say the profile means, immediately it should trigger in our mind that this will have all these values. Alright. So if somebody comes to you and asks you, hey, can you perform some profiling on this data? Which means that they are expecting all these different values to understand what is happening in that particular variable. Now, I just mentioned that please keep in mind this mean and median are very important characteristics of any profile, which means that the distribution I'm going to talk about of any variable can be easily characterized by these two values, and also these two values help us in identifying whether the distribution is the required distribution or are there any skewness in the distribution. So anyways, so keep in mind that these are very two important parameters of any profile. So now here I'm talking about the similar way for the product 2 and product 3, product 4. So this is the complete summary of the data that I'm presenting it here. Alright. So now, is this summary sufficient for you? Is this summary sufficient for you? No, this is not sufficient. There are some more other characteristics that I'm going to introduce that would be helpful for us to characterize the data. Let us take an example. Okay. Let us say this is an example which is actually talking about how do you compare the two distributions of, okay, two distributions. Before I use the word distribution, I just use very simple English. There are software, there are salaries of two companies in San Francisco and New York of different designations like junior software engineer, senior software engineer, project lead, manager, and senior manager. So these are the salaries of two different companies. Okay, one is in San Francisco, another is in New York. Now, if somebody comes to you and asks you, hey, can you just profile this data? When you profile this data, okay, means the salaries of these people, what do we want? Okay, the first one is, what is the minimum salary of the company that is located in San Francisco, which is 5,000, and what is the maximum salary, which is 55,000. And it is good that it is already in the ordered one right here. The salaries, as the designation is increasing, it's quite obvious that salary would also increase. So now here I wanted to know what is the mean of the salary. So here I have just populated my summary. When I actually summarize this data, the minimum of both the companies is coming out to be the same, maximum is same, mean is same, and median is same. But if you and I observe this data of this very small data with the naked eye, we can see that the senior software engineer of a person of this company in San Francisco is higher than in New York for the same designation. Here, in the project lead, New York organization is paying more than San Francisco. But when you summarize the data is coming out to be same. I mean to say that summary is looking same, right? The min, max, mean, median are also looking same. But this is not the actual case here. There is some variation among this data that is called the variability, or we can say that dispersion. So I'm going to describe about dispersion here. Dispersion describes the variability of the data. So we need few more measures to actually evaluate the characteristics of the profile. The first one is the range. Range is maximum minus minimum. Oh, here also the max and min, the range is coming out to be same because the max and min are same for both the companies, right? Then let us go to the other one, which is mean absolute deviation. Mean absolute deviation, which is nothing but, suppose you are having 5,000, this junior software engineer who is earning 5,000, how far is he from the mean value? The mean value is 30,000 here, right? The mean value is 30,000. And how much this person is varying from the mean, and which is the absolute value. That is the mean absolute deviation. Mean how much this particular junior software engineer from San Francisco is deviated from the mean, which is an absolute value, all right? So which is nothing but 30,000, so 5,000 minus 30,000. Okay, similarly software engineer of this San Francisco. So I calculated for all of them, and when I sum all these values, the mean absolute deviation is coming out to be 15,000 here, whereas for New York it is coming out to be 25,000. So which means what exactly this is actually giving me the information? This information gives me that the company in San Francisco, the people who are earning money are very close to the mean than the people who are in New York, right? So these people are, let us say these people are 5,000, three of them are, three designations are complete, are 25,000 distance away from the mean, right? And these people are again 25,000 points, I mean the salary points away from the mean, right? So the mean absolute deviation is nothing but the sum of all the mean absolute deviations, okay, which represents this one. So here we found this particular MAD, mean absolute deviation, is helping us to find out the variability across the two profiles. Am I right or not? Neither the mean nor max or any other mean, median, range was not actually giving us the variability in the data, but mean absolute deviation is giving us. Okay, now we are going to the variance. Variance here, okay, which is the same difference but square of that, and we calculate the variance as the sum of all these values, which is the variance. Similarly for the New York, and then once we calculate the variance, we can calculate the standard deviation. How? Standard deviation is equal to square root of variance, right? So which is here in this case the standard deviation is 17,078 and 25,000 for the New York based organization. So this value is giving some information. What is that information it is giving? Which gives how much these salaries are varying from the mean. Okay, how much it is deviated from the mean. Okay, so this is second measure. I mean to say third measure, range, which is coming out to be same. Mean absolute deviation, yes, it is giving good value, good information, as well as variance. Now let us see what is coefficient of variation. What do you mean by coefficient of variation? The variation, that is, which is nothing but the variance that we calculated, okay, and then standard deviation we calculated, okay, and the mean. The coefficient of variation is nothing but the standard deviation by mean. How much it is deviating divided by the mean value. So the coefficient of variation, so it is coming out to be 57%, whereas here 83%. So if you look at these three measures like mean absolute deviation, variance, and coefficient of variation, these are all actually capturing almost all the same kind of information but in a different units. What I mean to say is that mean absolute deviation gives us the information that most of the salaries are not away from the mean, and here the coefficient of variation, which is also giving the information that there is not much variation in the data when compared to the people who are in New York. Alright, so there are cases where whenever you are summarizing the data, you are getting the same kind of values, but data is not capturing that. Okay, I mean to say the data properties are different. So now these are the some of the measures that will help us in identifying the different properties of the data. Now I will explain these skewness with the graphical plots as well. In fact, I would explain all these concepts with the plots as well, but this is an example trying to show you that whenever you get the data, what are the different characteristics that I should consider to describe the data. So coefficient of skewness, yes, coefficient of skewness is actually, this is the, I'm straightforward giving you the formula here, which is the mean minus median by standard deviation. Whenever mean is equal to median, the coefficient of skewness will become 0. And whenever there is whenever the coefficient of skewness is 0, then you should be very happy that the distribution is not skewed. Skewness is a property of the data that is centered towards, that is centered means that is actually not for, that is the mean and median are not equal, where it is moving towards either left or right side, which means the distribution is skewed. Skewed means it is actually not following the very good distribution. We have worked out on very small data as an example, where we were trying to compare the salaries of two people coming from San Francisco, New York. Why can't we do the same thing for a very not very big for a data set that is reasonably better? Okay, so I'm not talking about any very big data table. Let us talk about a small data table that is having total 100 customers who had come to my website and had purchased different products, and their gender, what kind of product they had, what color of the product. Here I have taken Samsung Galaxy of 3 different phones, okay, and their color, the characteristics of the product like memory size, price, and what is the EMI value that it is actually showing there in that website, and number of sellers. Okay, so it is also the feature of the product who are all selling, and RAM size, whether it is having dual SIM or not, and what is the resolution of the camera. So now similar data set, assume that you have collected for your experimental study data, okay, from the experimental study data, and you want to get some summary of the data at any point. Okay, whenever you are going to handle with the data, it is always better to first get this summary of data irrespective of whatever may be the data. Okay, so now let us say now I want to apply the I want to just summarize this data by using the descriptive statistics. So there, if I am actually going to do that, the first thing, summary of the data, I would say that number of rows is 100, okay, and number of columns, how many columns do I have? 11. Now I want to calculate the mean, max, mean, median, standard deviation, and number of unique values. So here I just want to explain you one more concept, that is the type of variables. Because if you are actually looking for minimum for anything, something like for the gender, so is it possible to find out the minimum? No. So you can find out the minimum value, maximum value, or mean value for only continuous variables. Right? Continuous variable means those are numerical variables, and those have some value. Okay, there can be situations that the values will be numerical but may not having some value. So in order to explain this particular, before I go and summarize this data, it is very important for us to understand what are the various types of variables that we generally encounter in our data. Okay, so you might say that, hey, by looking at this one, I can see the numbers and the strings. These are the only two types. But from the statistics point of view, it is better to understand various types of these variables.
Let's have a quick quiz question, guys, and the question is, which of the following is not a common pre-processing step in the natural language processing? And your options are tokenization, lemmaization, normalization, or data augmentation. Please mention your answers in the comment section below.
So now let us look at these basic definitions. So population, okay, these are the basic definitions. I will explain this population, sample, and everything. Okay, population is the group from which data need to be collected. Let us say a large population of software engineers in Bangalore, which is one of the examples. Okay, and out of which you are selecting some 100 people for your study. For example, whether they know any particular computer programming language like Java or Python or any other .NET. So you want to see that how many people know a particular computer language, programming language. So you may not go to each and every software engineer in Bangalore, Okay, so you take some sample there. I want to explain what is variable. A variable is a feature characteristic of any member of a population differing in quantity and quality. Okay, please remember this, quantity and quality. Based on this quantity and quality, we are defining the quantitative variable and qualitative variable. Quantitative variable is the variable that is actually differing in quantity. Okay, and qualitative variable is that is differing in the type of quality. For example, you may have, okay, for the product I am having color. It is a qualitative variable, okay, which is not having any quantity, means any number associated with this. No. Okay, and similarly, if I'm talking about the stock price is going high, okay, the stock price is going at low. So there I'm actually talking the qualitative nature of the particular variable, right? So these are the first quantity and qualitative variables. And then discrete variables. Discrete variables are those variables those will not have any floating values. Okay, these are called, in programming language we call them as integers, right? So int, generally whenever we write any program we say int. Okay, so what are the examples of the discrete variables? So how many number of licenses you have, how many number of insurances you have, how many products, how many number of products, number of cars, number of visits. So you cannot say that I visited this shop for 2.5 times. You always say that I visited this shop for 2 times or 3 times. Okay, so such kind of variable is called discrete variable. And then continuous variable is the one which is again quantitative variable that has some floating values, like this product value is $233.35, or this particular one costs $2.57, so which has some floating value. So whenever we get the data, so it is always better to develop a hierarchy of the data. Okay, a variable type hierarchy, it is better to have this one. That will give you a very clear picture of what kind of variables I have. So out of these variables, what kind of descriptive statistics methods that I can apply on them. For example, if I'm telling you, if I'm showing you the data of a product which is having different colors, then I might ask you a question, which color is coming out to be the most? Which color of this product is having the least? I don't ask you that what is the minimum value of this color, right? So similarly, whether the product is having a camera or not, I'm saying that yes or no. I'm not there. Can you find out the mean value of that one? No, right? So mean, median, all these things can apply to only quantitative variables, right? So that's what, whenever you perform any arithmetic operations on them, then we can call them as quantitative variables. Okay, whenever no arithmetic operations are not possible, when no two are possible, that means you cannot do any arithmetic operations, then it is called qualitative variable. All right, so again, in this quantitative variable we have two types of variables. One is the discrete variable, another is the continuous variable. Similarly, in the qualitative variable, okay, again you have two branches. One branch is that, okay, nominal variables. Nominal variables are those variables whenever I say male or female of any gender variable that has the values like male, female, then there is no grading, there is no grading or there is no ordering on these variables. Okay, whereas I say that, hey, my son got A grade in mathematics, B grade in physics, C grade in natural science. So when I say these grades, you are actually finding the relationships among these grades. Okay, like something like A grade is always greater or B grade is less than A grade, some kind of relationships that you are maintaining. For example, the same example, like whenever I say that my stock price, this particular company stock price is going very low, medium and high. So if I use these values to any variable, though it is qualitative, but we are actually maintaining the grades among the variables. All right. So here male female, female male, male female, there is no grade here. New York, Texas, or if I say Chicago, Seattle, so there is no such kind of grading is there, correct? So this is about the qualitative variable. And also, suppose in the ordinal variables there are chances of coming some numerical values. For example, this particular the customer who visited my site gave 5 stars. Okay, 5 stars grade. He provided a review, I mean to say. So 4 stars, 3 stars. So though it is a quantitative number, but it is still talking about the qualitative nature of it, right? 5, 4, 3, 2, 1 star ratings are still coming in under the ordinal variables. Okay, so which means that you cannot add uh, you cannot add 5 plus 4 here. You don't need to add. That shows that what is the nature of the or the kind of grading that it has been provided by the customer. All right. So my point here is that whenever you get the data, on this data, first build this hierarchy. This is the first and fundamental rule that you should follow, and that gives you very clear picture that what are my variables that I am having. If there are 300 variables, do that. Okay, just put all your qualitative variables here and nominal variables just put down here, put down at the bottom, discrete variables, continuous variables. Then on these continuous variables, whatever we discussed in the previous session, like mean, median, all these things can perform in a similar way here also. But on these quantitative variables only, you can do the mean, median, and all these things. Then you may ask the question that what will we do on these type of variables? On these type of variables, we can perform only least, highest, how many number of females are there, okay, how many number of unique values the particular value has. Gender will have number of unique values will be male and female too, okay. Whereas in continuous, number of unique values can be very high. If I start taking 2.1, 2.5, 3, 3, 7.5, so it is a continuous value, it's a curve, it's continuous curve. But here it is a kind of only unique values that you will have. That means the points you have. Okay, so now if we go back to our data and look at the data, and now if I'm start doing my data summary on this one, what I will do first, I will take the number of rows, number of columns. Customer names is my first variable, right? Customer names. So customer names, can I get min, max, or anything? First of all, why can't we build this hierarchy? Okay, I'm leaving this one as an assignment to all of you. Okay, as an assignment to all of you. I'm having name, color, memory size, dimensions, price, EMI value, number of sellers, type of screen, RAM size, dual SIM or not, resolution of the camera. So can you build a type of variable hierarchy? Okay, why don't you try yourself? That is a good exercise for you to really think through the type of variables. Okay, for now I'm going to show you the data summary here, and also this is also I'm leaving it to you for your assignment because I had already explained this example, right? So do this one, but I just want to give you some kind of directions. Okay, customer names, gender is male, female. I cannot find out min, max. Then for this variable, and names of the products, this variable and this variable, these are all non-numeric. I cannot perform any kind of, I know this is an assignment, okay, before you follow this session, better you work out yourself and then see whether you are matching to this discussion in terms of variable hierarchy. Okay, so now memory size. It seems to me that these are all some numerical variables. Okay, I'm just trying to make it as a numerical variables. Okay, and here dual sim yes or no, it is just like a nominal variable, non-numerical. Okay, I will put it like that, non-numerical. Okay, and resolution of the camera, again this is a numerical variable, right? So in on these things, okay, memory size, what is the minimum memory size, what is the maximum memory size, what is the mean memory size, what is the median, what is the standard deviation, so I can find out all these things, right? Similarly, if from this distribution also see that what is the mean absolute deviation, I want you to do this one as your assignment. Okay, on this data, I want you to do this one and find out what is the dispersion in the data and see that whether you can really communicate these values in simple English to any of your seniors or your colleagues or to anybody. Okay, but what I'm going to focus right now in the next session is how do we visualize these summary in terms of plots. Okay, in terms of plots would give you more visualization, more information. Obviously visualization will give you more easy description than something like all these numbers and everything, but it is the first good practice if you can really find out all these values, coefficient of skewness, coefficient of variation, variance, and mean absolute deviation for this data that I'm having. Not only for this data, any of the data that you may have. Okay, first do these operations and keep that with you as a reference throughout your statistical studies. This is also called a data dictionary. Okay, data dictionary means when instead of going and looking at the each and every data, if you go to this particular data summary, I will also call it data dictionary, you will have the complete information of the data variables, their distributions, means how they are actually mean, median, max, or varying. In fact, we are going to introduce the percentiles and everything. Okay, how they are actually varying, whether there is a skewness in the distribution. Skewness is nothing but how the mean and median are varying. So that is completely, that complete information is available in this particular data dictionary. So what are the applications of this data? Where exactly this data dictionary will be useful? If you have this data dictionary in hand, so in the future when you are going to build a machine learning model, or you are going to infer some kind of rules out of it, or you are going to take decisions, in those places these values would help you to see that whether your decision that you are actually taking is valid or not. So such kind of information would be available from this data dictionary. So I'm leaving this assignment to all of you. Okay, just to follow the same thing on this data.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
I'm going to ask this question: what is probability? Okay, so this is very common question that people generally ask. Okay, who is more interested in visiting my shop? What will be my inventory cost for the next festival, Diwali season? I'm going to put a lot of products so that people can buy them. So
What will be my inventory cost? Can you go and tell them that, okay, your inventory cost will be $20,000? No, you cannot come up with a very certain answers. And who is more interested? Here also, it is very difficult to capture the customer behaviors, and you cannot really give such kind of very certain answer. Okay, and also, what will be the airfare during the summer season? Okay, there are 8 mistakes in a page. How many mistakes you find in 200 pages book? Given the market conditions, what will be the share price of Facebook tomorrow? How many number of cars are having airbags on a given national highway during the weekend? So these are all questions that people may not have very certain answers. Okay, certainty here is that you will have a very high confidence in your answers. Okay, if you are having such a high certainty, then you can say that your probability, your confidence is very high, and the probability is almost close to 1. So if I look at any time, whenever we talk about probability, if I say that it is nothing but, okay, it is nothing but just it is nothing but the gradation from 0 to 1. 0 is that impossible event. Okay, impossible events are those events that will never happen. For example, I don't have any impossible events at this point of time, but yeah, in impossible events, something like okay, Obama becoming the president of India, that is an impossible event for me. Okay, so those are impossible events, and slowly you will actually talk about unlikely. Okay, please remember these words. Whenever people say that likely means very close to 1, unlikely means not very impossible, but yeah, chances are very less, like that. Okay, even chance means which is the 50% probability. Okay, if any of your friend asks you, okay, are you coming to the party tomorrow, you say that yeah, it is 50-50, because there are many kind of constraints you have in your mind, that you may have to go and attend some conference, you may have to meet your other friends, so you don't know. So since you don't know, you will actually give that, okay, it is a kind of 50-50. So whenever any kind of event is going to happen, so you should be able to term those events in terms of likely, unlikely, even chance, it is highly certain, it is completely uncertain. Okay, so highly certain, or it is impossible event. So in those ways you have to frame your questions. Suppose if you are an analytics person and your manager is asking, hey, tell me that tomorrow what is the probability that the number of customers visiting our coffee shop will be more than 200. So you tell that, okay, without calculating anything. What I mean by is that how many number of people were coming last week, before last week, last month, without calculating, without taking the data into consideration, you will say that, sir, very unlikely. So what I mean by here is that he is not using any data. Okay, not using any data, but based on his self, I won't use the word guess, self observation, he is actually telling that particular probability value, right? So we are going to cover what are those different types of probabilities in the later session. Okay, there are subjective probability. Okay, it is a person's belief. Empirical probability, which is nothing but he takes the data and talks about it. And then theoretical probability. Theoretical probability is mostly like I mentioned, right? Whatever the high school standards, we learned all these theoretical probabilities. Okay, which is nothing but actually you just say that how many ways that it can occur, which is something like how many satellite launches will be successful. So you don't have any kind of data, but you are going to predict some kind of theory. Theoretically, you are talking about, not something like based on the experience. I'm going to talk about it. But before that, we have to understand the sample space and events. So you may have observed that since beginning of this class, I have been using the word event, right? And all combinations, right? And some event and what is the possibility that particular event, right? So here sample space is nothing but which is actually having a kind of all possible combinations, and events is the one that you are more interested in. You're more interested in, what I mean by is that you are going to calculate that particular one. Okay, so for example, who is more interested in visiting my shop? Okay, the sample space is that there are many customers, C1, C2, C3, C4, C5, and like that. Then what is the event here? You have to define that event. Okay, you have to define the event. Event is the one that you are defining, and then you are calculating that particular probability based on that the event that you are more interested in. So E is an event where the customer with age range 18 to 35 visit my shop. Another event I can tell you, E is the event where the customers, okay, with customers who are males or customers who are females. So you are more interested in solving one particular, understanding one particular probability, that you will call it as an event. All right. So whenever I say that event, means that I'm more interested in finding out that particular probability. Okay. Now, what will be the airfare during the summer season? Okay, air ticket prices are there. Okay, if I'm taking that, that can be sample, it can be high, medium, low. These are the total possible set. Okay, and what is the event here? The event is an event where the prices are high. You wanted to know that how much the particular prices will be there. What is the probability that the prices will be very high during this particular summer? Okay. Similarly, there are 8 mistakes in a page. Okay, you are actually reviewing a book, and while reading those books, okay, so you found on an average 8 mistakes in a page. So now somebody comes and asks you how many mistakes you find in 200 pages. Okay, this is something like you have to estimate that. Okay, let us talk about the event. Okay, it is an M is an event where the number of mistakes in a page is even number. Okay, it is just, I made it up, but it is something like event is that, okay, events, the mistakes can be even number or odd number. So you are more interested in the even number. Similarly, given the last month's share prices, what will be the share price of Facebook tomorrow share prices? So the sample space will be share prices you are having. But what is the event here? T is an event. Okay, I'm just defining different words here. Don't worry about these words. Okay, it is an event where the share price is lifted by 2%. Okay, that is your more interested event. I wanted to know what are the chances that it will be lifted by 2%, or what are the cases where this is actually lifted. So something like that. Okay, and similarly, how many number of cars are having airbags on given national highway during the weekend? So cars are the sample space, C1, C2, C3. So K is an event where the cars are sedan type. So there are many possible different cars. Total number of cars are, let us say, 100. Okay, and during the weekend you found out, and how many of them are actually having airbags? And in event that you are more interested in sedan type, how many of them are actually, okay, are having the airbag? So what I'm trying to explain here is that these are some examples I provided. Whenever you are solving a problem, don't think that your boss is not asking you to solve the probability problem. Okay, when any problem that you are solving in the industry, means you can really formulate the problem in those terms. Your communication with your boss, your colleagues should be in such a way that you should define it. Okay, this is my sample space. I have taken this many event, and and this is the event I'm interested in. And many times I'm telling you, many people are taking the data And without understanding the problem in those terms, they will just go and solve the problem, and finally after 1 week, after 1 week of cycles, they'll come back and say, I didn't find any results. Why? Because you did not really understand the problem. Okay, maybe for example, this is the one. The cars are sedan type. Did you see that how many sedan types are there here? If there are only one sedan type, okay, then the probability will come out to be very less. In the similar fashion, whenever you are solving any problem, you should completely understand the complete sample space, and you have to define your own events first, and then you jump into solving the problem, whatever the problem that you are going to solve. Without doing these steps, if you are solving the problem, then I would say that we are wasting time. Okay, so now going back to the three approaches to probability, as I told you, right? One is subjective probability, which is a person's belief. My belief that Hillary Clinton wins these elections is different from your belief. Here, I and you are not using any data, but we are using our previous experiences or readings from the newspapers, news channels, and all these. Based on that, I'm coming with some belief that this is the value, that particular probability that Hillary Clinton would win. It varies from person to person. Okay, I would say that there is a high probability that Messi would come back. You would say that no, he would not come back because he is imprisoned. Okay, and there is something like a big project is there, and the revenue is coming out to be something like $300 million. Now, given the chances that that particular probability is success is less than 20%, okay, I mean to say it is going to fail. 20% means 80% chances that it is going to fail, but the revenue is coming out to be $300 million. Then will you take up the project? So your personal belief tells you that should I really take this project or not? How many chances that my career would go up, okay, if I take this project? So these are all subjective probabilities. Okay, so as we go down, I'm going to teach you that how we can introduce these subjective probability values in solving your problems. And second is empirical probability. Empirical probability is nothing but you conduct the experiments and then you calculate the probability. You conduct the experiments. If I'm throwing a dice, or if I'm catching a bus or catching a metro, how many times am I going to miss? So you calculate the data. Okay, for example, Sachin made more than 8 centuries against Australia. What is the probability that he would make century in today's match against Australia? Here I have the data of that particular cricket player Sachin who made centuries. Okay, so now based on that I'm going to calculate the probability. Now coming to the theoretical probability, here you are not conducting any experiment. Here it is not your personal beliefs. It is something like theory, you would say that. Okay, if I want to catch this train, okay, what is the probability that I'm going to catch the train or miss the train? Then you will actually calculate where am I staying, how many times, what are the possible chances that you would go, can I catch the train? So you will take all those possible combinations and then you will tell the probability. There you are not empirically, you are calculating the data. You're not actually telling the subject that, oh yeah, I can catch the train with 80%. That is completely without calculating data. From your personal belief, you're telling that is subjective probability. If you're collecting the data every day and you're doing and calculating them, that is empirical probability. If you're just calculating just like a mathematics that, okay, this is the chance, this is the chance, this is the chance, then that is called theoretical probability. Okay, so whenever you are calculating any probability problems, working on probability problems, first you have to really define that whether that person is talking about subjective probability, empirical probability, or theoretical probability. Many of our discussions that happen in industry are subjective probabilities. Okay, which is something like experts talk about these things. Experts, subject matter experts, based on their 20 years or 30 years of experience, they would say that this is something like going to happen. But that particular era is going to be changed with the data is arriving into our servers. Okay, like, which means that we are getting more data, that is we are having more empirical results, the real values we are having. So industries are actually using both SMEs and empirical probabilities and then getting the most powerful insights in terms of business decisions. Okay, theoretical probability, of course, it is something like you don't have the data, you don't have subject matter experts, and you will just calculate this.
And how we are actually going to use this Bayesian theorem in any of our practical applications. So how many of us are having a very basic fundamentals of probability? What I mean by basic fundamentals of probability here means um, we have done a lot of probability courses during our elementary school level, right? During that period of time, we know how to calculate a simple probability. For example, the common example that we generally take in this one is that, okay, there is a dice, and when I throw this one, what is the probability that I will get even number, or what is the probability that I get some number? So you will find out all the possible chances, and then you calculate the probability. So this is what I mean by elementary level of probability. But in practical applications, whenever you are solving a problem where you are having lots of data and you wanted to really understand the relationships among the variables, that we generally cover how exactly the two variables are related, you wanted to, or two events, I will put it, okay, in the probability terms. I really don't want to make it very technical. I just want to give you a very simple example so that let us understand how exactly uh, these concepts of probability we can use it in the real practical applications. Okay, yeah. Now coming back to this one, yeah, there is a relationship between two events or two variables you wanted to find out. Let us say um, uh, Max or Thomas came to the office very late. So when the manager asked him, okay, what is the reason for his arrival coming late? So he said that it's a traffic. Okay, so traffic is an event that made Thomas to reach the office late. Okay, and that event is causing another event to come late. So if I take two variables here, coming late or not, whether there is a traffic or not, if there is a relationship you wanted to understand, okay, traffic always causes the persons to come late. So if you understand the relationship between these two variables, like traffic and coming late, are two variables, so you wanted to find out one variable how it is causing the other variable to act upon. Similarly, in any e-commerce application, you wanted to see that a particular product has been really sold very well, which means, for example, a cell phone has been sold very well. So what is the reason behind that particular activity? You wanted to understand that the sales are growing up very well, high. You wanted to find out the cause behind it. Is there any other variable which is impacting? Is it just because of my salespeople performance, or is it just because I put the right element at the right amount of time, or right pricing? Or you want to find out what is the relationship between the pricing of the product and the sales of the product. You wanted to understand the relationship among them, right? So in those kinds of relationships, generally how we approach, if I approach just a common thinker, I approach this problem is, okay, let us see how many products had been sold, okay, when I was, how many, means how my sales were there when the product price was, let us say, $100, and how the product is, the sales are changing when my product price is, let us say, $25. So there is a change in this particular variable, how my sales are actually getting affected. So you want to find out these relationships, the associations you want to find out, okay, between the variables you want to find out these associations. When you want to find out these relationships, okay, we find out, okay, whether it is dependent, independent, that is a different story, where we had conducted chi-square test, and using the chi-square test we found out the relationships.
There we were just finding out the relationship, okay? But here we wanted to find out the relationship in quantitative terms. How much? That is the answer that we are going to answer here. How much? Okay, whether in the chi-square test we are trying to find out whether there is a relationship or not, dependent, independent. It's a binary answer. But here we are trying to find out how much it is actually getting affected. If it is raining, how much my traffic in this particular city is going to change. Okay, if it is drizzling, then maybe different. If it is heavy rain, then that is the traffic is different. So is there any relationship between them? That is the chi-square test we use. So are you with me, guys? So what I'm trying to say here is that this particular probability, until now, until elementary level, we have been using it in the form of like just understanding, okay, events. But as we are started going to use this one in the applications of our industry problems, we use it not only one particular variable, we will find out the relationship among different set of variables. Okay, now here what I'm trying to cover here is that how these Bayesian rules can be applied. Okay, so that is what the main focus of this session. Let us review some probability rules before you jump onto this Bayesian thing or any Bayesian rules or Bayesian theorem. Let us talk about first question. Do we know what is contingency table? If not, let us review that. Okay, what is a contingency table? To determine whether two categorical variables are related, we generally okay, any one particular variable, categorical variable, you want to see that profile and so the distribution of it. You see how many number of unique levels are there, that frequency distribution is different. Now we are going to use this contingency table, okay, not only for 2 dimensions here, okay, to find out 2 variables. You can use for 3 variables also, 4 variables also, 5 variables also. So that is called k-way tables. Okay, the 2-way, 3-way, 4-way, 5-way, 6-way, which means 6-way means I'm going to find out the relationships of the 6 variables at a time. I want to put it in one particular 6-dimensional table to see that how much this variable is going to affect. So very simple example I can give you here is that, for example, your manager is asking you to find out the patterns in the data. Okay, then almost all of the variables are categorical variables, which means that one variable is gender, other variable is city, second variable is city, third variable is let us say the product price, okay, the number of products they had purchased, and fifth one is that whether he is student or employee, something like that. So you wanted to know that how many students are males, okay, coming from one particular city, let us say New York, how many products they had purchased. This is one question. And you wanted to know that tomorrow if you want to um, project or predict your sales or anything, okay, does the gender is having any effect on the sales? Does the place has any effect on the sales? Does the the type of employment, like if student or employee is having effect on the sales? So you wanted to know all these answers. If you know all these answers, then you will be able to easily answer. You will be able to come up with a insight that yes, I should not project this particular product for this particular segment. I mean to say students are not interested in this product. Employees are more interested in EMIs to purchase some products. So in order to come up all these things, you have to build a kind of a table that gives you all these insights. But the question here is that, is it really possible to visualize that 6-dimensional or 60-dimensional or 6,000 dimension or 1,000-dimensional contingency table? Yes, it's very difficult. That's why we are having a lot of algorithms. So generally that comes under part of a machine learning course, where we will find out how do we handle such kind of high dimensional tables. Not only handling, it's not handling, it is more of finding out the relationships. Okay, these algorithms would help us to find out those relationships those are related among the variables, and you can give you the better insights. That is what. But anyways, beyond going to that high standard of machine learning or anything, I just wanted to first get the idea of a basic contingency table. If you are able to understand this contingency table and calculating the probabilities, applying the Bayesian rules on that, you would be able to easily visualize how we can do the same operation at the higher level. All right. So we know this contingency table. You got the picture on it, right? So what do you learn from this contingency table? In this contingency table, we learn all the conditional probabilities. Okay, I'll give you the complete details of it. And then it also we have to understand that product and addition rules, what exactly that these rules, how exactly can we use these rules, and also we will cover here. Okay, so most of you know that, right? Product rule can be used trying to probability that both the events occur, means A and B, event A and event B, which is something like students and coming from New York. Okay, both the events occur. So your question tells that I want to know the sales for the students and they are coming from New York. Okay, another question is that I want to find out the sales for students, okay, are coming from New York, something like that. So that is the addition rule that you. So try to understand the difference and or. Okay, based on that you get these probabilities. Okay, and what is basic rule? Okay, so if I talk about Bayesian, okay, this is actually I'm leaving it to you. This particular question, how Bayesian statistics or Bayesian rules are different from frequentist approach. Again, I'm repeating this question. This is something like out of your curiosity. If you are interested to know the complete history of these Bayesian rules, I'm asking this question: how Bayesian statistics is different from frequentist approach? Okay, search it out and understand how exactly this is different. Okay, just to for those people to just give to get some kind of basic fundamental answer here is that Bayesian thing always, okay, have some prior information. Okay, so that is how you start your Bayesian approaches. Okay, I'm a little bit digressing from the topic, but I just wanted to spend only 1 minute on this here. Okay, let us say there is something like we all humans means we all had developed some kind of understanding about this world, right? What I mean by understanding this world is that uh, you you easily know that whenever Sachin Tendulkar plays cricket, okay, in Indian cricket, you always think that India wins, right? That is the confidence that since childhood I had built up, such kind of some kind of probability of winning India whenever Sachin plays. Okay, this is something like that. Okay, or I have some kind of prior information about Narendra Modi, the Prime Minister of India, implementing a policy in our economy or for economic stability. So we have all some kind of a prior information, right? So that prior information we can easily say that yeah, India will win. Yeah, Messi will resign. Yeah, Messi will come back. So you have some kind of prior information with all of us. So this is called prior probabilities. We are having some prior information. Okay, as you start getting more and more information, okay, the probability of that particular event happening is going to change. Okay, that is what the main idea behind it. Anyways, I will go and cover all these things, but do not worry about things. I'm going to cover all those things. So let me first explain you what is contingency table. Okay, so a contingency table provides a different way of calculating probabilities. Okay, this we have already seen in chi-square session. Okay, and but here I just wanted to explain you from the probability point of view more. There I was actually
explaining it more from the statistical point of view here. Okay, so the table helps in determining conditional probabilities quite easily. You must be having a question here. We all got the idea of what is conditional table, but what are these conditional probabilities? Okay, so as I told you, okay, for example, I met you and said, hey, today there is a match against Pakistan in India, cricket match I'm talking about, and the probability of India winning based on my previous experience is 7 out of 10. Means it wins. Okay, so I mean to say 7 out of 10 is 70 out of 100, 70%. Wow, that this is something like an information I have. Now immediately I came to know that during my discussions, Virat Kohli is playing that match. Then I apply the condition like that. Then what is the probability that India wins given that Virat Kohli is playing, or he's actually Virat Kohli is playing? So what is the probability of India winning is my just India winning. That is the information, first level information I had. Now, given the condition that Virat Kohli is playing or is not playing, that gives me another level of information. In order to know that one, you should know what is the probability of Virat Kohli that he is actually making good runs, or some information you have to know about it, right? So here I wanted to explain the condition probability very easily. That conditional probability is the one when you apply that condition, what is the probability that you would get? Okay, so let us take this simple example. Here I am showing you, okay, there is a data that I have taken from somewhere in the internet, and this data is actually showing that people who are using the for car phone user and how many people got this speeding violation. Okay, I just wanted to find out the relationship between this variable, speed violation, and car phone users. Okay, this is one variable, and within this variable these are the labels. Okay, we have discussed the labels, right? Which means that if I say city is a variable where New York, Chicago, Atlanta, okay, Sunnyvale, all these places are coming out to be like labels, values of that variable, right? So similarly here, car phone user is one variable. In that, car phone user, not a car phone user, are the labels. Here, speeding violation is my variable, and how many of them are actually violating and not violating, yes or no, yes or no. Okay, so these are the values. So these are the actually independent variables that I'm getting, and I wanted to find out the relationship among them. Okay, so which is a relationship among them. I'm not trying to find out, okay, it's kind of finding out the relationship among them. So now you want to know that how many car phone users in the last year who actually violated this one, which is coming out to be 25. So I'm trying to find out the number of people who are doing end operation, not speed car phone users, no speed violation is coming out to be like this. And similarly the same thing, when you add them, this particular 305, which is showing the people who are using the car phone, means car phone user means people who are using the phone while driving the car. Okay, and 450 people are not using the car phone. Are you with me? So if somebody comes and asks you, okay, hey, tell me, what is that particular number of phone users, car phone users are there? Then you will say 305, right? Now somebody comes and tells that, hey, who are the people who are using the car phone user and violating the speed? That means this particular thing, which means this and this, which is joining here. Okay, this is the value. If my question is that how many people who are using the phone in the car and not violated the speeding, okay, this is the one. Similarly, not using the phone, but they are not using the phone, but they violated the speed limit, which is like this. Okay, so this is something like this total, this total. When you do this total, this is the total number of people or the observations that I'm having. Now, out of this table, I'm going to explain different types of probabilities. Okay, before go to this table, can we do this quiz quickly? Okay, do this quiz by yourself. Okay, and let me know if you can build this contingency table. You will get the complete idea of what exactly I'm talking about. Now, here in this quiz, problem 1 is that completing the table, and problem 2 is that, okay, if f is the female and this is something, this is another example, not the previous example. This is another example. So here it is the preferring the coastline and female. Okay, now I'm going to ask the question here is that what is probability of female and preferring the coastline? Okay, see if you can answer this one by yourself before going to the next session. Okay, please try that one. Similarly, this one. Okay, here, okay, find out how these numbers are coming and what is your understanding in terms of dependency independence. Okay, similarly, I'm giving you all these different quizzes, and please go through them. I'm sure you will get the complete idea in the if you make mistake, don't worry. So once you have this table, okay, once you have this table, you are going to, okay, let me show you a simple example before go to this one. Okay, practical table. Let's say this is something like a very simple contingency table I have taken. Okay, these are the people I'm taking, right? Now I'm going to calculate the joint probability. What is the joint probability? Joint probability is the one which is having this, okay, this and this. Okay, for example, let me highlight this one, this, and this value is a joint probability. Okay, first of all, how I came to these numbers, I came to those numbers. These are the 20, right? Let me highlight this area first so that you can easily, these are the numbers I got, and this is the total, correct? This is the total and this is the total. Okay, the overall total is 94. So in this contingency table, what I'm going to do is that I want to find out what is the probability of people coming from Maine who are from New York. That is nothing but the total candidates I have 94, which is nothing but 20 by 94. This is that value. Okay, C3 by this is that value, and similar, this is the joint probability I'm getting here. Okay, the complete joint probability of all the values will be equal to 1. Okay, don't worry about how this is and everything, just try to understand the concept here. It will be very easy for all of us. And if I ask the question that people who are coming from Chicago and those are males, which is nothing but 40 by 94, can you tell me out of all these 4 values which probability is more? People who are coming from male or coming from Chicago and who are males. Okay, I'm just taking an example to a shop or anything. Okay, I'm not worrying about it, just I'm having these 2 variables. Now this is what the joint probability. If I go back here, these are the actual values, and now I want to just find out the joint probability is nothing but a by the total that I'm actually taking. Okay, so that is what practically this is what it is showing here. Okay, similarly we are getting here. Okay, now by looking at this one, if I ask you the question, what is the probability of the people, okay, listen to my question, what is the probability of the people who are coming from New York? Okay, that means this whole thing. Okay, in my question I don't have anything. Okay, let me write down here, what is the probability of the people who are coming from New York? Okay, I did not mention whether male or female. Then it is only this particular thing I'm asking, which is nothing but this value. So let me write down here, which is nothing but this value, right? If I ask you the question, is the probability of the people who are female? What is the answer then? I'm not asking any question here, right? Anything related to that particular location or anything. So which is nothing but this value. This value is this, right? And another question, just to make up your own questions to understand better this one. So what is the probability of the people who are coming from Chicago and those are females? Okay, here did you observe? I'm using and. Okay, let me highlight that one. Okay, and that means Chicago and female, which is nothing but this value. Okay, see, whenever I say and, which is a joint distribution. Now I'm going to talk about the conditional probability. Okay, conditional probabilities is nothing but given the condition. Okay, and is different and conditional. Let us go through that. Don't worry about it. I'm going to explain that very well. Okay, conditional probability. Conditional probability is nothing but, okay, whenever I say that what is the probability of people who are males given the condition that they are from New York? Okay, let me write down the question. Okay, here I'm not using any AND operator. Please remember, please look at this. I'm not using any AND operator. Given the condition, okay, given the condition that they are New York, you know the probability of New York. And now what I'm asking is that, okay, you know the probability of the males, right? The probability of the males is 0.638298. Now, what is the probability of the males given that they are coming from New York? Okay, here I'm going to talk about the Bayesian rules. Okay, how do I calculate this one is the main thing in the Bayesian rules. In the Bayesian rules, what we are going to do here is that I want to know, okay, what is the probability of the males? Okay, that means I just want to know the joint distribution of these two things. Those are the people who are coming from male and New York. Okay, and then I want to calculate what is the probability that, and the given condition is that they are from New York. Are you getting me? Again, don't get confused. I'm going to explain it again. Probability of males, let me read this. I'm starting again. What is the probability of males given the condition that they are from New York? Let us forget about this. Just try to see that what is the probability of people coming from New York? This one. This one. Right? Now, what I'm asking here is that here there are something like from New York, both males and females are coming. But my question is that if I ask you this question, what is the probability that the people are coming from New York? I can simply answer this. Very straightforward, right? But if I look at this thing, what is the probability of males coming from New York, given the condition from New York?
So here I have calculated this probability, joint probability on the overall population. But here I have to calculate the overall this probability only with respect to this particular one. Given the condition, it is only from New York. I don't care about all these things. So there are 20 people, right? And out of 36, 20 people are coming from New York. 16 people are coming from New York. So I just worry about this. The conditional operator always neglects the other things and just focuses only on this one. Okay, if it is Chicago, then you focus on this one. So now this is my total population. Now 20 by 36, that is nothing but 0.5. Okay, is the males who are coming from probability of males coming from New York. Given the condition, they are coming New York. Females is 0.44 New York. So this is the total one. Are you guys with me? Now the answer is that probability of that one, males given the condition that they are New York, just this is the condition first I have to remember. Then my whole probability distribution will be only this variable, because that is the condition I'm applying on that. On that condition I will just calculate this one, right? So this will be like, so why this is not coming out to be 1, why it is coming out to be 1 here? Because in this one we are actually, the population is only within this condition New York. Okay, it is something like this. I want to give this particular coupon to those people who have purchased my product more than 2000 in this year. So I'm applying a condition. As a manager, I'm applying a condition. When I'm applying a condition, I do not worry about other population members who are not satisfying that condition, right? Similarly here, I am actually applying that condition and trying to find out here. So the conditional probability of the gender given that city, this is what, right? That's what I'm calculating. Similarly, given the city, that is Chicago, what is the probability of male? 0.68, which means that people who are coming, I'm just only focusing on the people who are coming from New York and want to know that what is the distribution of the male and female. If you look at the joint probabilities, and Chicago males are coming out to be more, right? But here, if you take the overall population, let us see if I change it to, let us say 38, for example. Okay, if I'm making it 38, almost very close to the this one, right? So then overall population is overall joint probability is almost like this. Okay, let me take one more example. Maybe I'll take here 40. Okay, so here females are from New York are coming out to be more, but here with respect to the New York, this is only point, this is actually dominating more, and with respect to the overall probability, this is actually coming out to be less, right? So similarly, conditional probability of city given gender, my condition here is that, let me write down here. Okay, what is the probability of, okay, what should be my sentence? What is the probability of people coming from Chicago, or I will write down, okay, New York, given the condition that they are male. Okay, here my condition is male, so what should I do? I should only focus on the males row, right? That is males row. I should not focus on this row at all, correct? So now this is, if I want to find out 20 by 60 is New York males, okay, 40 by 60 Chicago. Okay, I do not worry about female one. That is what, see here I'm doing C3 by E3, C3 is nothing but this by this. Okay, so now that is how you are going to calculate the conditional probability city given the gender, gender given the city. Is that clear, the difference one? Okay, so first of all, here also I will just, okay, given the condition, okay, if I say anything like and, then that is a joint probability. If I'm giving this one, then it is. Then there are some more concepts I'm going to talk about here. Okay, those are like, what are marginal probabilities?
Marginal probabilities are that just now I told you, okay, I'm just what I told you, all these males are coming out, okay, sorry, all these males are coming out here, okay, only males 0.5 with respect to the whole distribution, my friends, don't get confused. With respect to the whole distribution, this is the joint distribution, this is the conditional table, conditional probability table. These are also called CPTs, conditional probability tables. Okay, joint distribution is nothing but this particular male with respect to the whole population, how much is this? With respect to this one, how much is this? Okay, sorry. Uh, uh, Marginal probability is only with respect to the joint probability tables. Similarly here. So this is the marginal probability of the people who are coming from New York. This is the marginal probability of the people who are coming from Chicago. This is the marginal probability of the people who are males. This is the marginal probability of the people who are females. Okay, and this can be applied for any problem, let us say, and this is something like mortgage loan, paid or not, and this is their credit card report or something. You can create these continuous tables on any other table like this. So if you actually calculate all these things, okay, you will completely understand what exactly is considered. So if this is clear to all of us, then I can tell you the relationship how I can tell you the Bayesian rule. In very simple, Bayesian rule is, excuse me, is nothing but this gender given probability of gender given city is equal to probability of city given gender. This is what Bayesian rule. Let me go through this.
Let's have a quick quiz question, guys, and the question is, which of the following clustering algorithms is based on the concept of density? And your options are k-means, hierarchical clustering, DBA scan, or agglomerative clustering. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Okay, anyways, I'm actually going to repeat the same thing here. Okay, we understood the joint probability, and this is the example we had done. Okay, joint probability is the overall distribution, right? And marginal probability on the joint probability table, whatever I just find out, New York people, okay, Chicago people, this is called joint probability of this one. Similarly, joint probability of male, this is the one that I had explained. It is very clear. So independent events, yes, this is something very interesting. Independent events, we have done that, right? So in independent events, that means there is no relationship. That's what in chi-square test also we have done, right? If there is no relationship between two events, then you say that yes, Narendra Modi is the prime minister. Visiting a cricket match anyway depends upon winning of the match against Pakistan or South Africa or Australia. So what is the probability of winning a match given the condition that Narendra Modi is watching that match live? Okay, means live means in the stadium. So is there any dependency relationship? So in those cases, the probability of winning that particular match, let's say B is the event, okay, where Narendra Modi is watching that particular cricket match live, and what is the probability of winning that A is completely independent. That means they are not related. So in that case, what is the probability of winning the cricket match is only probability of winning in the match, right? So there is no dependency relationship. That in that case, we call them the that is something like, okay, whenever a conditional probability that you are applying, okay, that even after applying that condition, the probability of that particular event does not change. That's what it means, nothing else. So which is nothing but that is the probability of one event is not affected by the occurrence of the other event. Okay, whether I go to the office or not does not depend on Sachin Tendulkar playing a cricket. I'm an employee. I'm just doing my job. I'm not a cricket player. So it does not depend
anything until unless he is my relative or something related to each other, or he dashes my car during the car accident. I don't know. I'm just making up all these examples. But my point is that here, whenever you are trying to find out the relationship between the events, so you generally apply these conditions, and if the problem is coming out to be the same, then those are not dependent. Well, so we are going to cover the Bayesian theorem here. Okay, so Bayesian theorem is nothing but the relationship between the probability of relationship between, okay, if it is not equal to, it is something like relationship between probability of A given the condition B, okay, and probability of B given the condition A. So which is nothing but, let me write down here. Okay, I'm writing the Bayesian theorem here. Okay, see, this Bayesian theorem is going to use in Bayesian networks. Okay, that is actually interact with lots of many variables. Let me just figure it out with respect to the two variables. So the probability of gender given the condition that city, okay, is equal to probability of city given the gender, okay, the relationship, okay, into probability of city, okay, okay, let me put it this way perhaps. Yeah, okay, okay, and probability that is nothing but a P of gender given city, okay, okay, probability of, I think here city, sorry, this is confusing for me. Why is it confusing me more? I'm getting confused. Is that right, my friend? Yes, or I can put it like this also. Probability of gender given city into probability of city equal to probability of city given probability of city given, okay, probability of city given the gender into probability of gender. Okay, this is what the Bayesian rule, which is nothing but the relationship between this contingency table CPT, and this CPT means conditional probability table, and this conditional probability table. But the same thing I'm going to explain using a very easiest way by using a trees. Okay, that is what this Bayesian tree. Okay, here probability of F and probability of E, okay, or something like another two events. We can take it something like two events, okay, two events, and let me copy this one. It's easy and quick for me. So if it is something like, if I'm taking, okay, this is like E, okay, event E, and this is something like some F, okay, this is yes and this is no, okay, this is yes and this is no, something like this. This is another event, these are two events I'm taking, okay. So probability of F given E and probability of E given F, all those things we are going to learn with this particular tree. So this is something like I can take a probability of gender or a probability of city or a probability of F, probability of E, anything, okay, fail or boys, girls, or accidents, not accidents, mortgage plan, payments, any event I'm taking, okay. So now what I'm going to explain here is that this is the probability of event yes, probability of event no, okay, that is what F and F dash. Here this event is, okay, occurring given the condition that this is happening. Here this event is not occurring, that means not occurring given the condition F. So we have to calculate these values, okay. Similarly, E, probability of event E occurring when F is not occurring, E not occurring and F is also given the condition that F is also not occurring. So an example here is that what is the probability of India winning given that Narendra Modi is watching the live, okay, cricket live in the stadium. What is the probability of event E occurring, E not occurring, means India not winning the match when Narendra Modi is watching the cricket in the stadium? What is the probability of event E occurring, okay, when Narendra Modi is not watching, when India is not winning the match, when Narendra Modi is not watching? Or I can put it something like this. What is the probability of another example? This is another example. I'm trying to give more examples so that I want you to really think about it. Okay, what is the probability of India is winning the cricket when Kohli is playing the match? When India is not winning, when Kohli is playing the cricket, given the condition, okay? When India is winning, when Kohli is not playing, India is losing when Kohli is not playing. So you have, if you have all these kinds of probabilities, the values, and it can be many, my friends, if it is having many kinds of values, not only yes or no, it is something like a city, this can be New York, this can be Chicago, this can be Atlanta, like that you can get many trees. So this tree is going to help you to answer many questions. Then my question here is that first question I'm going to ask you, what is the probability of E, okay, given the condition F? I want to calculate this one. How do I calculate this one? How do I calculate this one? This condition probability. Very simple. We go to this contingency table, and here we know that, right? Right, given that condition it is city, right? This by this by this, right? So you know how to calculate this one, and these values you will get it, okay? These are clear probabilities anyways. These probabilities you will anyway get that one, correct? So now let us see, okay? So which is nothing but, okay, how do I calculate this one, this particular one? This into this. These are the two events, those are happening, right? Okay, those are happening, two events. Then probability of, this is the chain rule that we apply, right, that we already discussed. So probability of F into probability of E given F, okay, this is nothing but this, okay? Then this is not, and this one nothing but this into this, that is this value. Similarly, this into this. How this into this is happening? Can somebody answer? That is what Bayesian rule. Okay, that is what Bayesian rule. Bayesian rule is nothing but probability of E given intersection F is probability of F into probability of E given F. And what is the, how do you define this one? Probability of E given F, right? Into F. How do you calculate this one? This is the joint probability. This is the condition probability. So if you have this value, or if you don't know this value, if you know these values, you can calculate, correct? Anyways, with an example it will become more clear. Let us just complete these things, okay? Now if I want to know that conditional probability, which is nothing but joint probability by that particular probability of the event P of E. So let us just understand this one. Probability of F given E is joint probability by probability of E, or I can put it like probability of E given F is probability of F intersection E and probability of F. So can I write it down something like this? Let me write it down here. Maybe if it is confusing, don't get confused. Okay, I'm writing it here from the same equation. Okay, probability of E given F is equal to probability of E, I would write it like this, okay, divided by probability of F. Probability of F given E equal to probability E and F probability of E. In this case, the same thing we have done, okay? Probability of this one. Suppose if I want to make it this one, I will come to this particular form. Just watch here. Probability of E given E given F, okay, into probability of F, probability of F given E into probability of E. Can I derive this one? Because E and F I'm just equaling that, then I'm getting this. Nothing but this is the Bayesian theorem. Is that clear? Right? So whenever I want to calculate a probability of E and F, if I know the joint distribution and if I know this one, I can get that. Okay, that is what here. Okay, probability of E given F, okay, is nothing but probability of E given F is probability of E and F by probability of F. And if you want to know that probability of E and F, then you can do this. Okay, is that clear? Now, if I want to, from this tree, if I want to calculate probability of F given E, which is nothing but probability of F intersection E by probability of E, okay, what is this probability of E? Which means where exactly this event E is S. That is what, there is no complementary sign here. Where is that it is happening? It is happening, this particular India is winning the match given the condition that Kohli is playing, and India is winning the match when Kohli is not playing. So there are two probabilities of probability of E is coming. So or this or this. That is what here it is given. Okay, which is nothing but probability of E is nothing but, see, this is the probability of E, right? This probability of E is happening when E and F dash, E and F, two places it is happening. Am I right or not? You just observe this. E is happening. E is happening. Correct? So E and F dash and E and F. So these are all two OR events, not AND events. Okay, that's why we are adding them here. Since you know these joint probabilities, you can easily know that probability F into probability of E given F. Okay, it is nothing but the same thing we have discussed, right? Probability of F is F given E. Okay, and the probability of F dash, this one, F dash and E, this one. Yeah, this is the rule. Here it is the one. Similarly, F and E, this one, probability of F, okay, given probability of E given F. Is that clear? So this is how you calculate the probability of F given E. It looks very, I know, I'm sure you people, many of you definitely must have got confused. In order to alleviate that confusion, just draw this tree by your hand on a white paper. Don't just try to understand by looking at it. Maybe we can try with an example. I'm sure this time you will be very clear. Okay. So the problem here is that, okay, there are number of mortgages. Okay, there are number of mortgages and their default values. Okay, 5%, 10%, 20%, 25%. Okay, so what is the probability of 5%? This is something like the values that we have taken. I'm just directly giving you this example. Okay, and this is 5% you are calculating, getting it. Okay, then whether he defaults or doesn't default. Okay, default or doesn't default. I have given this complete example for you guys. You have to just put it on your pen and paper and try to understand this one. Okay, what is the probability of default given that, okay, he has we have only 5% of mortgages? What is the probability of not default? We have the only 5% of no mortgages. Okay, so if I want to see that, okay, what is the probability of 5% given the condition that he is defaulting, D for defaulting. So the defaulting is occurring in many places, right? So I want to add up all these things at the bottom, and I just wanted to know that what is the probability of 5%, okay, given that he is defaulting. This is what I wanted to know. Okay, then it is nothing but 0.225 by this one. Okay, similarly
probability of 10% is not defaulting all these values, which is nothing but probability of not defaulting is, okay, sorry, probability of not defaulting is these values. Okay, we are taking these values. Okay, this is something like goes to the bottom. And what is the probability of 10% given that is nothing but this value? So 0.2425 by the wherever the probability of d dash is occurring, we are going to take. So now this is the question. Okay, this is a quiz question to all of you. Okay, there is something like probability of okay, let us consider that A, B, C, D are different sections. Okay, so you wanted to see that whether that particular teacher is teaching that particular class very well and what is their fail. Okay, so teacher, you just want to know the effect of the teacher on the pass and fail of the students. If you want to know that, you know what is the probability of that particular teacher, okay, who is actually uh, doing his performances before or anything, just like I mentioned, right? You have some knowledge, based on that you calculated. So you calculate that one. Okay, and now you wanted to know that what is the probability of pass given that teacher A is teaching. What is the probability that, okay, the teacher is actually failing given that the teacher A in the section, I mean to say A, B, C, D or sections, this particular given from this section, or the teacher is teaching. So you have the complete the probability values, and you wanted to know that who is actually doing better. So my questions are that what is the probability that a student will pass the class? Okay, what is the probability that a student will pass the class if he or she is from section D? Okay, that means this. Okay, he is from section D. So section pass means this. Where exactly the pass is happening, that will go to the bottom. Okay, again, what is the probability the student passes if she is section D? I think I'm repeating the same thing, I guess, right? Okay, absolutely. Okay, maybe you can put it something like section C. Okay. Okay, so you just try to understand, okay, how you are going to calculate these Bayesian things by using this one. If you people are very clear about how to calculate all these things, you can simply go for the Bayesian networks, and there you can find out many conditional independent dependent events and then calculate the probabilities. Okay, sampling distribution. So generally, whenever you get a complete population like this, and consider that you got a big data problem, and the data is very huge, the number of customers who are actually coming to your e-commerce website is obviously in terms of millions, okay, for a very big website. So if you really want to conduct some kind of study on some set of customers, or you study, what I mean by is that in other words, it is a statistical study, or you want to get some insights out of that person, out of that particular set of customers. So you cannot actually pick up all the customers because it is a huge data, and if you really want to do some kind of statistical study on that data, it requires a lot of time, energy, man hours and all these things. So you cannot take all these things, so you just take some sample out of it. So taking the sample out of it depends upon the nature of the kind of study that you are actually going to do. What I mean by here is that if that depends upon the kind of population. First of all, I want to cover that first. The kind of population here, the population is actually completely having boundaries, closed boundaries, which means that if you are performing some kind of fertilizer on some set of agricultural plants, let us say, you want to see that whether that particular fertilizer is actually helping it to really increase your productivity or anything. So you have to apply that fertilizer, and you have to wait for a few weeks, and then you will get the results out of it, correct? And because you cannot also test the fertilizer directly on the agricultural lands, and you may get some kind of bad results out of it also. So all these plants might die. Okay, So some kind of studies which is completely costly, what you do is that there the aggregate land that you are considering is fixed, which is not going to change. Means the population of those plants that you are considering is fixed, which is having a closed boundary. Whereas if you are actually trying to conduct a similar study of customers visiting your store, or the cars, the number of accidents happening on any national highway, there you do not know the right exact number of the population of the cars those are actually coming, or accidents those are going to happen. So that is completely unbounded. Okay. So first of all, whenever you are trying to conduct this study, you have to know that whether this is actually completely bounded or unbounded. If it is bounded, then half of your problem is solved, and you have to just take the sample out of it. Once you take the sample out of it, you are going to perform some kind of studies on that sample only, okay, not on the complete population, right? So how can you take this sample? You can say that I can take this sample without using any criteria, which is randomly I'm going to pick up. So which is something like, I will give you an example. Okay, in brewery system, like beer manufacturing or any assembly of engines manufacturing, all these engines start moving on the trail. You pick up some of the things, just randomly you pick it up. You want to see that whether this engine is perfectly good or not, or whether this particular brewery, this particular beer is having the right chemical composition or not. You randomly pick up anything. And if you pick up any sample randomly and you perform some studies on that, which is something like this, I can tell you the best example. Recently, Maggi has been banned. So there, what they did, instead of doing the complete study on the all sets of Maggies, they randomly went to different stores and picked up some Maggi packets from there. And they had done the study. Okay, they found in some lead percentage is there. So all these studies, whatever they are doing, they just blindly do not go and tell that, okay, this is having this amount of lead, so we have to ban it. No, nobody accepts it. They will have to prove that out of these millions of Maggi packets, this amount of Maggi packets are having this amount of the lead. The confidence interval is this much. Then based on that, people will take the decision. What I mean by here is that, let us say a Maggi sample had picked up and he tested and he found that lead is there. Okay, with a lot of confidence he will say that lead is there. Somebody will come and say that no, this is a sample error. What do you mean by sample error? Sample error, what I mean by is that the Maggi packet that you have picked up, which is the only one having that particular lead percentage, but others are not having. Okay, somebody can come and say that this is sampling error. Then you should go back and tell them no, this is not a sampling error. The number of samples that I have taken is actually following the distribution of the total population. Or you can say that out of this sample, if I am actually conducting this study, there is a significance of this particular sample is providing this lead is there. My statement is that it may contain, or it would contain, with this much percentage in the complete population. What I'm saying here is that you should not directly go and make your statements. Nobody would look at you. But there are some kind of statistical way of communicating your results. What are those? Those I'm going to cover here. That is called significance of the test. Significance of the test means whether you are conducting a test. I will cover more in deep details when I actually explain you what is hypothesis testing and everything. But here I'm just giving the fundamentals of significance testing. Okay, what is significance testing? So significance test is nothing but whenever you conduct any study on certain sample, this sample you are taking, and when you give any kind of your insights that you have observed out of this sample, you should show that it is not having any sampling error. That I will cover later, but let us finish off this sampling distribution. That I'm going to cover using the T distribution and other, that is a reason I have postponed the T distribution after the sampling distribution. Okay, so here for example, that Maggi investigation officer, he went and had taken some samples, like randomly he was doing that. Randomly doing that means with replacement and without replacement. With replacement means here in the Maggie case, he cannot replace that one. Okay, he cannot replace that one. What I mean by that? What is with replacement? Let us say you are having a class of students and you wanted to test the IQ test of the people there, IQ test of the students. So if you want to do your headmaster tells that, okay, do this test randomly, or he may give you some criteria. No, don't do it randomly. Use some business logic or use some criteria to do this testing. What is that business logic or some criteria? The criteria would be something like, okay, you do this test based on the top 10 ranked students only. Okay, so that is kind of, you are having the total set of students and you are applying some criteria. With that criteria, that is actually dividing the complete population into a subspace, which is a criteria that top 10 students. But here in the random sampling, the criteria here is that with replacement. With replacement means, suppose I pick up one student randomly. Okay, I don't know his name or anything. I just did some IQ test, and then the total number of students are, let us say, 62 students. Out of that, you picked up one student and you did the IQ test for him. You got some results. Now you just keep that student back to the same population, then again number of students will be 60 only. Again, when you go and randomly pick it up, there is a probability that you will pick up the same student is 1 by 60. So with replacement, what happens is that you know that with replacement, the student that you have already tested might come again in your next experiment, next to your IQ test. So that is what called with replacement. So there are situations where we have to do this study with replacement. There are cases that without replacement you want to do that. Your headmaster says that no, don't do this experiment randomly, but do it without replacement. Without replacement, so that we can minimize the person that who had already come, already tested, okay, again come and attend the same test, which is something like 60 students. I have tested one, then I would just keep him aside and I will go to the population. My population has reduced to 59. Okay, I will test it. 58, I will test it. 57, I will test it. So without replacement, you will perform this study. So that is called experiment with replacement and without replacement. Where exactly would this help you in modeling? Okay, in any of the modeling techniques, generally people prefer to do with replacement only. Okay, there are some studies like which customer had applied for the loan, and what kind of benefits can we provide to that particular customer, and how much he can actually bring the value to our organization or bank institution in terms of loan interest that he is going to pay. So in that case, you pick up one particular customer, you give him a loan. Okay, randomly you pick up one customer, you give him a loan, and you want to test some statistical study that how much he is going to pay the interest. So in that case, you cannot go with replacement, because you cannot go send him back and again you take him and give another loan. You don't do that, right? So you have to actually find out where exactly can I do with replacement, where exactly can I do without replacement. Okay, so this is completely random. Now, for example, there are some criteria that whenever you are doing this distribution, okay, let us say I am going back to the example of you are the same example I explained in the last class. I am just taking the same example. You are the Dean of Academic Affairs. Your main job responsibilities are selecting the students for your institute. Okay, your institute is a national organization. So now what you would use, what would we say is that, okay, your institute, assume that you are the only one institute, and you wanted to select the students. So when you are going to select the students, okay, there must be a criteria that you have to apply, right? So you apply something like there are 5,000 total students, and you are having total 800 seats in your institute, and you have to give some criteria. So when you're doing this criteria, you can simply take the top 800 people. Okay, you can take the top 800 people for your institute very simply. But now what we would do is that, yes, we can do that, but there is a restriction coming from the central government that, just as an example, no, don't, if you are taking the complete top 800 students, it may be possible that all are coming from the Delhi only, all are coming from one particular Bangalore only, all are coming from one particular city only, one particular state only. Instead of doing that one, why don't we actually create a different bins? What I mean by is that different states, and we will take top people from there, okay, using some criteria. Okay, so in order to do that one, what you have done is that you actually created different state bins. You create a different bins here, and you know these are the top rankers, some rankers that you have got in these regions. So if you actually see that what is the percentage, this is the actual distribution of the whole percentage of the people, and now this is the actual percentage of it. So when you are sampling, the criteria here is that I want to have the same distribution. If you can see the same distribution, but the only thing that I have to change is that from 5280 out of these things I have to take 800. So what is the distribution there? What is the total number of people that I have to take, so that the percentage distribution remains same, then only my distribution will be same. This is one criteria. Okay, now let us say your dean tells you that, hey, I want equal distribution, equal number of people from each and every state. This is called uniform distribution, right? This is the actual distribution, this is the uniform distribution. In order to come up with this uniform distribution, there is not sufficient people in Goa. There are only 80 people are there. But when you want to do the equal distribution, total 5 states, let us say 5 places are cities, okay, if you do the equal distribution 20%, 20%, 20%, but this 160 is, the population is not coming there. So even if your dean tells that, okay, take the uniform distribution, then you should be able to tell that uniform distribution is not possible here, and we should go for some other criteria. Okay, for example, if it is like 180 people, yes, I can take the equal distribution, then the distribution is a very good distribution. So what I want to say here is that the number of people that you are taking the admission, okay, should convince others that, okay, this is a very good strategy of selecting the people. This is the good strategy of selecting the population on which you are going to do the statistical study. So for all these things, okay, you do that. You actually consider this. Now I'm going to a little bit. I will give you one. I will go into one of the real cases. Let us say, whenever any transaction happens, okay, I'm just taking another example here. I'm going to tell you what it is. Whenever you are doing any ATM transactions, okay, assume that 1 million transactions are happening in Bangalore for a bank like SBI. Okay, out of 1 million transactions, every day there is a possibility of happening at least one fraud. Fraud, what I mean by is that that fraud is something like using a card to withdraw some money, and then they will get a call from the customer that money is withdrawn without using any card. That means somebody is tapping your card or some fraud is happening. If you are taking this example now, out of 1 million transactions happening in a day, maybe I'm exaggerating the number, but just to show you the difference of the distribution here, 1 million transactions are happening in a day or in a week. Let us say in a week there are 2 frauds are happening. Assume that. Now they will come to Vikrant and they will say that, hey Vikrant, we are having this particular problem that out of 2 million transactions, sorry, 1 million transactions, every week we are actually finding out 2 frauds. Then you would say that, okay, then you will ask some questions. Okay, 1 million transactions, how much money was the actual transaction happened? They would say, okay, almost all 2.5 crores of ATM, or 20.5 or 20 crores of money has been actually withdrawn. then you would ask the question, okay, for the 2 frauds that is happened, how much money did you lose? So they will say that, okay, almost all total of 2 frauds I lost some 50 lakhs, which is a very big amount, right? So out of 20 crores or 20 crores, 50 lakhs amount of fraud is happened means it's a very big amount. Then they will ask you the problem, can we predict what kind of fraud that might happen in the future? Okay, where exactly the fraud can happen? Can we predict? So you can predict at least with some 30% probability or 60% probability. You cannot predict, of course, with 100% probability fraud would happen on this day, this particular time. But by using the kind of transactions, the kind of timing of the transactions, the amount of the transactions, and the velocity of transactions, the place of the transaction, these are all different variables that you consider. But in this whole population, if you take the data of history of the past 10 years, okay, and assuming that in 1 month or 1 week, I will take it 1 month, 1 million transactions, there will be 12 million, and 10 years of data, 120 millions of transactions. Out of 120 millions of transactions, I am getting almost 24 into 10, 240 fraud cases had happened. So the distribution of that particular one, okay, if you draw it, which is very big like this, and the other transactions are very less. Okay, now you are going to build one artificial neural network model on all those variables, because artificial neural network or any other decision trees, some other machine learning models are actually proved to be finding this fraud patterns most efficiently. When you're trying to build the model, you need some set of, you need to sample the data most efficiently. So when you sample the data, randomly you sample the data, there is a high possibility that you may not get the transaction that is not a fraud in your model, right? Because there are almost 240 million transactions, you just go and pick up at least 20,000 transactions, for example. Okay, small n is equal to 20,000. When you're picking up n is equal to 20,000, which is very small, out of 240 million transactions, the probability that you are getting a transaction that is fraud in your sample is very, 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 very less. So in those cases, we generally use stratified sampling. Okay, so stratified sampling, what will you do is that the moment you collected 240 million transactions of the data from that particular bank, what you do is that you will tell your juniors or your subordinates, hey, this is completely, the distribution of the data is highly skewed, okay, highly skewed in such a way that the number of frauds is coming out to be 240 here. So do one thing, create 2 buckets that I will call it as strata 1, strata 2, okay, strata of the total population, because out of 240 million transactions, you have only 240 frauds, right?
Okay, right.
So what I do is that I will create strata 1 is 240 million minus 240. This is the strata 1, and 240 is the another strata 2 without fraud. This criteria, and here the example, you understand the example. Similarly, if you are having some age of the people and male and female, so what you do is that, hey, I want to create some criteria like 2 stratas I want to create, strata 1, strata 2. Okay, strata 1 consists of males, strata 2 consists of females. Now for your IQ testing or any other testing, you want to take people who are actually, you want to take 2 males or 5 females or 1 male or 4 females, like that you can change that one. And in that case, what happens is that you might sometimes get a criteria, no, I want to test this for an IQ test equally for both males and females. Then what you do, okay, I will create 2 stratas, male, another strata, female. Then I will take equally means 3 males, 3 females. Randomly I will take them. Then I will just do my study on. If you are having some 300 columns, okay, then if you take randomly, then what is the probability that you will get the equal probability of males and females there?
Okay.
Right? So it's only one example I'm telling you, but the strata that I have created here is only with one column. You may come up with another column is that, hey, I want to do the strata, I want to create the strata in such a way that males Bangalore and earning more than 20,000 rupees per month, like that I will create some kind of rule to define the status as well. Sometimes the distribution, the sampling that you do, this is the main mistake I found in my team also. People generally take the data, okay, we wanted to start with some criteria that, okay, take the distribution of this like this. They will take equal distribution means, yeah, I applied equal distribution, but they really don't check whether it is actually equally distributed or not. With the less sample, not 800, in that case, if you do this one, if you take all the 80 and 720 people only, on that 720 people only, they start building the models. They are missing a lot of data there. So every time we have to double check, that is called quality check. The number of samples that we got is actually correct or not. Every step we have to do that one. That is once you start doing that practice, it will become more practice.
Okay. And don't we compare the distribution pattern of a sample with the full distribution of whole population? I mean, to check.
Very good question. But that is what sometimes the whole population distribution you don't know. A number of cars coming between 5 o'clock to 7 o'clock this evening, you don't know.
Right.
The population you don't know. That's what I told you, right? If the population is fixed and it is very well known, like you are actually testing the population on a class of students, yes, you know. If you are doing that complete study on some kind of unbounded population, you don't know their distribution, right?
Right. So you mean there we check the distribution pattern for sample as well as the full population, where we have fixed bound. Yes.
Even if it is the fixed population of people in Delhi and Bangalore, okay, you know the total population. You want to know that whether even though it is fixed population, you cannot go and measure each and every person's height, right? Even then it is fixed population.
Okay.
So that is the main challenge here, is that suppose you want to measure the height of a penguin. Okay, you know that there are so many penguins. You know the population is fixed. Let us say assume that, and you cannot go and measure the height of the penguin. So if you want to say that somebody will ask you this question, hey Vikrant, can you find out what is the height of the penguins? Then you would say that, okay, I will take some sample, let's say 20 or 50 or 100. Then I will actually measure the heights of these 20, 50 or 100, and I will draw the distribution. Then I will find out the mean of it, and then I will say that, okay, this particular mean is coming out to be, let us say, height is coming out to be, let us say, just 2.5 meters. Okay, you come back and say that, hey, I have found the average mean of 50 penguins. It is coming out to 2.5 meters. Then people ask you this question, Vikrant, have you done on the complete population? You say, how can I do that on the complete population? I cannot do that, obviously. But how confident are you on coming out to be 2.5 is the one? Then that point you should be able to convince him that there are no sampling errors. Okay, there is if I'm taking the average of is coming out to be 2.5 meters, my confidence is that this 2.5 meters is the whole population's average height. The whole population's average height also will be 2.5, or it may be between 2.3 to 2.8 with a confidence of 90. That is called confidence interval. That's what we discussed. We draw the distribution, right? And we show that one, right? Sigma, 1 sigma, 2 sigma, 3 sigma. That is how you actually answer that. Okay. In those cases, you do not know the mean population. You have to estimate the mean population. Okay. And also, I'm going to the t-distribution. There I will tell you that, but I will give you some kind of understanding here. When you do this experiment, okay, when you do this experiment, you have taken some sample population. it is coming out to be 2.5 meters of the penguin height. You will actually go walk across the ocean and you go to another region, and again you pick up another population. Okay, here which is randomly but completely different subsample you have taken. On that you got 2.6 is the average height. Okay, and again you take another segment of it. Again you take another segment of it. Again you take another segment of it. Like that, since you have energy, time, and money, then you have almost all. You did not cover the complete population, but you have taken the number of random samples more and more. So as you started moving like 1, 2, 3, 4, 5, 6, 7, 8, 9, like as you are increasing the number of statistical studies of different samples, if you are getting, let us say 2.5, 2.6, 2.3, 2.4, 2.5, 2.6, 2.8, these are the means of the samples, for example, and the means of the mean is going to be the complete population sample. Okay, anyways, I will explain more there. Okay, so you understood what is the stratified sampling? There is actually proportionate sampling and disproportionate sampling. Okay, disproportionate sampling is actually what you do is that here if you look at here, okay, is actually 1, 2, 3, 4, 3 males are here. Total males are 1, 2, 3, 4. 1, 2, 3, 4, 5. So out of 12, I guess 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 11, that actually I have taken 5. There is actually 5, but here I have taken only 3. So it is nothing but 5 by 11, and this one is actually 6 by 11. 5, 6, 7, 8, 9, 10, 11. Yeah, 6 by 11. So actually this distribution is actually not following this actual total population distribution. Am I right or not? Here it is coming out to be 3 by 6, which is nothing but 50% of the 50%. Here it is 1, 2, 3, 4, 5, 5 by 11, which is coming out to be almost close to 50%, but not the 50%. So that is what disproportionate sampling is. This sampling is not actually representing the complete population. Here it is 3. Okay, 1, 2, 3, 4, 5, 6. 6 out of that I have taken 3. 6 by 11 here again. So disproportionate sampling is the stratified sampling procedure in which the number of elements sampled from each stratum is not proportionally that representing the total population. Now proportionate sampling is the one where you will maintain the same one. Let us say here 1, 2, 3, 4 by 12, I guess. Yeah, 12. 4 by 12. How much? It is 1 by 3. Here 2 by 6, 1 by 3. Females I am talking about. Okay, this one males are 8 by 12. Okay, here 1, 2, 3, 4. 4 by, it is another 2 by 3. This is also 2 by 3. Proportion in the distribution, not count. Right. Whenever you are actually doing with the whole thing, then it will called as a probability, not the count. It is something like you are maintaining the same proportions here and there. So there is a high chance of your studies, whatever you are conducting, would actually reflect the same on the complete population. You choose one sampling technique, Vikrant, that comes only based on your data and the problem. Systematic sampling. Systematic sampling, I just want to give you this example is systematic sampling is the sampling where you wanted to apply some kind of intervals in between the times. You wanted to see whether a particular disease is epidemic or not. Okay, what I mean by says that okay, or you can say that in any assembly process you found some kind of quality issues of that particular engine, some missing of bolts or some missing of all these things. So immediately you go and complain to the quality control department, and see these number of samples I have taken, or on which the number of bolt torque is actually less, then they will say that okay, we'll fix this problem. They fix that problem. Again, you just wait for 2 weeks, again go and pick up another sample. Okay, again you wait for another 2 weeks and you will pick up another sample. So which is a systematic sample is something like, here I have given the same example, I guess. So systematically select every car with every ith car in the assembly line of a car manufacturing company is a good example. Okay, which is a systematic sampling. Any traffic police officer who wants to check whether the license, people are carrying the license or not, then they just let other people go. The moment one particular person is processed, then they will pick up another person. So that is called systematic sampling. So they cannot pick up all the population, but they will just pick up people in some kind of intervals. So this cluster sampling is generally cluster sampling. I told you, right? You asked me this question when you asked me, can we do this directly? Or so cluster sampling, what happens is that you have male, female, and different states and different salary ranges and different occupations and everything. You are having many columns. There, when you apply this criteria, let us say he should be male, he should be female, he should be male, coming from Bangalore, earning more than 20,000 rupees, having this kind of software job. I want to take that sample. But sometimes when you do your rule, it may not be true that it may not be possible to get a very good sample out of it. You may get 1 or 2 for sometimes if you apply a very big rule. So what do you do is that you apply this clustering. Clustering is a technique. What you do, it will group all the people based on some criteria. Let us say all the people coming from Bangalore, okay, but maybe having a different occupations may come into one cluster just because the criteria they are coming from Bangalore. Okay, maybe people who are coming from not coming from Bangalore but having ages, same ages and same salary criteria may come into one cluster. But so what I mean to say is that by clustering on some set of variables, you are trying to group the people at least meeting some certain criteria. Clustering is a technique that actually represented as 2 vectors of represented any 2 peoples or any 2 observations are represented as vectors. Whenever the distance between them is coming out to be 0, may not be all times 0. If it is 0, then it is overlapping, right? Any 2 points, if you take in the Euclidean space, the distance between them is 0, means they are overlapping. So they are not overlapping, but at a distance of 0.1, 0.01, 0.8, 0.2, like that, then which is something like representing as okay, they are very close to each other but not the same. Okay, that is what this clustering. So this defines a cluster where, okay, if everybody is matching to the everybody is actually same, altogether same, then it will be a point. It's not a group. Okay, so clustering is a technique where it will actually cluster group the people based on certain attributes. Okay, where the distance between those peoples almost all will be not 0 but at least at 0.1, 0.2, like that. So this is one way of sampling also that people generally follow.
Okay. How will we measure the distance? Like if we have one criteria salary greater than 30,000 and we have another criteria like age greater than 30. So how will we be able to measure the distance between these 2 criteria and group people?
Okay, so let us say you are taking different variables, okay, age, salary, height, and location, okay, occupation, something like this I have taken. Okay, so age is coming out to be 25, salary is coming out to be 20,000, height is 150 centimeters, location is Bangalore, okay, occupation is software engineer. Let us say I will say Bangalore, his age is like 24, earning 15,000 and coming out to be 145, and he is a manager, something like this, something like 23, 20,000, 123, Gurgaon, and he is something like an analyst. For example, okay, when you want to do the clustering, let's just imagine that there are many data points like this. When you are having, just imagine that there are many data points like this. Okay, just I'm putting some like this. So there are many data points like this. Then each one actually represents a vector, right? So here it is actually 4-dimensional vector. Okay, so I will just take only 2-dimensional, no, 4 dimensions I cannot take because we cannot visualize that, and I'm actually just taking 3-1. Okay, this is coming out to be something like this is, oh shucks, this is something like age, this is something like salary, this is something like height. Okay, just I'm taking only these 3 variables for our easy understanding. The first and foremost thing that we are going to do is that I'm going to cover in the next session actually, but I'll tell you here itself. Do you think should I go and directly apply it here? Okay. Let us say age is 25 and salary is 20,000 and height is 115. Then that point is coming out to be somewhere, salary is 20,000. Okay, here. Okay, and 24, 15,000 this one, and this is coming out to be salary. This is 25, then I'll go 24, 15,000 is coming here. Height is less than this, so it will be somewhere here. Okay, just somewhere here. This is my second point, and this one is further down. 23 means that this is 25, 24, 23. I will take it here, and 20,000 is salary, same high this one, and 123 is the height. So since we cannot visualize very perfectly, I will just drop it here. Okay, now you want to do the clustering on this one. Okay, just like this, assume that there are many points I'm taking. Okay, many points I'm taking here. Now you want to do the clustering. What it will do is that you are not applying any rule or greater than or 20,000 or anything here. That you are doing only for the stratas. Okay. Here what you do is that you are trying to identify those rules out of here in terms of clusters. When you do the clusters, what it will do is that it will calculate the Euclidean distance between these two and between these two and between these things and between these two also. So it finds out, okay, the Euclidean distance is actually coming out to be very high here, okay, very large than these two things. Then it will disconnect this connection and it will make one particular cluster here. Similarly, it depends upon actually there are some parameters that you have to adjust in order to find out the best clusters or anything here. Okay, it will find out this cluster. So that is how you will find out the clusters and everything here. Okay, then this is out of these clusters, then you will take randomly one person from here, one person from here, one person from here. The best example is that I take an India map and find out the clusters of different states and taking the people out of each particular state. Let us say V1 is 25 I plus 20,000 J plus, these are I, J and all these are all some unit vectors. plus Bangalore L, something like this. Okay, this is one vector.
Got it.
Okay, now I want to go back to the students T distribution. Okay, since you understood the complete this thing. Okay, now student T distribution is a kind of distribution. When would we apply this one? Okay, whenever you are taking this sample, let us say, okay, whenever you are taking this whole sample and whole population, and you want to take a sample like this, for example, this sample will have some mean that I am actually representing with the x bar, okay, and the mu, assume that you know that, okay, but you don't know the standard. Mu is not constant. Mu is the
right.
Complete population one. Complete population one, you know that, okay. Then, but only thing is that you apply this student T distribution. Okay, you can apply normal distribution also. When this T distribution is helpful is that this is the condition. When you are taking the number of samples is less than 30. Okay, and the standard deviation is not known to you. Okay, the standard deviation of the complete population is not known to you, and comparing the distribution of any two samples. I will tell you about this one in the next slide. But so here, if you take ICC decided to select 20 cricketers out of 100 cricketers whose scores are distributed with an average runs of 45. So you know the x bar 45. You know the total sample n is equal to 20. You know this. Okay. So what is the probability that the selected sample would score at least 40 runs, okay, with the standard deviation of 10? Okay, that means S is 10, okay, and at least 40 runs is nothing but probability of the event that you want to calculate.
Okay.
Okay. Earlier examples of things, then I will go to that in just a minute. Earlier I was actually showing you this. Okay, in the ICC World Cup, top batsmen scores have been collected. You remember these things? So when we were doing this one, see here, this is the event. This is actually mean. Standard deviation is given. Okay, right? And you want to calculate this probability. But here, what the T distribution is actually doing here is that this one, you are taking 20 cricketers out of it. That means the sample size is 20. When it is out of this thing. So whenever the sample size is less than 30, it is a rule. I don't know how it has come up, but generally I told you the student distribution is it is not anything related to student or anything, but this is the T distribution. This technique has come from Guinness brewing company. They wanted to test the quality of the Guinness beer, so where they are actually going to take very less number of samples, and there may be some thousands or 10,000s or 1 lakhs of beer bottles, and they want to test it only 10 or 20 beer bottles only. So in those cases the sample is very, very less, and there is a problem as we discussed in normal distribution also. When not normal distribution, just quite 5 minutes ago, when you take the sample is very, very less, okay, the chances of that particular very small sample, let us say I will go back to the same example of the measuring the heights of the penguins. There are almost all 200,000 penguins are there. You want to know that one, you have taken only some small sample of the penguins. If you are taking only 2 penguins, and if you are calculating the average height of that one, that is not actually representing the complete population. So you have to take the best sample out of it. There are cases that you cannot take those many samples. If you want to test any doctor's efficiency on some surgery, you cannot put many people's lives at risk by taking many samples, right? Where the number of samples can be 1 or 2, maybe even not 1 or 2 also sometimes. I'm just telling you. So in those cases, what happens is that the number of samples is very, very less, and standard deviation is not known, and you wanted to know how much this particular sample, please, I'm going to talk about this. Whatever the value that you get some value for sure, t-value, okay, from this. But how do you interpret that value? You are going to interpret that value in such a way that when you take this sample, let us say 20 cricketers you have taken, so cricket board will come and ask you, hey, why didn't you take 20? You should have taken 60. Then you would say, sir, I cannot take 60 because the chances of spending the money on their trips will be going to be very high. Then why are you taking exactly 20 only? So how do you think that this 20 is actually representing the 100 cricketers? This is the question comes to them. Then you will say, sir, I can take these 20, okay, I'm sure that these 20 cricketers I'm taking, the random sampling error I'm going to get is very less. Then they will say, what is this random sampling error and all these things? Then you will say that the sample that I'm taking is almost all representing the complete population. This is what you will say in simple English. Okay, in order to convince them, what you would use is that you will calculate this t-value. Okay, once you calculating this t-value, you will have to tell that with some confidence. That is called the confidence interval that we discussed in the distribution. So when you go and try to describe them, okay, you get some t-value, let us say 0.3 or 0.2 or 1.2 or 1.3. So for every one this one, you will go to the t distribution curves. If you can Google it, you will get the t distribution curves. Okay. For each t-value, there is a probability that those are actually defined in those tables. These are called statistical tables also. Okay. Nowadays, what happens is this, earlier in our schools or colleges, we used to calculate this value and go to that t tables. If you want to see those t tables, you can quickly see those things here. Okay. T statistic yeah, t statistic p tables, t statistic table. Okay, these are the tables. If you remember, if you go to the 10th standard or 12th standard, we used to look at these tables. You remember? Okay, so for each t value, there is a probability value that is going to define. So this is the distribution, and it will show you how much probability value that it is actually having. Okay, I'm going to talk about it. Okay, so earlier we used to go and find those values. Okay, before going to that interpreting the t value, I just give you one more example of where exactly shall we use. So comparing the distribution of any two samples. Let us say you wanted to know IQ of people from Delhi and Bangalore. Okay, so from Delhi you have selected some people. Okay, let us say this is the population, the complete population of India, and you have taken N1 samples from Delhi and N2 sample from Bangalore, let us, or Madras. And now you want to compare the distributions of these two samples. So it will have some mean, okay. Now whatever the distribution that you have taken, you should be able to convince the people that these two distributions are actually the best sample that I have taken for my studies or for my model building. So you calculate the t-value here also. Okay, you calculate the t-value here also. Earlier only one sample I have taken, that is with respect to the complete one. Mu is the complete one. Here with between two samples. Okay. So when I calculate this t-value, I got the t-value. Okay. Now from this t-value, using those tables, I got the p-value. So p-value is nothing but it is the probability that the sample is, actually I'm going to tell this rejecting hypothesis, null hypothesis. Don't look at these things, but I don't want to confuse you, but look at these curves only. So p-value you have decided is something like 5%. Okay, 5%, which means that this is the actual total distribution. So from here to here 90%, and this is 10%, 10%. You say that 5% means total is 5% means here it is 2.5, 2.5 because symmetry. You actually take something like 5%, 5% means 95% is from here to here. You say that, hey Madan, I want to take 10% of p-value. Okay, no problem, go ahead. So when you take that p-value, okay, you take the p-value something like 10% you have taken. So this is the curve. The t-value from which you got the p-value is coming out to be, let us say, 0.01. Where exactly that will come? Somewhere here, 0.01, because you have taken almost 10% means 0.1, right? It will come to the 0.01 here. So whenever this is actually coming in this region, means whatever the region here, then I'm telling you very simple English, okay, then you are confidently can say that the sample that I have taken is very good. The sample that I have taken is good and it represents the complete population. So everybody will agree. In case the t-statistic, I want you to calculate it by yourself, okay? The t-statistic you will get something like 0.8 out of this one, for example, from this same experiment. If you do this, okay? Okay, why don't we calculate right now? Right now it's so x bar is what? The statistic one. How much is that? 20 is the n, and 100 who scores this is 45. Then standard deviation of 10, at least 40 runs. What is the probability that they would score at least 40 runs? So I did not give you the x bar, I guess. Okay, I did not give you the x bar. Okay, I'll just consider at least. No, it is not at least. Score average 40 runs. So 40 minus 45, okay, which is minus 5 by s by this one, so root 20. Okay, anyways, can you calculate this one, okay, by yourself, and you will get, let us say, one t-statistic, okay?
Okay.
That t-statistic, just you go to any T and P calculator, p-value calculator. I just want to show you how we generally do. Okay, we can take this one, pick p-value from t-score calculator. So let us say, I don't know, yeah, your t-score is coming out to be, let us say, 0.3, okay, and the significance level is, you are telling, is 5%, okay, and it is a two-tiled. Then when you calculate this one, what is this? Oh, degrees of freedom, I did not give you. Okay, degrees of freedom is nothing but the sample n is there, right?
Right.
Okay, and minus 1 is the degrees of freedom.
Okay.
19. Okay. Now let us say calculate this. See, the p-value is coming. This is actually coming from the table that I had shown. Is coming out to be 0.767435. See, the result is not significant. Are you reading this one?
Yeah.
The result is not significant, which means that if the population that you have taken is not actually, in simple English I'm telling you, not in the statistical thing, is not actually the right sample for your test. So I'm taking something like 12, just very large number I'm taking. The p-value is coming out to be this result is very significant.
Okay.
Because the value is coming out to be like, I'm just taking some more value. Means if t-statistics comes, t-statistics is not a big deal, you can calculate from there. Even t-statistics is coming out to be this one, the probability is coming out to this, and it is 0.05, two-tailed one, because your curve is two-tailed one, and it is significant. Which means it is significant means, that means the population that you are taking is very good, okay? The population sample that you have taken very good with that particular mean of average. So that distribution is very good for your further studies and analysis. So now this is the actual region. Whatever I have shown is that for that particular t statistic, whatever you are calculating, that is actually coming out to be that where exactly that p value is coming out here. It is not only that, and I have given an example here. If you are planning to conduct a study, okay, like how many customers would purchase a Samsung S3? So we cannot consider the whole population. So and select a sample. So whether that sample is significant to draw out any conclusion or not, that is what actually this particular p-value is actually helping you. Why are you going to this distribution? Just because the number of samples is very less. Out of 20 lakh people, you are taking only 20 people. Because there are 20 lakh beer bottles are there, you cannot test all of them, right? Generally,
Yeah.
as per my friend, he was saying that when you want to test these beers, they have to sip the beer. Means they have to take at least 100 ml. They have to drink it and they have to test sometimes humans, not chemical composition. So you cannot drink those many beers in order to test that. So yeah, in those cases, this tree distribution is really going to help you a lot.
Okay.
Is that clear? So now I just wanted to review about the probability distributions that we have been talking, and by covering different samplings and everything, sampling distributions and everything. So different distributions, there are many distributions that I'm not covering here, but my ultimate objective here is that how do you, whenever you want to really draw out any conclusions, how do you select the right distribution, like normal distribution, t-distribution. I'm going to talk about chi-square distribution also when we are trying to test the dependency test. So my point here, Vikrant, is that how much you are going to apply these techniques in your real world data science applications, that I don't know. But having the complete understanding of these kinds of different distributions would help you to actually convey your results in a more meaningful way. Okay, and also whenever any data comes to you, you should be able to discuss with anybody, or you should be able to formulate the data in such a way that by understanding what is the criteria. And now I'm going to tell you, until now Dhawan is making the score or Sachin Tendulkar is making the score, then you can say that, okay, I can go to this normal distribution, I can find out the probabilities and everything. But the problem that I discussed that you are going to solve is that whether any transaction that is going to happen next in 1 hour in any SBI ATMs, what is the probability that you would say that it is going to be fraud or not? So how do you say that one? Then suddenly the person asks you, hey, tell me which distribution are you planning to use in this case? Then you should be able to say that no, I cannot use normal distribution, I cannot use t distribution. Okay, I can use binomial distribution perhaps, I can use Bayesian distribution perhaps. So what you should have for that particular problem, what is the distribution that I should be able to use? So that is what people say that in the client meetings, they say that, okay, which distribution are you using? You should be able to say that no, I'm considering simple Bayesian distribution. So what is a Bayesian distribution? For example, this is a simple example. Okay, last month the average number of days means it is nothing but you know the mu value, which is the mean value. You know, average number of days that any patient stayed in our hospital is 4 days. So what is the probability that any patient will stay exactly 5 days in the next? This is the question. So here there is not actually, when you are actually going to build a model, it is more complex. I'm not going to do that, but if you have the intuition of which distribution should we use for this problem, and how exactly can we calculate these probabilities, then we need only two values. One is that average number, that is called mu. Another is that the days that you are actually going to expect, which is something like somebody comes to you and knocks at your door and tells you, Vikram, can you tell me how many number of accidents might happen tomorrow? Then you will ask, okay, can you tell me at least average number of accidents happened yesterday? That means you are using some time intervals here. Time intervals, and also you are talking about only success and failure, which is called binary, which is nothing but fraud is going to happen or not, or whether this customer is coming or not, going or not, giving or not, getting or not. These are all binary, success and failure. That's what people say. So somebody comes and knocks at the door, okay, what is the probability that Sachin will score a century tomorrow? You will definitely have some complete history of the Sachin's thing against Pakistan, or against Bangladesh, or against Sri Lanka. You will say that, hey, there is a high probability that he will make century, because last time he almost hit 100 with Sri Lanka in those matches. So there is a probability that he would hit that one. So that is how this is actually going to help you, Bayesian distributions. So number of accidents are going to happen or not, whether number of customers are going to, number of customers are coming tomorrow to my shop. Yesterday there were 10 customers. What is the probability that, not yesterday, I would say average number of, average, mean. You should give the mean, not on a particular point estimate. So similarly, another example is that the average number of car accidents in national highway is 2. What is the probability that there will be no car accidents tomorrow? Okay, so which is this? If you want to calculate similar thing, you can do here. Okay, Poisson calculator. You can use that one, or you can use with simple Excel also. Okay, Poisson distribution calculator. I'm giving you something like the same example. Mean is 4, and I want to know 5, right? 5, and this is 4. The Poisson probability is actually 15%. Exactly the number of days that a patient is going to stay in that hospital is 5 exactly, and is 0.15. If it is less than, cumulative probability is 62%. If it is less than or equal to 78%, if it is greater than, this is. Similarly, when I'm asking this question here, okay, national accidents is 2, and what is the probability that there will be no car accidents? So no car accidents is 0, and it is 2. Okay, then it is 13.5%. That is one. Okay, so now whenever there are more than 2 car accidents and less than 5 accidents, which is something like Sachin Tendulkar is making the score between 80 to 90, that is how the question, which is something like more than 2 and less than this one. So probability of x is equal to 3 plus probability of x is equal to 4. So I will put it x is equal to 3, and the number of car accidents is still just 2. X is equal to 3, exact 3 means 0.18. This is 0.18. Okay, x is equal to 4. It is another 0.09. So 0.18 plus 0.09 is the value that is coming out to be 0.18 plus 0.09, right? 0.09 plus 0.27 means 27 probability that the number of accidents going to happen between 2 and 5 is 27%. No accidents is going to happen is 13.55%. This is how Poisson distributions are. Those distributions, okay, generally we use for whether it is a fraud or not, or how many number of days customers, the patient is going to stay in my hospital, how many number of customers are going to come to my shop tomorrow. So for these kinds of different problems, we assume these distributions.
Let's have a quick quiz question, guys. And the question is, which of the following is not a feature selection method? And your options are principal component analysis, recursive feature elimination, lasso regularization, or k-means clustering. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
We have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay, so after that we will see, after that we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to, play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay, so NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with Pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax is import, then there will be package name, then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program, and then we will have a alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay,
pip install, sorry, I am writing it again and again, pip install NumPy. So it will find it and it will install NumPy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use NumPy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in NumPy also. So how we write it? We write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be where it is where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing, yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Next is nd array object. Okay, so in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in real world, if you ask me, we don't use more than 2 max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use NumPy arrays. So in NumPy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to, all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see if you want to see the first column, you need to do this, right? So you need to do this, so you will see the entire values. If you need to see only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming, okay, I am working on 2D arrays, sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays I will show you. So for others, what was the names? A and B, right? 2D arrays I will be showing you, not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has 2 elements. Now if we do this, then it will print whole. If we do this, that also will mean the same and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay, now NumPy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay, this part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than NumPy array. Okay, now next is, if you go into check the individual, yes, right, so it will be begin colon n minus 1, that is how. So right hand side will always be excluded, like that. Okay, next is NumPy array initialization, right? So how do we initialize NumPy arrays? As we have already seen, right, how do we do that, but still this is how you do it. Okay, so initialize means what we want to do is, we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is, we will, if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in NumPy. So what you do, you write np.zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np.zeros, then row comma column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in NumPy. So that's how you print zero arrays in NumPy. Okay, next is if you want something with the interval, right? So how you do, you write like this, np.array, within bracket we pass, so it will print you another new array. So what we are doing, we are in here what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's a range, so it's a range actually. Okay, so what we are doing, we are passing 3 variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having 5, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have 3 numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay, till 20 we will print it out. Okay, so that's how this kind of arrays are getting printed out in NumPy. So using this a range you can have other type of arrays also. Now this is the same thing. Okay, now next thing is this a range is done, right? Now let's say we want we want to spread some points over a straight line. Okay, so how do we do it? We want to I mean what I mean is, if you think of a 2D plane, right, like x and y plane, if you think of, and we want to spread some points along that line. Okay, so what we will do then, like we want some points between range A and range B. Okay, so here we are giving intervals, right? So we need to calculate the interval, we need to calculate the point difference and all, then we need to provide it here. So that's how it works, right? But we don't want it, we want it otherwise. Okay, we want it to spread along a line like this. So for between 5 and 10 we want 6 numbers. It is almost same as NumPy, but it has a bit difference. So how it is differing, I will show you. Okay, so this
Just one
links,
doubt in the range. The last, the end number, can we put as 19 instead of 20 in the last example?
yeah, then it will print only single number,
No, no,
right?
no.
And
No, the second argument.
yeah,
Yeah.
this one we can do. It will go till 18 only, not an issue.
Okay, thanks.
Yeah, you can put anything. So the logic is, when it reaches the end number, right, with interval, if it goes past or if it goes till the last number, then that number will be I mean that number will be excluded, right? So let's say 18 plus 2 will be 20, right? So 20 will be excluded. Okay, so that's how it works. Okay, so for 19, 18 plus 2 is 20, so anyways 19 will be excluded, right? Nothing is there to print it out, right? So that's up. Okay, so we are not into loops, so I won't go in that. Okay, next is this linspace. Okay, so linspace and arrange, right? So arrange, what it does, it takes in three numbers, so start number, end number, and so what we do in arrange, we have three numbers as a parameter. We take end number, start number, end number, and the interval, and we print out the values based on the intervals. So from start number till the end number, we print out the values based on the intervals. Okay, but in linspace, what we take 3 parameters again, and what we have in there, we have start number, end number, and then we take in number of points in there. Okay, number of points in there. So if we give you a start number and end number, then if we split it into 10 points, then we will get 10 points between the start number and end number. So that is the difference between linspace and arrange, and all these functions we will be using heavily when we use go for data science. Okay, because these things we will need, and you will see how do we do that. Okay, These things we will be discussing when we discuss about the data science concepts. Okay, now next is how do we do array with the same number. Okay, next is how to create an array with the same number. So this is same for same uses like that, like for zeros, right? Formats for carving out some masks like that. Okay, so if you use this keyword, then if you pass some values, so come on, if you pass some values, then it will give you that number of the dimension it will take care, and it will give you that kind of an array. So row, then column, and then it will be taking up. So np dot full, it will take up first the tuple of row numbers, column numbers, and it will take up the number to fill that array with. Okay, number to fill, like that this thing works, this full function works. It can be anything. Okay, it will give you a array full of that kind of numbers of any dimension. Okay, any dimension can be given. Okay, any real world numbers can be given, I mean sorry, any integer number can be provided as a dimension. Okay, so that's how this full function will work. Okay, next is to randomize an array, again for, I mean, that masking only. So how we do, let's say we want a 3 by 4 matrix to be randomized. So it will give you some here and there numbers of random numbers. So that will be and those will be structured in a matrix form. Okay, the dimension you pass, in that way it will be organized. So random is this thing. Okay, now we go to how do we access this NumPy arrays. Okay, now let's say we are creating 2 arrays. How do we access it? Okay, how do we see what's wrong with the array and what not? Let's say I am creating a 2D array. Okay, now if I do print it, so that's how the shape function works. Okay, that's how we can access a shape of an array. So shape function will return tuple of its row number and column number. Okay, so a dot shape returns tuple row num column, like that. Okay, so it will be returning like this. Okay, now the next thing is, what is the use of the shape function? Okay, so this is a tuple, but we can change the values of the tuples. So this will change it. Okay, we can access the shape function of it and we can change the values. Okay, even now we can access like a, no, come on, we can access this. Yeah, so we can access it like this. Okay, come on, I have not given print. What is happening? Okay, so we can access individual elements of the shape tuple that is being returned like this. Okay, like we use like we access normal tuples. Okay, so we can, what we can do with this a dot shape, we can get the tuple, I mean tuple of row number and column number as an output. We can change the shape of the matrix with this shape function, and we can access individual arrays. Let's say you want to see how many rows are there in your data set, right? You can use it. You would want to loop through all the data sets, all the rows of your data set using a for loop. You don't want to go for map and all. So that's when you use a dot shape. And for print a, that's how you use. Okay, for print a, what you do, you just, I mean sorry, for shape 0, that means you are accessing individual elements of a tuple, right? So 0 will be giving you the number of rows and 1 will be giving you the number of columns, like that. Okay, one thing, so you guys are acquainted with I mean, you guys know about lambda functions, right? It was covered.
Yes, sir, correct. But just want to go back the zero index. Zero index, it will return the number of row, correct?
Right.
If you give comma and another zero, then it will give you the number of column. Is it okay?
It's going to be
No.
one. Shape is always gives only the columns and rows here. So the 0 will give the rows and 1 will give the columns. That's it.
The column. So that is a tuple basic, right?
Can you please do that?
So tuple, how it works, number of elements in tuple, we will have a 1D array, right? So 1D arrays can't be having two indexes, right?
Okay.
So
Okay,
that
got
will be 0, 1, like that. So it is in 1D tuple or 1D array, whatever you call it. Okay. So that's
Okay,
how it
thank you.
works. Okay. Now we can have several more examples of NP. I mean, there's a shape function, but I am not going into the detail. But you need to remember one thing: you need to match the number of elements in the tuple. Like we have 6 elements, right? If I want to split it to 3, it won't work because the size of the array is total of 6, right? So we need to have it multiple of 6 only. That's how we can break. That's how we can reshape. Okay. That's what is about this shape function. Okay. Next is how to get total number of columns. Okay, so again I am having 10 functions and I want to see the size of it. So it will give you 24. As you can see, there are 24 elements in the array. Okay, so that's how this size function works. And this is another syntax of np.arrange. So here what it takes some number of values, number of points needed, will place the numbers between 0 till that number. Okay, so that's how another syntax of arrange works. Okay, so for size function it will give you the total number of elements in an array. Okay, so that is what size function works for. Okay, next is dimension of array. It is more or less same like this. It is more or less the same thing like that, like a shape function. So I will put it right in there, but the only difference, it can be modified. Okay, so where were we? We were with this ndim, right? So how it will work? Ndim will return you the, it is not, I mean, it is a bit different from shape. Shape returns you the exact shape of the array, like the number of rows and number of columns, right? But ndim will return you the number of dimensions of the array. Okay, so if you see the ndim, then what we have 2 as a return, right? That means it a total of 2 dimensions, 3 and 2 dimensions, right? So that's what ndim returns. Okay, ndim will return you the number of dimensions of the array. Okay, so that you need to remember. Okay, so that is what you need to remember. So ndim returns you the number of dimensions. Okay, it is not shape, but it is a dimension. Okay, now d type is the array data type that we have already. Okay, next is d type. Okay, d type is to give you the type of each elements in the array. Okay, in the NumPy array, it will give you type of all the elements, and NumPy arrays cannot be heterogeneous, it has to be homogeneous always. So NumPy arrays will return you, I mean the return you homogeneous arrays. So when you do a d type function on an array, it will return you the number of dimensions of the array, I mean sorry, the data type of each of the elements in the array. Okay, so here we have 24 int numbers, right? So that's why we have int 32 as a return type. Okay, so that's how it works. Okay, so that is what is about this d type function. Next is how do we use it for maths calculations. Okay, so any doubts till this part, till this d type? Now if I show you something more, say, okay, next is as I have created now array with like float numbers. So you see the arrays are, the d type is printed as float 64. Okay, so you have you got an array of, I mean the d type as float 64. Okay, so that's how this d type function works. Okay, so and NumPy, as the name suggests, it is used for linear algebra. Okay, so NumPy is used for number mathematics or linear algebra. So you won't be really having string arrays in NumPy. Okay, so you won't be having it. That is not provisioned. So NumPy is only used for linear algebraic operations, and for that we need integers and floats, right? Nothing more than that. Okay, next is NumPy maths. Okay, we can do summation, division, multiplication, and all those kind of here and there stuff with this NumPy. Okay, now how do we do it? Okay, let's get started with a single array. So this is how NumPy summation function works, and it can add up to different things. Okay. Okay, so sum will return you a sum of all the elements, or it can return you sum of two arrays. Okay, sum can do anything, anyone. So sorry. So sum can return you either sum of all elements in a Python array, or it can return you the sum of elements of two matrices. So matrix multiplication, matrix addition, all this logic will be implemented in there. So now what it will do, it will take up two lists, it will add up all the elements, and it will return you the output. Okay, so 5 10 2 3, that means 10 5 15 and 2 3 5, so 20, right? And for subtract, it will take two arrays and it will subtract the results and it will throw it up to you. Okay, so that's how this subtract and numpy.sum function is used for summing up and finding difference between two matrices. np.sum has a few flavors in it. Okay, so it can do a few things, so we will discuss that. So let's say we have seen how it takes in two lists and it sums you up the result and it will show it up to you. Now if you specify an access parameter, then it will do the sum based on the rows or based on the columns. Okay, we print out a and b for you. Yeah, so see, A and B are 5 10 2 3, right? If we do a sum of sum with x is 0, that means it will do you a column wise sum. So that means 5 2 7 10 3 13. Okay, and if you go for a row wise sum, then it will be x is equals 1, so it will return you 15 and 5, right? So that's how this will work. Okay, add a row wise sum, that's how it will work. Okay, so that's what is the so that's how this functions work. Yeah, that's how this numpy arrays are array sum function works. Okay, so that's how you can get the. Okay, give me a second. Yeah. Okay, fine. So this is not how it works, right?
Remove the square bracket and keep only the circular brackets.
Sorry, no, not like that. It won't take it. Yeah, so x is 1 5 2 7 10 3 13. Yeah, got it. Okay, so two confusions were there. First of all, p like it like x is 1, why it is not taking up? Okay, let me check for some example in the ppt, doing some casual mistakes. Yeah, that's what I have written, right? So 0 0 0 1 0 5, so it should be 0 plus 1 5 plus 0, that is 1 and 5, so it's fine, right? 0 1 0 5, so 1 5. Yeah, correct. 0 0 1 5 6. Okay, let me copy this exact example, what it does. np.sum with x is 1 having some problem. Just give me a few minutes, I will do that. Yeah, now it is working fine. 0. Yeah, now it's fine. So now if I replace it with a, I replace with b, if we remove this, as those are already list, how it works. Yeah, now it is looking good. Again, okay, I will be getting back to you on this. So for now, let's move ahead with the other functions. Okay, so having some kind of a problem, I will check that in the break and I will explain that after the break. So not sure why it is happening, but it shouldn't be happening it like that. Okay, let me go ahead. So sum I will discuss it later. For subtract, we already have discussed. For this division also, it will work in the same way. Okay, what is it with someone? Sure. Check. Okay, now if we pass two parameters to the divide function, it will divide row wise or column wise as you define with this axis, right? So okay, so divide won't work axis wise, it will just take in two parameters and it will just divide to the numbers. Okay, row wise it will divide to the numbers. So 5 and 2 will be divided like whatever happens in the matrix operations, right? In mathematics, the same thing will be applied here. So in matrix operations, what we do, we just divide the first element by the first element of the next array, second element by the second element of the next array, right? So that is how it works. So that is how this division will work here. Okay. Similarly, we can see the multiplication being worked on the same thing how we did in matrix multiplication in our class 12 maths. So it will be same thing. So 5 into 2, 10 by 3, so 1030, like that it will work. Okay, so these are a basic few functions that will be needed for our data science courses. And this expa, it will give you e to the power a. Sqrt, it is for square root. Np dot sign is for sign value of each of the elements. Np dot cos for cos value. Log for log values. Okay, so these are not really used in data science related things. Let's say I will show you quickly all these examples just to have your basic knowledge about this NumPy. I am showing that to you. So these are not really needed for being a data scientist, so you can just check these values. Okay, next is the element wise comparison. So we have, so that's how element wise comparison does. So it will compare each and every element of the array with another one, and it will return you a list of true falses. Okay, so that's how it will work. Okay, so that's how it will work. It will give you a output of true false. If you change something this to true, then the second element of the output will also be changed to true. Okay, now along with this np dot equal, there comes another function where we check the entire array. Okay, if all the elements of the array are same or not. So that one is called, so it will give you a single value. Okay, true or false. So it will check the arrays that is passed to it. It will compare those on a broader level, that is on a array level, and it will give you only single output of false or true or false based on the comparison results. Okay, so that's how it is. That's how it works. Okay, next is aggregate function on this on a single array. Aggregate functions always work on a single array, right? So that's what we are gonna see next. Now, if we have already seen this sum function, right? So
arrays are of different dimensions when you use equal, array equal, or other things.
Sorry, you mean this, right?
Yeah. So no, I mean when you're doing an equal comparison, yeah. So how did it handle different dimensions of the arrays?
It won't handle, right? It will throw you an error, because that is how matrix works in real world, right? You can't compare, you can't add, you can't multiply matrices of different dimensions. It has to follow some rules, right?
Agree. Yeah, I remember now.
Yeah, so same things will do it here. So for multiplication, we have a rule, right? 2 by 1. If a matrix is 2 by 2, then the other matrix, the first one, has to be equal to the second one of the first matrix, right? So 2 by 2 will go with 2 by 3, not with 3 by 2, like that.
Yes.
So those rules will apply here. Okay?
Yep. Thank you.
That is what the basic things of this. Okay, so np dot mean, max, these are there. Np dot mean. So mean, median, mode, standard deviation, this thing you guys remember? Because these are heavy terms that we are going to use for rest of our sessions. Too much. We will use this.
Statistics, yeah.
Yeah, basic stats. Data science is all about that, stats and maths. If you are good in these two, Python is super easy to learn. It won't take you much. And you just need to incorporate the thinking, that how do we think as a data scientist. So these three are main things. Others will fall into its place. But if you have a good base in maths and stats, it will help you a lot. Okay, so what is it? 4QF. Okay, FF not. It's F. Come on. Yeah. So these are a few aggregate functions of the what we can apply to a NumPy array. Okay, come on. I am forgetting this. If you write it or not doesn't matter. When you do np.sum, it will automatically be converted to an array, so you can skip it safely. But again, that is the best practice. Write it. Okay. So np.sum a will give you sum of all the elements. Minimum will give you minimum. Max will give you the maximum element. Mean will be the mean of the elements. Okay. So mean means the middle element of the arrays. Okay. Then standard deviation is how the elements differ from the mean. So that's what is standard deviation. Okay, so that is what is about standard deviation. I will try to connect my pad and will show you the formula once. Same thing will happen. Okay, so it will give you sum of all the elements, minimum of all the elements, max of all, min of all, like that. This correlation coefficient is a machine learning term. We will go into it later. I will tell you what is it. So it's not, let's not worry about it. So except this, have all these things clear. So that's how it will work. Okay, so that's how mean, median, and standard deviation you can take into account. Okay, now what is mean, what is median, I will stack it for the next class for SciPy, because then we will be discussing all this statistical things at one go, and I will give you a brief about all this. Okay, so if you have forgotten this, not an worry, we will be discussing in the next class. So that's fine. Mean, median, mode, and all this thing. So not sure, I am not having my tab with me, so I will have it and I will show you the formulas and all this small stuff. And also what you can do, you can once go through all this basic things. Okay, that's just the basic stats, not needed in entire detail. You can go through the basics, so it will help you understanding what I am covering in the next class. Okay, so that's how it will work. So okay, so this must be clear now. So with that assumption, we will go ahead with to some new topics. Okay, so that is like broadcasting. Okay, what is broadcasting? If we have taken two arrays of different dimensions in here, what would have happened? Let's say we are keeping till this part. What is this error? Axis 1 is not coming through. Okay, yeah, axis won't work for this kind of cases. Yeah, okay, so let's say we have this kind of an array to work with. So the first array, if you see, the first array is of 3 by 3, right? So 1 2 3 and 4 5 6, it is a 3 by 3 array, right? The second array, if you see carefully, we have passed 4 5 6, only 3 4 5, only 3 numbers. So that array comes to be of 1
This
by
2
3.
by 3, how is it 3 by 3?
Sorry?
You said the first array is 3 by 3, it is 2 by 3.
Oh yeah, correct. Thanks for correcting. Yeah, it's 2 by 3. And the next one, if you see, that one is a 1 by 3 array, right? 3 4 5, only 3 numbers are in there, so it is an 1 by 3, right? So now when you add it, you if you notice it carefully, you will see the second row of the array is also getting added with the same number 3 4 5, right? So that's why it is coming 4 3 7 5 4 9 6 5 11. Okay, so how this is happening? This is the concept of array broadcasting in NumPy. Okay, so
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
if you see in this diagram, what is happening, this array is getting expanded to match with the exact dimension of this array, of the first array. Okay, so this was an array of 1 by 3, but when it stretches down, it becomes an array of 4 by 3, right? So it matches the dimension of the first array, then only this array addition is possible, right? So this is the concept of broadcasting. Okay, this is the concept of broadcasting. Now one thing to notice, this broadcasting won't only work for array additions. Okay, it will work for all kind of operations between two arrays in NumPy. Okay, so as you have just seen, this thing all works for this subtraction also, right? So subtraction is also supported. This broadcasting is also done for the subtraction scenarios also. Okay, so this is the concept of array broadcasting. So what it does, the NumPy array gets inflated to match with the dimension of the first array, so that the operation that we are supposed to do is possible, is feasible. Okay, so this is what the concept of array broadcasting is. Okay, now indexing and slicing in Python. This, as you have already went through, I will go through this a bit quickly. So let's just see how you do it. So index in Python list refers to a integer position, right? It can either start from minus or it can start from plus. So minus, when we go for, so Python, when positive indexing is done, then the index goes from smaller number to higher number, and it prints accordingly. right? So let's say for this Monty Python, we are going from 6 to 10. So that will take from P till H, right? Because 10 will be excluded. But when we go for -1, then we go from the larger number to smaller number, because as you know, for negative everything goes opposite, and the bigger the number is, it is smaller, right? So -12 and -7, it will go from -12 till -8, because right hand will always be excluded. So that's how it will be printing the entire Monty string. Okay, so that is what indexing works in Python list. Okay, now when we do it, do a 6:10, that means that is from 6 till 10. Like that indexing is done. Okay, next is slicing. Okay, so A0, if you see this matrix 1, 2, 3, 4, 5, 6, and 7, 8, 9, if you go for A0, then it will print all the elements of the first row. And if you, so that's how first row will be 0th index and first column will be 0 index. Okay, if you go then within brackets :1, that will also return you the same thing. Okay, let me show you. That means we are just taking, okay, so these two things returns basically the same thing. Okay, so when we have A0, we return the first element of, I mean the first row of the matrix. Okay, when we return A:1, what does that mean? Okay, so :1 is for the so what we want all the rows. Okay, so in 2D arrays, how the indexing works, if you know, so then it will be a comma separated one. So first part will entirely work for rows, second part will entirely work from columns. Okay, so if we write :1, that means for the row part, give me all till the second row. So that is the first row, right? So that's what it is returning, 1, 2, 3. But that list is within a list because we are taking it as a list only. We are slicing it, so it will return a list. Okay, and list of lists. And the first one of A0, we are just simply accessing the first element of the first row of the array, first row of the 3D array, 2D array, and that's why we are getting 1, 2, 3 as a list. Okay, so that's how this slicing works for arrays. Now let's go back to the PPT and let's see how what all things we can do. So A:1, extract till row equals 0. That means it is the first row that is being printed, right? Now for the second part, if you remember the indexing and slicing thing, so the first one will account for the row and second one will account for the columns, right? So if we do :1, that means give me all columns till 1. So that is the first column. So that will give you only 1. Okay. Now if we do 1: that means give me all from the first column till last. Okay. So that's where we get this 1: will return you 2, 3. Okay. Now if you remove :1, that means you want all rows and you want columns from 2 onwards. Okay, so that's why it gives you 2, 3, 5, 6, 8, 9. Okay, so that's how indexing and slicing works for NumPy array. Okay, that's how it works. Okay, so we will have a few examples. Let's do it. So I will leave it up to you. You would need to answer this. Okay, so let me explain. This 2: means we are wanting the third row of the matrix. Okay, from the third row onwards. So third row is the last row, so only one row will get printed out, and we are giving :3. So that means it will go up to the third element of the column, right? So it will give you the entire column. So that's why :3 returns you 7, 8, 9. Now let me change it and see how many of you can answer. If we do it like this, what will be the answer? :2, then 2 colon. For row it is :2, and for column it is 2 colon. So y3, y6 separately. Okay. So for row we have given :2, right? That means we want the second row, right? So colon 2. That means we want till the second row. So the first two row will come into picture, 1, 2, 3 and 4, 5, 6, right? Then we have given 2 colon. That means third element onwards. So 3, 6, right? Okay. Next thing is array manipulation. Okay. Array manipulation is to stacking arrays. I mean, like, okay. So what is the difference between array manipulation and the sum and other operations that we have seen? So in that case, what we are doing, we are performing some operations on two arrays and we are outputting a third array. Here also, we will almost do the same thing, but a bit differently. Okay, we won't add or subtract those. We will keep the originality of the arrays and we will output something and something. Okay, so okay, the first function is concat. Okay, so this is horizontal concatenation. Okay, so the arrays will be concatenated horizontally, and one is out of bound. It shouldn't be. Okay, we don't have any columns in here, right? So that's why column wise is not possible. But if we had 2D arrays, it will be possible. That's what I will create for you. It will be easier for you to understand. Yeah, so this is like column wise stacking, right? So this 1, 2, 3 in here and this 3, 4, 5 in here got concatenated together, formed a new row. This 4, 5, 6 and 5, 6, 7 formed a new row. Okay, if we go for 0, it will be like this. Okay, so this is just column wise. So that, I mean, sorry, this is row wise. That means the rows of the first matrix and the rows of the second matrix will be concatenated to another matrix. Okay, let me print this matrices for you. It will be easier. So see, the first matrix is 1, 2, 3. Second one is 4, 5, 6. When we do row wise concatenation, right? We just concat the rows at the bottom of the matrix. So 1, 2, 3, 4, 5, 6, 3, 4, 5, 5, 6, 7. Okay. Now if we go for column wise addition, a column wise concatenation, then what it will do, it will concat the columns on its own. Okay, it will concat the columns on its own. Okay, so then it will give you a new row output. Okay, so that's how. So what it does, this 1, 2, 3, 3, 4, 5 gets stacked in because this is column wise now. So that will be column wise now. So 1, 2, 3 and 3, 4, 5 will be stacked in together. 4, 5, 6, 5, 6, 7 will be stacked in together. Okay, so that's how the output array output will look like. So the columns will be concatenated to a row. Okay, so that's how this concatenation works. Okay, that's how the concatenation works. Okay, so this is what is about this concatenation property. Okay, next is vstack and hstack for NumPy arrays. Okay, so what is vstack and what is hstack? As the name suggests, vstack is vertical stacking. Okay, and hstack is horizontal stacking. Stacking means the same thing as concatenation with a bit with just a small difference. Okay, that we will discuss now. So before going into vstack, what I will do, I will show you stack example. Okay, there is another function called stack in NumPy. Okay, so I will show that first. Okay, before going into this normal thing, this hstack and vstack operations. Okay, so what it will do for these two arrays only I will consider. So let's say I am stacking a and b with x is 0. So I am stacking a and b on x is 0. Okay, so it is not a list I should pass, it should be a tuple in here. Was what is happening? Okay. Sorry. This one is there, this one is here. Yeah, so this is how the stacking looks like. Okay, this is stacking horizontally. Okay, and if I go to axis 1, this is stacking vertically. Why the array is not changing at all? Have I changed it? No, right?
It is changed, Abhishek, for the axis 1.
Is it? Okay, let me print out two separate ones. Might be the quick change I haven't noticed. It should change. It will be 1, 2, 3, 4, 5, 6 like that. No, yeah, that's the intended output I was looking for. So for horizontal stacking, for x is equals 0. So for again, now I'm having some kind of a problem in
No,
here.
you're
Not
not
sure.
running it again. You need to run it again.
Yeah, I ran it, but still it is not working. Not sure why.
It's
But this
working
is not
for us.
returning in the proper stack also. This is not how it should return. That is again a problem. Let me try with 1D array once. 1 second. Yeah, now it is coming fine. Yeah, so that is what is about horizontal stacking and vertical stacking. Okay, so in horizontal stacking we stack two arrays row wise. Okay, we stack two arrays row wise, and in vertical stacking what we have, we stack two arrays based on columns. Okay, two arrays based on columns. So as you see in the row equals 0, the output is 1 2 3 and 3 4 columns. So the two 1D arrays have gotten into a sequence, row wise they have concatenated, but when it is going for column wise, then for 1D arrays it has concatenated the columns into its rows. Okay, it has concatenated its column into its rows. Okay, so this shouldn't be printing. First of all, this shouldn't be printing like this. Why it is printing? So that's how this stacking works. So again, this for 2D, why this problem I am not really sure. I'm typing the exact syntaxes, but still it is not working. Okay, so for stack, we need to have 1D arrays. If we need to have more than 1D arrays to be concatenated together, then for that we have concat function. Okay, this stack function will only take in 1D arrays into account, and it will stack those accordingly. Okay, so that is what is about stacking. Okay, now if we go into this is what is about stacking. So stacking will take only 1D array into account, but if we need multiple dimension arrays, we need to go for like 2D arrays. Okay, we need to go for 2D arrays. That's how it is. So now let's say I am creating a new array like this. Okay, so if you see this carefully, the stack function, it takes in only 1D array, and if you pass in a 2D array, it doesn't do anything with the array, right? Except what it does, it just created, stacked array of its own, or the array A and B individually was stacked onto something, and that's what got written over here. Okay, now here on the contrary, if you see the hstack function that I have written at the bottom of the screen at the last line, it took in two 2D arrays to properly stacked. Okay, so that is what is the difference between this normal stacking and this H stack and V stack. Okay, if you want to go for concat function, concat actually differs in two ways. First, one way, actually just only one difference of concat, that is okay, let me write it. So let me do it a bit clearly, give me a few minutes. Print vertical concat vertical stack. Okay, Let's see the differences. Okay, now x is 0, x is 1. Okay, so for each stack, that is horizontally stacking, right? So what it did, 1 2 3 2 3 4 concatenated in a same row, 4 5 6 5 6 7 concatenated in a same row. Okay, and return you the desired output that you want to see. So that's how horizontal stack worked. Okay, so this is row wise stacked, but the rows are concatenated together into a new column, right? New row, sorry. So rows are concatenated to a new row and it outputted a different version of a matrix which is having a different shape. Okay, so if you compare the output of horizontal stacking and vertical concatenation, you will see these two are same thing. Okay, these two are same thing. So that is the basic difference between this concatenation and stacking. So stacking is to add up the elements to the same dimension. So when we are doing a row wise stacking, that is horizontal stacking, we are adding the rows, the element to a row itself. Okay, but instead in concatenation, the rows are added up to the entire matrix. Okay, the rows are added up to the entire matrix. So that is the only difference between this horizontal stacking and vertical and the concatenations. Okay, now for the vertical stack, the same thing happened, right? The columns got merged in, just the columns got increased and those elements are stacked into the columns. So 2 5 3 6 4 7 have added into the column of the first row itself, which was done in the horizontal concatenation, right? So that's how this concatenation and stacking works and differs. So that means for stacking, the stacking will be along the axis which it is currently working, and for concatenation they will be concatenated on the same dimension. Okay, so that is the difference between these two. So are these things these four things clear to everybody, or I need to explain it a bit more? First of all, for stacking doesn't work on 2D arrays, and for H stack, V stack, and horizontal concatenation and vertical concatenation, these are the examples that I have written. So are these things clear? Seeing a mixed response. Okay, let's go over this. So horizontal stacking, right? What it did, it had two arrays to work with. Okay, A and B. Okay, so how A looked like, how B looked like. I will show you. Stack, forget about it, it won't work here. So this 1 2 3 4 5 6, let me write it down. 1 2 3 4 5 6 2 3 4 5 6 7, these two are the rows, right? So when we are stacking horizontally, the two rows, that is 1 2 3 and 2 3 4 are stacked, okay, on the rows. So 1 2 3 2 3 4 are merged in a single row. 4 5 6 and 5 6 7 are merged again in a single row. Okay, and the resultant output is returned. Okay, so that's how this thing works. Okay, that's how this stacking works. Okay, now for horizontal concatenation, what we are concatenating the rows to the entire matrix. So 2 3 4 5 6 7, these two rows are concatenated to the entire matrix, that is row wise. Okay, so it didn't form a new row, instead it just stacked in the rows at the bottom of the older matrix. Okay, for vertical stacking, it's the same thing but on the column basis. Okay, this is now a single column, this is now a single column, like that. And for vertical concatenation, it is the same thing as horizontal stack, it added those elements in there. Okay, so that is what is about these four operations on this array. Okay, so is this clear now? Okay, next is column stack. It is same thing. Let's see it here only. I need to go in the other slides. So the column stack matches with the vertical concat. Okay, so which matches with the horizontal stack. So that is the column stacking. Okay, that is what is about this column stacking and there. Okay, that is how it works. So that is not much used, column stack function. Pardon please. So that's how it used. So that is what is a function of this column stack. Okay, so we generally use H stack and V stack a lot, not the other ones. Okay, so if it's clear, we will go into the splitting of arrays. Okay, this is a bit tricky one. So what I will do, okay, so the syntax is, I'll show you here. The syntax, how it tells is, for this split function is np dot split. Okay, it takes three parameters into account. First one will be a array. It can be anything. Next one will be index. This I will explain. The next one is axis. Okay, the array, the first one can be any NumPy array. Okay, it can be any NumPy array. Indices has two forms, either integer or a list. If it is an integer, then what it does, it takes into account the array is split from that very index which is mentioned as an integer. But if it is an like section, like an list is passed, then that 1D array will be that array will be splitted from that row. Okay, splitted from that row and column based like that. So it will be coming to an 1D array, the list, it will be then be splitted based on that. So we will see that in a few minutes. Okay, and next one is axis. As you already know, that is having 0 and 1. That is the same thing as you already know. 0 for like a row based, 1 for column based. Okay, so that's how it will work. Now let us go back and work on this A array. Okay, so print A, this will be our A array. Now what we will do, we will split this array. So A, the first, second one I am passing an integer, third one I am giving it a column. So see what happened, I provided 2 as an integer value, right? So the array is split onto two arrays. Okay, if I pass 3, it won't be 3. Why it is not equal? It should be equal, right? Okay, why it is not working? Because we have 2 rows and we are splitting it based on rows, right? So it won't work. So that's why we need to split it on a columnar basis. So that is the idea. Okay, so see here, so we have a 2D array, right? So we are splitting it based on row and we are splitting it to two splits. So the two arrays will be coming out. Now we are splitting it based on x is equals 1. So that means a columnar way. So we have 3 columns, so it can be split into three parts, right? So that's what is about the split. Okay, that's what is about the split. Let me print it something here. Now this is the easy and simple part. We will get into the critical part in the next part. Critical thing is coming up for you guys. Now let's say I am not passing something as integer. Instead, I am passing it as a list. Let's see how the output differs. Okay, so this is how it will differ when you pass this, like when you pass this pass a list to the integer value. So the array here will be split into 3 parts. Okay, and then those 3 outputs will be given. Okay, so in the list, the first one is an the first thing refers to the column. So array will first be split into a colon 1. Okay, then the array will be split between these two numbers, that is 1 colon 2. Then the array will split for the last number, that is, sorry, the array will split into the last number, that is 2 colon. Okay, so this 3 thing will be outputted based if it's a list is passed into the indices thing. Okay, so this is what is the idea here. So what this basically does, if you see the array in full, it has 3 elements, right? It is a 2 by 3 array, right? Now I am splitting it from 1 to 2, right? So that means we are splitting into these 3 parts. That's how split works. Okay, so this array refers to from where it is, from which, along which axis it will be splitted, and this is how it will work. Now, so this is what is to hold true for row wise. Now if we go for column wise, you see something different, right? So what is this doing now? Here everything is given for only row, right? But here everything is done for column. Okay, so see, the first output is 1 4. The next one will be done for column. The first one that we have seen was done for rows. Now in the second one, the everything will remain the same. Instead, we will do for columns instead of doing it for rows. Okay, so now if you see carefully, these are the splits that you got in there. Okay, 1 4, 2 5 and 3 6. Okay, these are the splits you got from there. So every operation is done like this. So whenever you get an index, you split that array individually into 3 parts like this. Okay, and then you concat the output of these 3 separately. So that's what will return you the exact output of the split function. If you split that on the rows, then it will be a row wise split and it will return you the values and the 1D arrays based on its rows. And if you split it based on column, that is x is 1, then it will return you some values based on the columns itself, the column separation itself. That is what the concept of a split is.
Let's have a quick quiz question, guys, and the question is, which of the following Python libraries is commonly used for deep learning? And your options are NumPy, Pandas, Matplotlib or Keras. Please mention your answers in the comment section below.
Why Python is so popular these days for data science and other things is that it has wide range of libraries which helps you to get basically anything done in few minutes. You no need to write the codes from the beginning in order to get the things done. Okay, you will get many open source packages available in the market and they will be absolutely free. No charges will be there for using those, so not an issue. So you can always use those packages. You can write it on your own, but when something is already developed for you, that won't be required, right? So you can use that package. Okay, you can use that package. So that is again a very big point for using Python for data science related applications, because when we cover the machine learning algorithms, if you see for implementing a basic of it with some good amount of result, it will take a huge amount of time if you don't have the packages. So Python has those, and those packages are really easy. You just need to understand how the algo works, how you need to use it. You don't need to write the entire algorithm. So that's why Python is again very popular. And for today's Pandas module, this has many functions, many things related to data manipulation and data analysis. So that's why we use it, and it's open source. That's the main reason we use it. Okay, so let's go ahead and let's see how this Pandas works. Okay, how this Panda was derived actually. So this Pandas name was derived from the word panel data. Okay, what is word panel data? That was some kind of a tabular data that has multi-dimensional data in it. Okay, and it is kind of a time series kind of a data. So when I say time series, what does that mean? That means, let's say we are having male female ratios for last 5-6 years, okay, or male female income ratios in last 5-6 years, the example that is given here. So those kind of data is called time series data. See, for 2013, for a female age 23, salary was 20,000. In the next year it got increased by 5,000, next year 10, next year 7.5, like that. So this kind of things called a time series data, that where we have a series of data. So the state of the data differs with the time. So that's what is called a time series data, and this is something like that. So while analyzing that, this Pandas module was derived by this guy Wes McKinney. It was derived created in 2015 actually for ease of use, and this is basically built on top of the Python list dictionaries and NumPy arrays and dictionaries. Okay, so that's how this Pandas module was created, and these are some basics. So that's why you need to have your Python basics crystal clear in order to grab this Pandas module. Now let's go ahead and see what are the features of a Pandas module. Okay, first is series object and data frame. What does that mean? So Pandas can support multi-dimensional data, 2D data, and one-dimensional data. All these three kinds of data are supported. Okay, so for 1D data, we have a series object. What is it? We will see that in a later. But just for an overview, series object, you can say it is a 1D array of NumPy. Okay, a 1D NumPy array is almost similar to the series objects. How they are different, what are different, we will see in a few minutes. Next is is data frame. Data frame means a tabular kind of data. Okay, so it will have some labels for the columns, it will have labels for the rows. You can have it, you can create that kind of 2D data. So how it works, this is a tabular data, right? So this MPG, cylinders, displacements, horsepower, weight, acceleration here, those were stacked into columns, and all these rows have had indexes. Okay, so that's how Pandas module can read the data. So that's where the data frame comes into picture. Data frame is basically for handling two-dimensional data, and for 3D data we have panel data, but we don't really use 3D data nowadays because that's kind of things we still don't get. That is basically for videos and all, where we have layers of data, right? Pixels are layered, so those kind of data we don't really get it in data science. I mean, video analysis is only used for traffic police purpose, not much, and others very high-end jobs that will be using this kind of data. So for normal usage we don't have it. So what we have is basically 2D data. So data frame is the thing that we are going to use more frequently, and series object is the next thing that we are going to use. Okay, this is for 1D and this is for 2D. Okay, next is handling of missing data. So what does that mean? We had some NA values in the data set, right? So we cleaned it. So how do we clean it? We fired up one command of Pandas and it filled in the missing values with the mean of the data set. So handling of missing data is also gets very easy for using Pandas. So that is again a good feature of Pandas, which will give you a very handy functions to replace missing data or null data or the rows if they're not there having null values, NaN values like that. Okay, we will see those shortly. Next is data alignment. For what this means how you access the data, how the data is placed in Pandas data structure. That plays a vital role. Let's say for the XLS file that I have shown you a few seconds back. So for that, if you had to have all the list, all 1D list stacked into different parts and all different lists for rows, different lists for columns, so they are pretty messy, right? And it will take a lot of space to store those data. Also, it will be really hard to get the data. I mean, get the required data that you want to have, right? So that's where Pandas makes your jobs super easy. So that's where we use it. Next is group by functionality. So not only group by, we have group by, pivot, and all those functionalities is Pandas module, which will help you to also join, merge, and all those kind of things are possible in Pandas. So without having a database, without having a relational database, you can still perform this kind of operations in Pandas module itself. Okay, so that's how you won't be able to write select queries, but again, the data set, if you see, you can select the columns as you require, and all those kind of stuff is possible. Okay, so that's another good feature of Pandas that we will be seeing in a few minutes. So next part is slicing, indexing, subsetting. As I already told, like this slicing, indexing, and subsetting is a core thing that Pandas does. So because this is basically based on Python and NumPy list. So again, this is widely used, and this indexing and subsetting will be used a lot. Okay, so that we will see later on. Next, if we go merging and joining, I have already told. Reshaping means you might not need some columns, you might not need some rows, so you can drop those easily. You can reshape it. That will be pretty easier. Hierarchical leveling of access, that means you will have a properly defined structure of rows and columns. Accessing those rows and columns will be very easy. You will see that. Next is robust input output tools. What that means, input, you can provide XLS, XLSX, CSV files, text files, everything to Pandas. It will grab those and it can convert the data frames and series objects to Excel file also. Okay, let's say you are processing some data. Let's say we have a Titanic data set. We need to predict the output of who survived and who didn't. So you predicted the output, but you need to present it to client. How you will do it? You can just have that data from data frame and write it to Excel file, and you can show that to your client. Like let's say this is the data that I got. This was the training data. That's what I did. I have some algorithms behind. Those I am not gonna share to you. What I can show you is how the output looks like, and output looks like this. So what you will have all the columns in the train data plus the survived column to check who survived and who doesn't. Okay, so this is that's what is benefit of Pandas. It can save the output files in one liner. You can just have a one line. You can select the data into Excel file in a CSV file. You can also name the sheets, like which sheet you want to save. If you have more than one sheets in the file, then also it will work. You can read that way also, you can write that way also. It has very robust tools for doing that. Okay, very robust functions are there where all functions are available, so you don't need to worry about it. File handling gets easy with pandas. Next is time series specific functionality, again that I told in the first step only, because this is the base of pandas. So from this requirement this was derived, so this can always be done, right? So this is again a very good feature. Pandas versus NumPy, what is the difference? So see, NumPy, what it has, it has homogeneous arrays, right? With 1D arrays with only numbers. But Pandas, where they are preferable when you have heterogeneous data. Okay, so let's say you want to accommodate strings also. It might be case that you want to have strings. You don't want to always convert it to numerical thing, but the reality is for the features of machine learning you will have it, but sometimes you will need to do a text processing also, right? Text mining also you might need to do before going to it. Let's say you have a very large description field, so you don't want to check all this, right? So you want to check for some specific keywords in that, so that's where these things comes handy. So it might be the case the data set that you get, you have some comments filled in there and you need to analyze that comment. Let's say for Twitter, for sentiment analysis you might need it. So that is again not data science, but that is a part of data analytics, but still somewhere you might get that requirement. Okay, so that's where pandas will save you, because in NumPy you won't be able to process the 1D, I mean the string arrays or more than 1D arrays. Okay, you can have multi-dimensional arrays, but again accessing will be difficult because it won't have named columns, named rows like that, so it will be difficult. So that is a real world case when you should use pandas, and when you should and this NumPy thing won't fit your purpose. So next thing is pandas perform better than NumPy for 500k and more. This is just a number, this is just a number. We will show you like why we are telling this. We will show you at the end of the lesson, so you will see an example like how much time and space it takes and all. Next is pandas series object is more flexible, as you can define your own label index. That's what I was telling. So you will have a labeled index for rows and columns that you have. So you're accessing your columns won't be always based on integers, okay? Whereas in NumPy, you always have integer positions, right? But in pandas, you won't have it. You can define. So you will see that how it works. You will see that. Okay, so that is what is about pandas. Now next is how to import pandas in Python. So you can write this function import pandas as PD. So that will import pandas for you, and it will have an alias name of PD, which you can use it in throughout your code. You can give anything as alias, but PD is short and so short and sweet. So you use it. So you need to refer pandas module by using PD dot like that. Next is what kind of data is suitable. So as we already discussed, tabular data, arbitrary matrix, any matrix can suit this, right? And you can change this indexes and columns. And time series data. This was what I was talking about, time series. So see, a series of time will be given, and based on that the changes of values will be given. So this kind of data suits pandas the most. Next is data structure in pandas. Before going to that, I will show you how you can install it. So in Anaconda, we will by default be having this pandas module. Okay, we will by default be having this pandas module installed. So in that case, you won't be need to install pandas separately. But if you are having standalone Python installation, then how you can do it is you can use this command to install pandas. Okay, if you are having any standalone distribution of Python, not the Anaconda one, then you can use it. Okay, so you need to set the path for this pip command, and then you can install pandas. Okay, so that's how you do it. So that's what is about this pandas things. Now let's get started with this data structure in pandas. This I have already told. So in for one-dimensional data, we use series object in pandas. Okay, we use series object. For multi-dimensional data, we use data frames, and for 2D data actually we use data frames, and for multi-dimensional data we use panel data. So this is not in scope. This we don't use it. So it's very rarely used, this panel data. So we will concentrate on first two, series object and data frame. Next is, what is series? Series is a dynamically labeled one-dimensional array. You can think it like that. So it can contain similar or mixed type of data. That doesn't hurt. Okay, you can have any kind of data in there. So see here when we have, okay, so how do we create series object? We used to use this notation. Okay, so pd dot series, within brackets we need to pass in the data type that we going to that we need to convert to series. Okay, let me show you what happens if we pass 2D arrays. So see here what it will do. This will convert your data, whatever you pass it, to a series object. Okay, what is a series object? That means it will label your rows using integer indexes, and it will give you the data. Okay, so if you see, when I provided only one list, so what it did, it converted this list into a series object, and it had 1 2 3 4 5 written separately. But when we provided two lists, right, so our expectation was to get a two-dimensional matrix kind of thing. Instead, what it did, this series object taken those list as an individual element and columns. It put in the column values, and it provided indexes to the rows, right? So series object is strictly for 1D array. If you pass 2D arrays, that will also be changed to 1D thing. So series object is always used for 1D kind of an operation. So always keep in mind, don't confuse it with the data frame, because we are going to see data frame next. So they will look the same, but it is not same. Okay, so this thing you need to remember. Okay, now if you see the type of this series, if you see type of this series object, you will see it will be pandas.core.series. So that's where it comes handy. Okay, so you can check it like that. Next is the series object is done, so it will be of type pandas.core.series.series. Okay, so that's how it will work. Next is how to change index names. Okay, this was what I was talking about. So that means, like you saw, we had the 0 1 2 3 index kind of, integer kind of labels attached to each row, but now you can change it to anything. How do we change it? You can, when converting this array to a Python series object, you can change it here. Okay, you can pass in a list of names here. Okay, so we have 5. Let's say we are providing 4, and if we run it, see here what is telling, length of pass value is 5, index implies 4. So what it will do, the list of index that you give, it will map it to those indexes. Okay, the index that you give, those will be the label for the row, and that sums this up. So this one will be mapped to each of the rows. So a b c d e will now be the row objects. Now if you try accessing this, so this will work. Okay, srs a colon c, now this will work. Okay, this will return you the values that you have. Next thing to remember, when we are using string based indexing here, it won't be excluding the right hand side. Okay, because it can't, right? But if you use integer based index, the right hand will be excluded. But for this kind of things, this kind of string based indexing, it won't be excluding that. So that's how it works. Okay, so renaming is done. Let's see how we can convert all these three types of data into scalar. To series objects. So we can convert this array to a list, dictionary in the similarly you can do scalar data also, you can do it. Okay, similarly this dictionary will also be converted, and scalar means a simple 1D thing that is also been discussed. Okay, so now the series part is done. So what is Pandas data frame? That is basically a two-dimensional labeled data structure with columns all of potentially different types. That means any tabular kind of data which will have 2D data, two-dimensional labeled data structure with columns of potentially different types. What that means? That means you will have row labeling and column labeling. Okay, so this column labeling, so you can use it instead of 0 1 1. You can have labels for columns also, and those columns can contain different kind of values. Okay, one can have string, one can have int, one can have float, anything it can have. So that is where data frame comes into picture. Now, why data frame? Data frame supports different type of columns that I just told, right? So you no need to have, I mean, you no need to have a single, I mean, one only homogeneous data when you are using this, like when you are using data frame. Okay, so that's where it helps you in getting in getting things done easily, right? Because when you are reading an Excel file, you can't expect that everything in there will be of some of the same type. It can have different types of data, right? So that's where this data frame comes handy. Next is mutable size. That means you can change the size. It is not immutable. It is mutable. So you can change the size and shape of the data that you get. So you can drop, you can create extra columns, you can drop columns, you can drop rows, and everything you can do with this data frame. Next is labeled access. This has already been discussed. So arithmetic operation in rows and columns. We will see how you can get meaningful information from the Pandas package, Pandas data frame. All the stats information that we saw in the last classes, like in the SciPy that we have seen, in the NumPy we have seen, we have same set of information available through this Pandas object also, because this is basically built on top of this NumPy arrays only. Okay, so you will see how you can do this. How to create data frame? It is the same way, pd.dataframe data. So list, series, NumPy, nd, array, dictionary, anything and everything can be converted to a data frame. Okay, now let me show you again. See now, what is the difference from series and what is difference from the difference in this? You have a index in column also. Now let's try this. See here what is happening. So as you have provided two columns with different set of values, that's why it has put in none, nan, when it didn't find any values. Okay, so what you had 5 columns in here, right? You have 3 columns in here. Let's say I am changing it. So you provided 3 in the first one, and 5 in the first one, 3 in the second one, right? So when it tried to map the second row of the data to all these 5 columns, like in the first row it had 5 columns, right? Because you have specified 5 values. So in that case, it found 5 values, it printed all those out. In the next row, when it had 2 3 4, it tried to map all those to 5 columns, but instead it found 3 values. So what it will do with the rest, it will put an NaN in there. So that's how this pandas data, I mean this 2D arrays has been mapped to a like pandas object. Okay, now let me change this to dictionary right away. So here if you see, I have put in a dictionary, right? A and B. So A, B are converted to columns and others have been changed to row indexes 0 1 2 3 4, and the values are mapped to this columns only. Okay, values are mapped to columns only. So that's how this thing can be that's how this thing can be changed. Then that the dictionary is changed to this kind of a 2D data frame. So that's how dictionaries can be changed. So here what it will do, this there are 3 values, right? So it will convert to 3 columns, and here we have only 1 value, so the other columns will be converted to NaNs. But here we have 2 columns with 5 rows, so that's why it won't be containing nulls, and you need to provide both this value part to be the same size, otherwise it won't be converted. You will see some kind of value error. So that's why. So this if you have 3 values for the second one, that's what I just explained. So what is happening in this case, it is taking 2 columns, right? And it is filling out rows. So while filling out rows, if it doesn't have the matching number of columns, I mean matching number of values in the columns, it will throw an error, right? So that's what it is doing. So it is not, now it is filling out rows, it is not filling out columns. So you need to have full columns in order to provide the values. Earlier it was taking into account the column values where it put in null, but I mean NaNs, but here it is filling out rows based on this A and B columns. So that's why it should be equal. That's why it should be equal. So that is the concept. So we don't generally have this kind of values. We have, I won't say we don't have, but we don't have generally this kind of values for dictionary. I am just showing it for illustration purpose. So for filling rows, it can't fill in names because we don't know it. So that's how it works. This is a real world thing where we use this dictionaries. Okay. So for fruit we have some values, and for count we have some values. So that means we have 10 apples, 12 mangoes, and 13 bananas. In that case, it will show up nicely. Okay. The example that I have taken, it is something else. That's why we use it. So basically, this column A is a series, column B is a series, and this entire thing is a Pandas data frame. Okay. So individually, all the columns are a series object. So when you get into this kind of a zone, you will be using the renaming of index. So here you can change this index name A to a fruit or something like that.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So that's where it goes. Okay, we will see some examples on that also. Okay, so this basically sums this up. So this is for converting series objects. See here, we are providing names separately. So you can give names like this. So what we are doing, we are creating a series object with A and B name, and then we are passing it to this DF, and DF is having this AB612 values. Okay, like that. So NumPy arrays also you can pass it to there. So 2D arrays I have already shown. It can be of different types in here. So this kind of dictionaries you can put. So that also I have shown. So that's how this works. Okay, that's how this data frames can be created from variety of things. So that's how you can convert different kind of data types. Whatever you see in and around Python and in and around this NumPy and SciPy, you can convert all of this to all of this to a data frame. Next is this inner merge, inner join, left merge, left join, outer merge, outer join, right merge, right join. So this is basically to concat two different data frames. No need to worry, we will see all these examples in a few minutes. Okay, we have a separate section for this. Starting from this slide, you will see a lot of examples. How do we use it and how do we do that and all. So plan is to have it after the break, or let's see how it goes. Okay, so till this slide, any doubts you guys have, or we can proceed. I think I have answered most of the questions in chat. The chat window is really small, so if I missed something, just let me know. Okay, I can repeat that also.
Abhishek, can we rename the index of rows? That is by default is coming like 0, 1. No? So can we rename it?
Yes, but that's of no use, right? So you will, when you are accessing the Python object, you will max of the times you will use it based on columns only, right? Rows are not that much used, but you can do that. That's an option. Okay.
Okay.
But just think of it. Do you really need to rename an index, or 0, 1 is perfect, right? Columns are fine. Columns you will need here and there. So I can show you also. That's not a problem. So you can, okay, let me show you. You can pass in a dictionary actually, and you can do it. I will take a small example. I won't do it big one. So what I am doing in data frame, we have a thing called columns object. Okay. So when you do that, like when you check, when you after you create a data frame, you can access the columns of the data frame by using this keyword df.columns. This is a cheat code. So that is a list. Okay, and this is mutable. So you can assign the number of that values you want to specify for each columns, and it will be renamed. Okay, so this is a mutable thing, so that's why this way it can be used. Yeah, so that's how you can change the column names. Okay, so this is how the syntax is. So the thing is, if you want to change the indexes of a row, if the row labels you need to change it, then what you need to do, you need to pass in the 0 and 1, that is the row indexes, and create a dictionary. You can pass it. in the index parameter of the df dot rename thing, and there it will be changing the rows based on the it will be changing the row indexes. Okay, but if you want to change the columns, then you need to pass in index equal to string or int, something like that. So this index will contain this index, okay, the row indexes. This will contain the row indexes. Okay, then you need to pass in columns list. So this becomes same as this, df dot columns equals list, or columns equals a dictionary, the older name and new one, and the new name. Okay, and then this in place equals true. In place equals true means it won't be creating a new one, it will replace that existing thing. Okay, so that's why in place equals true, and then if you execute this, so it will rename the columns. But in real world, using this one is really easy and really helpful. So what you can do, if you I am not going into map now, if you use map, it gets easier. So for call in df dot columns, if call equals let's say 0, then you change it to will be a here, right? So if it's a, then have it call equal to b. So if you run it, this will this will change the column value. Now then you can go back and assign this column value to this df dot columns. You can create a list here, you can assign that list to df dot columns, like that you can do. Okay, so that's how you can do it. So you need to take another list, let's say call list equals this. So after you come out of the for loop, you change it to, let it be a, let this rename first. See, now a converted to b, right? So this is the best case where you can use. This will get clumsy as the number of columns grow in, you need to remember all, you need to rename all, so this will get clumsy, the syntax will get clumsy. But in real world, how I use this one. Okay, so that's how I use it. So this is the this is how you can do it in real world. This will be easier, right? As you can see. So if you want to change it, this will be much easier for you. So it can be anything. Okay, so 0 1 2, and you just check the conditions, you can change it like that, you can do it. Okay, so this is just to show you how it works. Okay, so that is what is about this row and column accessing. So now next thing is what is inner join. Inner join is joining two tables based on the common column, and the common column will be absent in the resultant value, right? So that is what is inner join. For right join, what happens? The right side table will come in entirely, and the common part of the right side table will have and will be coming entirely in the result, and the non-matching values of the left side table will contain null values. Okay, left join, it will be just the opposite. Left hand side table will be coming entirely, and the non-matching values of the right hand side table will have null values. Outer join, it will have all the data of all the tables, and whatever is not matching, it will put on null, right? So that's what is about this joining. Okay, so now all this can be achieved using pandas. So see, this concat thing that is being shown in here, I will show you with an example. So the concat thing that is being shown here, so that is something like, okay, so that is something like outer join. So that's what concatenation does. Okay, concatenation, what it will do, it will concat all the data frames that is passed as an object to it. It will be taking all those and it will merge all those three data frames. Okay, so that's how this concat thing works. Now for right join and others, what I showed, so that will work similarly as it works for this one, right? So for that, we need some good kind of data sources. Let's say we are creating, I will keep it short, I will keep 2 columns only. What do we have here? This is my first DF. This is my second DF. Okay, We have a common column of A. We have a common column of A in there, right? So if we do concat, let's see what happens. See here what happened, it just concatenated the values, right? The C column in the first table is NN, so it has put an NN there, but B column in the second list is NN, so when it concatenated the second one, it passed an NN in there, right? But it has kept in the entire syntax perfectly, right? Entire values are kept perfectly. So that is what happens when you use concat. Okay, so concat is kind of a inner join. Okay, concat is a kind of inner join. Concat is kind of a outer join. So inner join, if I now show you what we need to do, it will be done using this concat command only, and we will have something extra. So we will pass in the axis value. Okay, so axis means the column, one means the column, right? So we will pass in and we will type what type. This is now inner join, right? So A, B, A, C is there and all the common values are present only. The values where it was not matching, those are removed, right? So this is what is about, oh sorry, axis one means row, right? So if you using columns, then only the common column is came out of it. So between A, B and A, C, only A is common, so A column is came out. So we are passing 0, right? 0 means the row wise and 1 means column wise, right? So we have passed in 0 here, so we are getting this kind of a result. So this has joined it row wise. Now if we do it using 1, so it will just concat those rows, right? So that's how it works. Okay, so 1 2 3, the first data frame was 1 2 2 3 3 4, second one was 3 1 4 9 5 10. So here 1 2 3 1 2 3 4 9 3 4 5 10, it has concatenated based on inner join principle, right? So this is I mean this follows the basic rule of inner join, but the difference is, unlike inner join, it won't give you the exact format of output. So for that we have some other things that we really don't use here. Okay, we use it but we really don't need that for now. That is when we do, like when we access the RDBMS kind of data, right? So then we use it, and then this kind of things are there. So you can there is an SQL utility in Pandas, so where you can pass in exact SQL statement that we have, and you can concat, inner join, merge data set based on those principles. Okay, based on those based on the query outputs, you can merge and inner join those. So that's how this kind of thing works on. So there is another thing. So these are not really used. Okay, joining data frames are not used, or you always will be concating only. Concating or merging things, you will do that only. Okay, so that's how it works. So that is what is about this concatenation thing. We have another thing, that is merge. Now see this will work as a exact SQL join. This thing will work as a exact SQL join. Okay, so how it will work, it is not concating, it is merging the data set. See what is the error here? Key error A, right? Why key error A? Because it tried to join this two data set with column name A, but in the second data set we don't have A, so that's why it threw the error. So what I did, I renamed this column to A. Now I'm coming and I am merging it. See, it works, right? Now if you match it, it is the same output as you do in SQL join. If you do create those two tables in DB, if you check the output, now it will match. So concatenation will give you the result that will look the same as SQL1, but it won't be similar as SQL joins. Merge will give you the output that looks like the SQL joins, and it will be the same thing as I mean it will be working similarly how the SQL joins work. Okay, I will just quickly write these things, all the different kind of joins that we have. Now if you compare all these outputs, right, you will find it that it looks like, see this concat value, how it looks like the first one, right? Like the first output that we saw. So that's how this outer works. So that's what is the difference between merge and concat. So merge will work Similarly, as SQL joins work, but concat will give you the output that is based on the principle of those, but it won't work like that. So that depends on the scenario. If you are working with this like that database, RDBMS kind of database, then you can go for merge. Otherwise, you can go for concat. So it depends on your need and your scenario, how you are using it. Okay. So that entirely depends on the scenario. So that's how it works. Okay. So see here, this when you are wanting to join two things, where you want the common values only, you don't want the entire thing, then you go for merge. If you want the entire value, or not only the common values, go for concat. Okay, so that's how it works. So here you need to decide based on the scenario that you have. So that's how the SQL joins work. So if you do a inner join, then wherever it gets a matching value, it will take those into account. So if you see 1 2 2 3 3 4 3 1 4 9 5 10, and then we are joining on column A, right? How we are joining? We are joining on inner join strategy. So which value of A is matching in both these columns? 3, right? So what will be the output? 3, 4, and 1, right? So if you see the output, what is that? 3, 4, and 1, right? So that's how inner join works. Inner join will compare the values of two columns, and wherever it matches the value, it will take those columns from both the tables, those values from both the tables. So that's how inner join works in SQL, and that's why the output is 3, 4, and 1. Okay, so next part, what we will do, we will see all this thing coming into life. So till now, I was showing you some fake data. I was just taking something out of my mind and I was showing you. So what we will do now, we will see how the real data works. Okay, we will read a CSV file that we have. First, I will show you about the file, how the file looks like and all. Then I will show you what all things we are doing with it. What all things we are doing with it. We will see data cleansing. Then we will see the analyzing the basic stats. How can we take out the basic stats out of a Pandas data frame? So this is some kind of a cars data set. You can have it from net also. If you are not getting it, you can have it from net also. So this is a cars data set. Okay, you just type empty cars, you will get the CSV file out of it. Okay, so in this cars dataset, as you see, we have a few columns, right? We have 13, 14 columns, and in that we have serial number. The next one is blank, it is not named, so it doesn't have any name. Then we have MPG, SIL, DISP, HP, DRAT, WT, QSEC, PS, AM, gear, and carb. Let's see what those mean. So MPG means miles per gallon, right? So that is the mileage of your car. Cylinder is number of cylinders that your engine has. Displacement is again the displacement of the car, that is of disp. HP is gross horsepower. DRAT is rear axle ratio. Okay, so in the rear tire, the axle ratio. W2 is weight of the car. QSEC is 1/4 mile per time. So that is what is, I mean, for 1 mile, the quarter of a mile, how fast your car travels, that is QSEC. VS is engine, V-shaped or straight. AM is transmission, automatic or manual. So for 0, it's automatic. For 1, it's manual. Gear is number of forward gears. Carburetor is number of carburetors. So that's how this data set looks like, and this is the data dictionary for that. So you can easily get this from net. So that's how it works. So that's how the data set looks like. Okay, now what we will do, we will read this file and we will do some kind of cleansing and all. So before that, let me show you in Excel only what kind of values do we have. We have all proper values in serial number. We have all the names. We don't have any nulls. MPG also the pretty same thing. It's good. MPG also, cylinder also is there. Displacement also is fine. Horsepower doesn't have it also. Okay. So it is fine. Okay, for QSEC, see, we have a few blanks. For QSEC, we have some blank values. Others, it will mostly have some values. So 3 rows, we have blank here. Okay, so we will see how we can, what we do with this 3 rows and what all we do with it. Okay, so let's go ahead and let's jump into the code. So closing out this data set and see here what we are doing. We are reading a CSV file. So for reading a CSV, we have this command of read CSV. Okay, for reading a Excel in Pandas, we have a command of read Excel. So if you do it like this, then file name, then sheet name, it will be reading that Excel file with the name. So the format will be XLS or XLSX. Okay, so that's how it will work. So you need to pass in a file name and sheet name. If you don't pass the sheet name, the by default the first sheet will be read into account. For document, what is that? The doc file you mean? Doc file, you won't be getting that kind of data, right? So when you are analyzing some kind of data in here, so that will be in tabular format. That's what is the basic requirement of Pandas, right? So we covered this in the first part only, and in data that will be text mining. That's a whole separate thing. So for Pandas, the only fit-in thing will be tabular data. So we covered this earlier only, right? What is the scope of it? Okay. So see now what is the output here? Only the column for which name was not mentioned. Pandas has renamed it on its own to unnamed :1. Okay. Others are fine. Now, if you see this data set, our first task will be to rename this data. Okay. So this is just to show you how you can change the data type. Okay. So you can, it's an optional step. You don't need to do this. This is just to show you how to convert a data type. Okay. So for MPG, we are converting it to string. So how we are doing? We are writing cards.mpg equals cards.mpg.type within bracket. We can give anything. So here, if you see MPG seems like float values. So we can't convert it to int. If we do it, we will lose the information. So we are converting it to string. So that is not required. This is optional. This is just to show you how it can be done. Now we will see some few analytics functions. So type cards you already know. This is a data frame. Okay. Next is how do we see first 5 rows of a data frame? We use cards.head. So head will by default return first 5 rows of a data frame. If we want to have first 10 rows, then we need to pass in the number into the head function. So 10, 12, 20, 30, 50, whatever you do, it will return those rows from the top of the data set. If you want those many rows from the bottom, then you need to use tell function. Tell will work as similarly as head. It will just start from beginning or from the bottom. Okay, so that's what the difference is. Others will work as same. So tell will return you by default bottom 5 rows. If you mention a number within the tell function, it will return you those many number of rows from bottom. Okay, so that's how cards.tell works. Now to check the shape, same thing, cards.shape, as we have seen in the list and NumPy arrays. So this shape object will give you the number of rows and number of columns. So see here, it's a really small data set with 32 rows and 13 columns. Okay, that is how you can take out a shape. Now, how do we print how many objects are there in the columns actually? So here, see, we are doing cars.info. That means if you run it now, you will see the only non-null object counts that are there. It will be printed over there. Okay, so those will be printed in there. Okay, so all these columns will be printed like how many non-null values are there. So see, only the qsec column doesn't have 32 non-null values. It has, that means it has 3 blank rows. We already cross-checked this using from the Excel only, right? Shape is for returning shape and reshape is for changing the shape, right? So that's what the difference between them. They are two whole different functions, shape and reshape. Anyways, no comparison can be done between those actually. So for the info, we will see how many non-null values are there. So this is the first point you need to hit as a data scientist. Okay, others that I have shown, just know that those can be done. Those can be done in that way. Okay, you can see first 5 rows using head, last 5 rows using tail, like that. If you need to see more than 5 rows, then you can mention the number from either from the top, then head. If not from the bottom, then tail. But as a data scientist, your job begins now. So you need to check if any of the columns have any missing values or not. So that's where this cards.info thing will come handy. Okay, so here, see, in qsec we have 3 null values. So your first thing you need to remember is you will need to replace the 3 null values of qsec. How we do it, we'll show it to you. Next, a few basic functions like to find out mean, median, and other basic stats, standard deviation, cars, minimum value of car, maximum value of car, and the count, how many non-null values are there. Next is count of non-null records. This is also another thing where you can see that. Okay, where you can see that. So that is here, if you see the QSEC column value, then it will be 29 only, right? It will be 29 only. So this is another point where from where you can understand like how many non-null values are in there. Okay, so that's how you can do it. Next is how to get all this information stacked in together. So this is cars.describe. So that is the data frame name dot describe. What it will do for you is it will sum up all the stats that we have seen till now in a single place. Okay, so for if you check the output carefully, it has count, mean, standard deviation, mean, max, and all those kind of values, right? All those kinds of values it will print you it will be printed over here, so that you can get all this information at a single place. Okay, so the function for that is car.describe. So that's how it works. Okay, that's how this function will work for you. Okay, that's how this function will work. Okay, next is cleaning. Okay, so cleaning, as I told you, like this one column is there in the data set which doesn't have a proper value, right? Which doesn't have a proper column name. So for that, what is happening? For that, we are renaming the column. So see, now we are doing cards.rename, then we are passing in the same way that we did in the earlier example. So we are checking in we are getting the cards.rename function, then we are what we are doing, we are passing the columns dictionary which will contain the old name and the new name of the of the row of the columns that we want to rename, right? So that's how we are renaming the unnamed one column to model, because if you see carefully, that information that is there is model name on, right? So that's why we are renaming the column with the name of model. Okay, so we are changing the level of the unnamed column to model. So that was the name. Okay, next is filling in missile values. So which column had null values? As we know, QSEC column had null values. So we are filling the null values using fill na function, and what we are filling with? We are filling with QSEC.mean, right? We are filling it with QSEC.mean. Okay, so that's how we are filling in null values. Now after filling the null values, if you check the data set, it will be fine. It won't have those extra, it won't have those null values in place. Now next is dropping unnecessary columns. So you can understand the first one that we have, the first column, that is serial number. So what is it? The serial number is nothing but a straightforward EP series actually, right? So it is just having some numbers from 0 to 32. So when you do a data science related thing, this kind of data won't help you, because what you will get from the serial number, it doesn't have any pattern, right? It is just a EP series. So you can safely remove it, because for data science you won't need it, right? So that's why we have removed the column using cards.drop. So in these columns, as you can see, it is a list. You can have more than one column name also. Okay. For here, we are using only one column name to remove, that is S number, the serial number. But you can use more than one column name in the column list also. Okay. In the list, you can pass more than one values to remove those. That's how you drop the column. So now the column, the serial number column is removed, and we are left with 12 other rows. Let's see what we do with this 12 rows. Okay. Now next thing is correlation. Okay. Correlation in statistics means how do we like get, how two columns are mutually related. Okay, how two columns are mutually related with each other is the dependency between two columns. That is what is correlation. So how you can do, you can specify the column names among which you need to find the correlation. Okay, so here we want to see correlation of one column to all the other columns that is present in the data set. So that's why we have passed in all the names. Okay, all the names within the second bracket. So that is basically slicing, right? That is slicing. We have passed in a list of columns inside the data frame. So it will provide you all the values of the columns, and it will calculate the correlation using the CORR function. Okay, so we no need to find out, but it will find it on its own with you using with this CORR function. So that is basically correlation function. Okay, now next what it will do, if you see the output carefully, the diagonal elements are all one, right? The diagonal elements are all one because the name of the columns are matching. MPG, MPG, cell, cell, desp, desp, HP, HP, like that. So here the value will be maximum, right? Correlation between the same column. So MPG and MPG will be maximum. That's obvious, right? So where you have the correlation value generally runs from -1 to +1. So that means if the value suggests if the value is negative, then what that means is the columns are inversely related. If it has a plus value, then it can be thought of as the columns are strongly positively related. Okay. So here if you see miles per gallon and number of cylinders is inversely proportional. Okay. So that means to have high miles per gallon, we should have less number of cylinders. So that is also explainable, right? So that's what happens. So if you have more than one cylinder, then the miles per gallon will reduce because your car will consume more petrol, right? To go the same distance, like that. Okay. So this way you can see all the values are printed. Wherever you see a negative values, that means those are inversely proportional. Wherever you see a positive value, that means they are highly proportional. So for displacement and cylinder, see, there is a high correlation. Okay. For HP and cylinder, there is a high correlation. So positive and high is strong correlation. Okay, that's how you can use this correlation matrix. So what kind of thing it will give you? So if you have any data set and you want to check how many, if there is any relation between two features or not. Let's say let's go to a real world example. Let's say we are going to predict the housing value. Okay, so we have square feet of area, we have garden space. So higher garden space means the price will be higher, right? But if you have some unnecessary column in there, let's say we have a column called this is something which is not necessary to calculate the price. What can be? Let's say main code physics or not will be a factor. This will be a factor. Let's say, okay, any obstacles are there or not outside the house. Yeah, wall paint is there or not? Wall paint is not. So if wall painting is there, that means the price will higher. So let's say if the values, I mean, let's say if there are any obstacles surrounding the place, so this kind of things, those are unnecessary things. Yeah, gate size, right? Gate size is a good one, Anvesh. So let's say if the gate size is bigger, then the price will go high, but that doesn't mean, right, I won't go there. If someone is charging me for their society gate, I won't go there, right? So those kind of things you can remove from there. Okay, if you have zero correlation or very small correlation, then you can remove those. So very small means in the terms of double zeros. Okay, 0.00 then something, you can remove that. So if it's less than 5%, you can remove it. That's safe to estimate, but you can remove it otherwise also. You can remove those from the equation. There are a whole lot of scenarios that we will discuss when we go for machine learning. Okay, so that's where you can use this correlation matrix. Next is we are again here changing the null counts to float. This is just we have converted before to string. That's why. Otherwise it is same. So here also we have changed the QSEC. We have filled in the QSEC, right? So the QSEC column that we have is now having 32 non-null values. That means all the columns that were passed in, I mean all the columns that are there have exactly the same number of values. So that means that part is removed. Okay, that part is by now removed. And QSEC has all the required kind of values. Okay, so that's what can be seen from there. This is a repetition. Okay, next is manipulation. So in manipulation, what we will do, we will see how to access the data. This is almost the same thing as we do in list and NumPy array. So I will just quickly go through it. The only new thing you will see here is iloc. Iloc is nothing but indexed location. Okay, so as you know, we can access the columns of a data frame using names also. So if you use iloc, then the indices that you pass in will need to be only integers, strictly integers. Okay, but this is not really used. What we use is this one. So that's how this iloc is used. Okay, so all these things will be integers, and then if you when I tell integers, it will be applied to all the like those indexing and slicing techniques that we have seen till now. Okay, so that is what iloc. So if you check the outputs here, 6 colon 4 colon, that means from 6th row onwards, and 4 colon means 4th column onwards. So like that it will match. So iloc is the same thing as what we have in indexed arrays. It's the same as indexing and slicing of an array, right? Of a list or a NumPy array. So next is slicing by label. So here you see we are passing the labels. So that's how we use it. So we want all the rows for MPG column. Okay, so we want all the rows. We want first six rows for MPG column. Okay, so this is again the same thing, slicing and indexing. So that's very much sums it up. So it is the same thing. You can see. So MPG to QSEC, we want all the columns and the 6th row on, and for the first 6 rows only. So that's how it works. Now next is how can you change the column values. So you can access the columns using this syntax also. Okay, so you can write the data frame name, then within brackets you can pass the string headers. Okay, so am is am drat wt qsec, you can pass it here and you can access it. So no need to use cards.iloc or loc and like that. So here we are using LOC, that's why we are passing in mixed of string and integer. One thing need to be remembered, and for iloc we can only pass the integers. Either all the two parts of the indexing for row and column both need to be integer. For LOC it can be anything. Okay, and to access a column we can use it with a label only. Okay, we can use it with the column label only. Okay, so here what we are doing, we are changing all the am values to 1 just to show you how to do it. Okay, so we are changing all the values to 1 in here. Now next is often you might need to find some derived columns. Okay, next is applying this lambda function. We ran it, that's why we were getting all the values as 2. So this is applying lambda function. So this is just to get some derived columns. Okay, this is okay. VS is a good example. I will show you. So cars, the bracket, condition I want, cars of VS equals 0. Now it will show you all the values where VS equals 0. It will show all the values where VS equals 0. Okay, so that's how you can use filtering. That's how you can use. If I haven't applied lambda function yet, I will do it now. So this is what is about lambda function. So that means what this means is we can find out some derived columns also. Let's say we are not keeping the name as am, we are changing it to 2am. Okay, so that's how we can do it. So we can apply any function on the column also to get a new value. So what we are doing, lambda x equals x star 2. Then we are doing cars am dot apply function f. So it will double all the values of the am column, and it will be double to 2. Okay, so that's how you can apply lambda function to a data frame object or any column of a data frame, more than one column, or you can find out some derived column also. So see, now we have applied the lambda function to this am column. Am was 2 from 2 to am value was 2, and 2am now contains 4, right? So that's how you can do it. I created a new column named 2am, so it will, I intended that, that's why it got happened it, right? Next is sort by values. Okay, so this is how easy is to sort a data frame in Pandas. You no need to write a sorting algorithm and all. So cars dot sort underscore values, if you provide by equal to any name you provide, it will be sorted based on that column name. Okay, so here we have provided cylinder, so the column will be sorted based on cylinder, and you see 4 6 8, that's how it is sorted. So you need to remember this. Okay, sort values, sort underscore values, That's how you sort a data set. And you can pass the option ascending equal to true or false. By default, it will be ascending. If you make it false, then it will be in descending order. So that's how you sort a value in Pandas data frame. Okay, so that's how it works. Okay, next is filter records with more than 6 cylinders. I already covered this, right? So that's how you can do it. So see here, card cell greater than 6. What that does, that returns a true false array. So this will return a true false array. Now let's say I am storing it in a somewhere and I want this. Yeah, so see here, it is written. So filter, I have created a new function that is called cards of cell greater than 6 that will return this true false array. And when I pass it to cards true and false, so wherever it is true, those rows will be returning. Wherever it is false, it won't be returning. Okay, so that's how this filter thing works. Okay, now you can have multiple options. You can have more than one condition also. So car cylinder greater than 6 and HP greater than 300, like that. You can provide multiple conditions and you can filter the array. So that's how you filter and data frame in Python. Okay, so let's go to this data visualization part. I will just show you how you can plot a few curves. So for visualization, we have many libraries, but we predominantly use two libraries, that is Seaborn and Matplot. So here we will show you what is Matplotlib, okay, and how you can use it. So the name is Matplotlib of the package. So we have imported the matplotlib.pyplot as PLT, okay. Then we have done it, we have forced it to render the picture in the Jupyter notebook only with the inline function. Then what we have done, we have plotted the HP column of the car. How we did that? For that, what we need to do, we need to pass in two x and so to plot a curve using Matplotlib, we need to use that plot function, that is plt.plot. In the bracket, we need to provide what should be x-axis, what should be y-axis. We have many parameters in there to pass on. We need to pass in x and y values. So here our y value will be the HP column of the car's data frame that we have. Okay, and x value will be 0 to 32, basically the serial number column. So that's why we have taken in range and x equals range and y1 equals cars HP. Then we have passed in x and y1 to the plt.plot function, and the HP values are printed in a line plot. Okay, so that means for the first row, HP value is somewhere around 120. Okay, for the second row, the HP value is somewhere around 95 or 98, something like that. Okay, like that, this curve can be taken into account. That's how this curve can be thought of. Next one is again another line plot with the displacement. So you can see the displacement values in there similarly to the line plot. Okay, similarly to the line plot for HP curve. Okay, so next one is to merge two curves in the same plot. So what we have done, we have taken two y variables, HP and displacement. We have placed both in there, and see this kind of a beautiful curve is being displayed over here. And this legend is also being added with this plt.legend. So see how we can visualize the data, as we are working with a data set. So it won't complete without showing you this. That's why I am showing you. Okay, so that's how you can visualize this kind of data sets. Okay, yeah, next one is stack plot. Okay, this one is called a stack plot. This is stack plot or area plot, whatever you can consider. Okay, so this is the same thing basically. This is the area chart or stack plot, any way you can mention it. So see here, it will show you the area covered. I am going to the second example. So it just shows you what is the area covered by the curve. Okay, what is the area covered by the curve? We have two plots here for HP and DISP. So we have two areas covered. So this is stack plot and this is area plot. That's how we plot this. This is to show you the area covered by the curves. Okay, so that's how this works. This is bar chart. This is a very popular chart among IT people. Everyone knows this chart. We use it frequently for presenting our estimates and all and all and all. So this is very popular. So this is how it looks, this bar chart, and for that we use plt.bar, okay, to plot this bar chart. So we are plotting the car models and the car's HP in a plot. So that's how it is. So here the plot, the car model names are there. These are the HP values of the car that are plotted using bars. Here it is using horizontal bar. For that we need to use bar h function. Okay, so that's how it works. So here also model name and HP. Model name and HP we are plotting in a horizontal bar. Okay, so that's how you can do it. So that's how basically you can use Matplotlib and Pandas object hand to hand. Okay, so which of the following will be used to read CSV files? So the which of the following is used to read CSV files? Which one? pd.read underscore CSV, read underscore file, or data frame.read underscore CSV, which one? So next is what will be the output of the following? So that means that is ARR equals 1, 2, 4, 5, 7, 8. Small lists are passed. Then DF equal to data frame ARR. Index equals ABC. That means the row names are ABC. Column names are capital A and capital B. So how the array will look like? A, B, C, capital A, capital B, 1, 2, 4, 5, 7, 8, like that. So 3 rows will be there. Okay, 1, 4, 7, 2, 5, 8, and the name of the rows will be A, B, and C. Small ABC. Name of the columns will be capital AB. Now we want to have colon, comma, capital A within quotes, right? So what will be the output? So A is the correct answer because we have passed in the row labels to be ABC, not 0, 1, 2. Okay, what is the output of the following? Okay, see here the march function that we have used. pd.dataframe 1 colon 1 a comma a, and df1 is 1 comma a. Okay, df1 is 1 comma a. Now small a is capital A, small a, capital A, small a. This will I need to type. So basically the output, which one it will be? A will be joined 1a. So here if you see 1 colon 1 and a colon a, 1 means this array 1 1 1, and a means this array a. So the arrays will the first array will look like 1 will be the column header, a will be the column header, 1 1 1 is the value. So this is the first column of the first array. This is the second column of the first array. This will be the second column of the second array, and this is the second column of the second array. Now if you inner join, the middle one will be common and others will be merged. So that is the output. So A is the correct output. Okay, next is import pandas as PD. Data frame 1 equals pd.read underscore CSV, some dataset dot CSV. Now to view first 15 rows, what will be the command? Should be D. Next is to rename a column in given CSV dataset. Which command is used? We need to mention the like argument if it's a column or index, so row or column. So columns we need to specify. Okay, that's what is about pandas. 2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings, so that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, object name dot function name. That's how we use it, right? That's the OP basic. So that's how we do it. Okay. Yesterday you saw we can integrate this using pandas, and as pandas is based on NumPy, so NumPy is also possible. I have shown you examples, but this matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay. Next is very wide variety of graphs. We will see that next, like what all types of graphs we have in Matplotlib and how that can be used, and what are the usage of those graphs and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is I mean that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used the alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is. Next, what we are gonna see is what are the different types of plot that we have. Before that, let me come to this inline thing. So this inline function, if you don't have it, it will still work. Okay, this percentage matplotlib inline, you won't see a difference in Jupyter notebook. Okay, because this Jupyter notebook is anyways browser based, right? So this won't give you any difference when you use Matplotlib from any web based or any kind of notebook kind of scenario. Okay, but if we have a different set of, I mean if you are running Python separately, right? If you are running Python separately, correct, using Spider, it can be Spider, it can be a simple command prompt of Python, anything can be there. So if you are running it from those, IntelliJ idea means PyCharm. Okay, for Python the ID name is PyCharm. So if you are running using those IDs, or if you are running using like what, let's say if you are running it from the command prompt, then this will create a separate window. So that's where it gets difficult. Okay, so that's where it is, I mean it is advisable to use this like NumPy, I mean sorry, this Matplotlib inline command for having the graphs inlined to the screen that you are currently using. Okay, otherwise what it will do, it will create you a whole separate thing. Okay, so it will give you a different set of, I mean a different window where you will see the plot. So that's why we use this Matplotlib inline. So that's the basic standard, to have it displayed in the same window. Okay, so that is why we use Matplotlib inline. But if you don't want it, if you want the separate window to pop up, it will also work. Okay, that will also work. So that's no need to be worried. Okay, before that, let me show you what.
Let's have a quick quiz question, guys. And the question is, which of the following machine learning algorithms is a type of ensemble learning? And your options are normal distribution, Poisson distribution, beta distribution, or exponential distribution. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Are the different types of plot that we are having in Matplotlib, and what are their uses? Okay, then we will go to each of the examples one by one. So if the what you need to remember from this whole lecture will be 2-3 things. Okay, first of all, why and what plot need to be used, where it need to be used, and how you can write those. Okay, customization, even if you learn it slowly by playing with it, it's perfectly fine. I don't That's not a matter. Okay, the customization thing, coloring thing, changing the axis labels, adding legends, changing the colors, there can be thousands kind of customization in Matplotlib. Okay, so Do I have that mail with me? No, I will have it my official email ID. Okay, so what I did for some requirement, I created there is some kind of graphs and charts that goes to higher management. Okay, for reporting purpose that goes every day. Okay, so I created something using Python. No data science is involved. That's a straightforward thing, much easier. So I created a simple script or simple job using Python. What it does, it takes in data from a rdbms, it plots the data nicely in a matplotlib plot, and it sends it to you, sends it to the upper management. So when we are, I am telling upper management, that is D plus. Okay, so that's where this comes handy. So in there you understand, right? When we are going to show this to upper managements, we need to have the graphs beautiful, we need to have all the specifications, we need to have pointers, we need to place them in the right position so that they don't find any errors and they won't accept anything so easily, right? So that's how powerful matplotlib library is. I don't have the I can't show you that because that's not allowable. So otherwise I would have shown you. So that's how you can do it. So the graph, what I can do, like the simple graphs that you are seeing in here, you can change the background color of the graph. Okay, so the background will be of some different color and the foreground will be of some different color. As you are seeing there in the right hand side, we have a bar plot, right? In the bar you can choose each and every bar color one by one. Okay, that can also be done. All these bar objects can be accessed individually. Okay, once you plot these bars in matplotlib, right, all these individual bars can be accessed one by one. You can change their width, you can change their height, you can change their color, you can set text to them, you can write text in between them. So whatever you can do in Excel with all these graphs, the same things can be done in matplotlib. But again, those things are not required for your day-to-day work. It will require very rarely. So if even if you don't understand those, if you even if you like the NSCOM quadrat I have shown you, if I start explaining the whole graph, it will take the entire class because it has too much customization in it. Okay, so just to keep it short and just to give you the proper idea so that you can start experimenting or playing with it, the basics I will tell you. Okay, and on the basic you can build up. Okay, you can build up on the basic. If you do understand the core concept, you can easily build up. So, and also if you are facing any problem, you can tell me in the next class also, I can help you. Okay, so that's how powerful matplotlib is. And let's see what kind of graphs we use. We have line plots. So line plots, what we use just to plot 2D equations, right, with x and y. There we will use line plots. Okay, so line plot will give you a trend line in an equation. Okay, so when we see linear regression, we will see its use pretty heavily. Okay, for machine learning, and also for observing a data set how it is distributed, this is really needed. Okay, next is bar plot. This is the same as line plot. The difference between these two is you can add a trend line in bar plot also, so that way it will become this, but this denotes the area covered by the point. Okay, so the bar will start from x-axis and it will go, the height of the bar will equal to its y value, and the shaded area will be showing the area covered by that point. Okay, so that's where bar plot is needed. Bar plot is basically this, it is required in the same way we have line plots. So what is different in here, in line plots you might not be able to tell what is the value of x for the value of y at x equals 17.5. You need to go there, you need to see, it will be difficult for you. But in bar plot you can see it there directly, right, because the bar will do that. Significance of width, there is not much, it is just to illustrate. Okay, illustrate this bar one. Okay, this is that is how this bar is designed. So bar means it will show you some area covered by the curve. So if you calculate this rectangle, so what it has, this rectangle is same, this rectangle has this width of some x value, height of this y value, right? So if you calculate a rectangle covering that area, so this will denote the area covered by that point. Okay, by that x and y point, from the ending to beginning, this area will be covered. So area is shown here. Next is scatter plot. So scatter plot and line plot again are same, but only difference, the points are not joined. So you need to understand when we use these two. When we have a continuous set of data, we know that it might fit a linear equation, right? Yes, Azam, I just explained it. What is the significance of the area, right? So in the line plot, if you have if you have a like continuous set of data, then in that case this line plot will be visible. But if you don't have a continuous set, if you have some chunk of data, clusters of data, then you will use scatter plot. This is to see the data distribution, how they are distributed, and this is the trend line of the data. This example of scatter plot you will see when we are covering clustering. You can understand, right? We have seen some clustering algorithms. So if you plot the data in this plane, then from that you can easily understand how many clusters will be formed from that k-means, right? The k value you can find it from your you can find it by checking that manually only, right? If you plot the data, it will be clear to you. After clearing the data, if you are able to plot that data in this plot, you can find the value of k without any hack, right? And you can pass it to the algorithm to give you those many clusters and their centroids and all. But what you not need to do is you no need to check the data points and decide which point will be belonging to which cluster. Those things you no need to calculate. Okay, next is this histogram. Histogram is basically used for image processing purpose. This histogram shows you basically, okay, so this histogram is basically used for like image processing purposes. And what these bins are denoting, this bins denotes the number of times the values, the frequency of the values, the frequency of each point occurring in the data set. Okay, so that's what these bins are denoting. So this is not really used in data science, somewhat used, but it won't fit our purpose always. So maximum for image processing this is used to see how the data is spread and what are the frequency of the data point that we have, what are the frequency of pixels that we have, those kind of cases, and histograms comes handy. I will show you all these examples, but again this is not really required. Image plot, again this can yeah, CPU processing is also histogram, right? So that's what. So wherever the scenario fits in, to show you some frequency kind of thing, wherever it fits in, then you can use histogram. Okay, wherever you need to find out some frequency of some point in dataset. Let's say for CPU processing, if you see the graph how it will look, it will give you how much CPU is used in what point of time and what is the frequency of high CPU uses. In that case they will use histogram because it will give you the frequency related data. Okay, difference between bar and histogram is bar plot won't give you this frequency, it will just plot the x and y points. It is almost similar to the trend line, except it will show you the area, it won't show you the frequency. But from histogram you can find out the frequency. When we go to example, let's see how we can do that. Okay. Okay, next is image plot, right? Image plot is to plot some image. Okay, again you won't need that. So image plot will fit in a existing image to this to the 2D plot, and it will show you the height and width and all those things you can see visually. Okay, next two plots are really important for us. Those are box plots and violin plots. Okay, so let's do one thing. Let's see the examples of all the 5 plots that we discussed, then we will discuss the rest 5. Okay, rest 5 or 6 whatever we have, we will discuss those after that. Okay, let's see these examples first. So this line example I have already shown you. Now the next one is how to customize these lines. So basically these are the basic customization technique I will show you. So see here what we have done. We have taken the same example as the earlier one, just we have reduced the number of points. We have used this fig equals plt.figure, fig size equals 10,5. So this one, this plt.figure object, what it does, so if you don't use it, that also work, but how it works is this plane is a single plot. Within the plot you can create multiple figures. So let's say you want to create two charts side by side. In that case you will use this figure. Okay, you will create a figure size, I mean you will create this 2D plane first. Okay, then you will plot this line. That is the best standard practice, so you should follow that. Okay, you will create a figure object, then you will plot the data points. Okay, that is the standard that we do. So how do we do that? What we do, we use plt.plot function as shown before. We are having x and y, two values for x and y data points. Next we are passing is this line width parameter, right? So this is to provide that line width, what it will be. Next is line style. It has many different line styles also. It has dash, you can give 0, you can give O, any character you can give. Let's say I am giving I, and if I run it, it won't run because I is not a supported character. What was that supported one? I don't remember. I think dash was supported. Yeah, so this line style you can provide anything. Okay, sorry, not line style. Line style will be dot dash, these two things only, or a continuous line. I was talking about this marker. Marker you can put anything. Okay, so marker you can put something like this also. Unrecognized marker, except to what we had cross, I believe. We had cross, yeah, we have plus, those kind of markers are there. So this marker object is to show you this points. Okay, show you this data points, how you want to see those, but O gives you the best visualization among all. Okay, so that's how you can use it. Okay, next is this line style is for styling this lines, this intermediate lines. If you provide colon, then it will be like this dashed line. If you provide a dash, dashes will join, right? So dashes will join, and you will see a straight line. So that's how this works. Next is color. You can provide any color. You can write the full name also. You can use the short name also. You can provide here the RGB values. You can provide. Let me show you. You can provide this hex values also. You can do anything. Okay, let me take the default color that is coming. So I will show you this to example. Come on. Okay, if I tell it take it this, and if I put it here, this will also work. Okay, see the lines have changed to blue, right? If I provide this, that will also work. I don't remember the syntax for RGB. RGB is not much used, but still, okay, sorry. But still you can provide like this, I believe, and RGB like this. No, RGB is not the thing. RGBA, how was it? I don't remember. Okay, RGB styling in Matplotlib. Just let me check it. Check in Google. I will show you. Just a second. RGB, anyways, we don't use it much. We use the simple names or hex codes, because hex codes you can find in many places. Like in net, you can have it easily available. You can create your own colors, but RGB we really don't use in plot. Yeah, so that's how. So I will still show you because it can be done. So I believe we can only mention the tuple. We don't need to write anything in behind. Let's see. Still it doesn't work. Why? How to give it? Just the tuple without this single quotes? I believe yes. Let's see how it works. Still not working. Okay, how do I give it? How do I give it? Why it is not working? Not sure. It should work like this. Somewhere it is not working somehow. Not sure. I will check in the break and I will tell you. Okay, this one I will tell you. So you can provide the hex value, or you can provide the mnemonics also. You can type in any color in full also. If I type it yellow, it will also work. Okay, so that's how you can use this color attribute for all the graphs. For all the graphs you can use it. Okay, so you can type in any color, or you can provide the hex codes also. Okay, so let me give some good color here. So that's how it works. Okay, that's how this color attribute works. Next is for alpha. Okay, alpha is for reducing the brightness. Okay, reducing the the transparency of it. Let me give it blue. That would look the best. So that's how. So alpha is the transparency. Okay, alpha is the transparency of it. Yeah, that is not working, Nancy. I also remembered the same thing. RGBA is not working. RGBA, nothing is working. So I will check and tell you, no issues. Okay, next is alpha is for reducing the brightness. So let's say you will understand on your own only. I no need to explain. If I run it to 1, see this is much vivid. But if I do it 0.1, you will see this is way too dim. It will be way too dim, right? So that is what is alpha. Alpha is for reducing the brightness. So alpha is the transparency factor. So if you reduce the alpha, then what it will do, it will make the line or plot whatever you are doing transparent to the plane. So it will match the background color of it. Almost it will match the background color of it. It will be a very fade color. But if you pick a high alpha value, it will give you somewhat deep lines. Okay, you will see the dark lines, dark colors over there. Okay, so that's what is alpha used. Marker, as I have shown, these points are called markers. So that's how we plot a line. Next is this title object, right? This title function. So what we do with this title, we plot this title like line plot demo. This we put it using this plt.title, and it will automatically be placed here. Okay, it will automatically be placed at the top. You can change it to bottom also. You have options for that. But the basic that we follow, the standard, that is to put it in top always. And x level, y level, x axis, y axis, you can type it. So the labels, x's will be labels. Okay, x's will are labels. It is not for the value, it is for the labels only. Okay, that's how it is. And for the limit of it, the graph will take on its own. It is best to leave it on its own, because it will be helpful. Because if you are trying to manipulate the graph, because see, you will always not know this, right? That how much data you are covering, how much data you are taking, like that. So that's why this is best to leave it on the graph itself. So it will decide the best min x min y, min x min y, and max x max y, and it will plot it. Okay, so that's how it works. Okay, next is for plotting legends. Legends means this small markers. So to show someone which one line denotes what, right? That is what is legend. So for plotting legend, what we do, we use this legend function. Okay, we use this legend function, then within bracket we line the marker name. It can be a list also. Okay, it can be a list. If we had 2 lines here, let me show you. That will also work. Let's say I have an orange object now with marker as cross. Okay, and it is darker. Let's make it darker. And if I run now, you see we have 2 lines now in the same plot, right? So how you can have here, you can write like this, and see everything will be taken care automatically. Okay, see here in legend it's already added. The my line thing is already added, and LOC equals base means the graph will on its own calculate the best position for the legend, and it will put it. So it will always put in the best position. It can be down, it can be up, it can be anywhere. Okay, plt.grid true, that is to show these grid lines. If you don't want it, just don't mention this function. It won't show you these grids. Okay, so that's up to you. If you like the grids, you can keep it. If you don't, you cannot. So there is no really no real thing in that, in showing or not showing the grids. Okay, somewhere if you fill it, you can provide you can have those displayed. Okay, so that's how this grid works. And plt.show, as you know, to show the plot, to show the to display the plot in front. So that's how this thing works, this line plot works. Okay, so that is what is about line plot. And you have seen only single line plot in a picture, right? So I have shown you 2 line plots in the same graph, right? Let's say we have two different plots in the same we have two different subplots in the same plot object. How do we do it? Okay, so that is where this subplot function comes into picture. That is where this subplot function comes into picture. So if you see carefully what we have done here, we have taken the same thing, the same functions that we used in the earlier example, and we have shown you this. We have shown here the two different plots in the same thing. Okay, we have shown two different plots in the same figure. So that's how. Okay, so the next thing is the parameters that we have passed and how do we create this subplot. Okay, so how do we do is, firstly what we did, we used plt.subplot function. Okay, so subplot function, we have, there are many parameters that can be passed on to it. Okay, there can be many parameters. So we have provided only 3 parameters here. This is just to have it in a standard one. Okay, so how does it work? Okay, that means the first one, 1 2, right, these are for number of rows and number of columns. Okay, so we have created one number of row and two number of columns. Why one number of row? Because we want this to have in a single subplot, right? We want this to have in a single plot. So see, when I change it in 2 rows, so this first one gets smaller, right? Because it has created 2 rows. First one contains the first graph, second one contains the extra portion of the second graph. So always try to have n rows as one if you don't want to create more rows. Okay, so sorry, for the first subplot, for this first subplot, if you create 2 rows, then the same area will be divided into 2 parts. So the graph became smaller in and got fit into one row, and the next row is left around. Okay, so that's how it is created 2 rows here. So here, so the idea is, if you want to fit 2 graphs in the same subplot, then only go for this 2 1. Okay, but standard is to use one, because we generally, when we subplot it, we want the subplots to contain one graph. If you want to fit in 2 graphs like this, you can create a separate subplot here and you can plot the graphs. Okay, so that's how this plt.subplot is used. See here we have passed in number of rows and number of where we have passed in only plt.subplot, we have passed in some integer numbers. plt.subplot 221 222, so these are just integer numbers, right? So this is 221, this is 222, the starting point of the subplot, and the plot will adjust on its own. This is also an expression that we use, but this is not standard. Okay, this is not standard. This is just to have 4 plots, 4 plots arranged in a rectangular way. The standard is always this one. So we pass the number of rows, number of columns that we want, and this one is for number. So that means how many figures are there. Okay, how many figures are there. So this thing, the pyplot.figure function that I have shown you in the earlier part, that will be called, and the figure number will be attached to it. That means this is figure number 1 and this is figure number 2. Okay, so if you want to customize it using this figure object, then you will see how you can use it, but that is not really required. Okay, for now, just know that this is a number parameter that is being passed into this function, and that denotes how many number of, what is the figure number that is there in the graph. Okay, so for the next one, if you see, we have created the same subplot size 1 2, and we have provided number equals 2. So that means this is a figure 2. So this is figure 1, this is figure 2. Okay, the rest function the same as what we had in this. So plt.title, it has plotted these titles of graph 1 and graph 2. plt.show showed you the graph, and plt.plot plotted this x and y1 and x and y2, these two things. Okay, so that's how now line plots can be created and customized, and also multiple line plots can be created in the same subplot. So this applies to all the other graphs that we are going to see. So we won't show you those in that much detail, but you can always create a subplot. You can fit in 2 bar plots, 2 line plots, 2 scatter plots, anything you want in there. Okay,
Number of
so
columns. Number of columns means like one on x-axis and one on y-axis, or what? How?
no, number of columns will denote the width of it. Okay, the height and width, these two things. So if I give it 1, it is so small that it just went out. So that means if you want to divide this, right, how many columns you want in the figure. Okay, so so we want 2 graphs to be displayed, so that's why we set it 2. If we do it 3, that means we have a provision for the third graph to be displayed, and see, this graph is smaller, right? So if you change it to 3, it will be smaller, because it is providing you option for creating a third graph here. So the entire figure, how many columns are there, so that's how it denotes. Okay, so that's how it denotes. So if you do it 1, only 1 graph will be displayed. Okay, so that's how it works. Okay, so that's how you can create this subplots. So is this clear? Then we can move on to this bar plot. Okay, so bar plot is basically to show you some counts, to show you some this is basically used to show you counts. Okay, so see here what we have done. We have created a data set with 3 this is a dictionary, right? So we have count for apple, mangoes, lemons and oranges. Okay, for x-axis we have taken the dictionary, the list of keys from the dictionary, and for the y-axis we have taken the list of values, that is the count for those. Again, we have created a figure size. How do we plot a bar chart? We plot a bar chart using plt.bar. We passed in x and y. This kind of nice little rectangles are shown over here. So this is 15 and this is the area behind this curve. So next we will see how can we change the width and all of this curve. Okay, so let's go to this one. See here, this is actually this like horizontal bar graph. Okay, so here for horizontal bar graph we have taken the same data set, we have used bar each function, right? So bar each and bar both will have the same kind of customization. This width will be decided on its own, you no need to specify that. Again, as I told, you can change it, height and width you can change, but that is way too advanced. Take your time, you can work on those things later only. Okay, so this can be done. Just you, if someone asks in the interview, just tell them yes, we can customize those, it is not by default. But how that is a really advanced topic, I don't think interviewers will know also. Okay, next is data. How do we create horizontal bar chart? This is a reverse bar chart. So here we can have bar each function to be called for the plot, and similarly we pass in the arguments. Now the next thing to be covered is like bar and bar chart customization will be same as both will be same. So here beside this I can provide the colors also. Okay, so colors, let me put, say what should I put? Let's say I put maroon. So next one I will make it green. So that's how it looks. Okay, so you can pass in the color object, color parameter to it, and these bars will be colored according to that. Okay, so similarly for bar and bar each, same things will be applied. And this plt dot title, x level, y level, we have already seen, right, when we covered this line plot. So similarly those can be plotted. So see here, bar graph demo, quantity, fruits. Here also you can put it in the similar way, you can put it in this way. Let me show you, copy is not enabled file. So the similarly you can do for bar and bar each. So remember, bar is for plotting bar, bar each for plotting horizontal bars. Okay, so that's how bar plot looks like. Okay, so that's how bar plot looks like. Now next, any doubts in this, or scatter plot is fine now? So now we will go to the scatter plot. Okay, so scatter plot, see, scatter plot is a bit different. It is not like x and y equation. So we have 3 data sets, a, b and x. So this is x and y equation actually. So for this x value, this is y value for 1. So let's consider this as x and y and consider this as x and y1. Okay, so no equation we need to do. What we can do, we can just generally point these things. Okay, we can just distribute the points over the plot. Okay, so that's how we did. Okay, and this points will be taken automatically. Okay, the colors will be taken automatically. So next we will see how can we customize it. Okay, these are the basic customization techniques, not advanced. Many things can be done with it, just remember that. Okay, so again I will change it tomorrow. Okay, so here, okay, next thing to be show you is for line plot we use plt.plot, right? For scatter plot we use plt.scatter. We pass the x and y arguments inside this scatter, and then we get this nice looking output. Okay, next is customizing scatter plot. Same equations we have taken. So this C, either you can write C or you can write color, any way it fits you. Okay, S is for size, that means size of these things. If you make it, let me add another 0 and run it. So it will bigger the size of the data points that you have. So size, that is really size, you can write a whole or you can mention the short name, anyways it will work. Okay, edge colors means if you see these lines carefully, the edge is colored as yellow. Okay, because so edge is colored as yellow. So for, if I do it black, you will see that, I believe it is really hard to see here. If I make it 1, I think you can see. Yeah, now see the green round objects are covered by a black border, right? So that is the edge colors to differentiate between 1 and 2. Marker, it can be different kind of things. So marker have 0 o 1, if we give, it will give you some this kind of downwards value. 2, if you give, it will give you some upper kind of values. For 3, you will have the in the reverse side. Okay, in the reverse arrow. And 4, you already have it, right? Or if you put O, it will be the round objects that is going to be put. Marker, can we customize? No, we cannot. Okay, so these are the choices for the marker object. Alpha, as we discussed earlier, alpha is for the same thing. Okay, alpha is for the same thing, to reduce the brightness of it. Okay, next is plt.legend title x level y level, same as others. plt.grid, same as others. So now if you see, we have a plt.savefig scatterplot.png. So this is to save the output of the curve that we discussed earlier, right? This is to save the output of it. So if I go back to my Jupyter notebook, see here scatterplot.png is saved. And if you open this graph picture, you can see, and then you can use it for your own purpose. You can attach it in mail, you can send it, or you're going to do whatever with this. Okay, so that's how you can save the figure to a nice looking image. So that the command for this is savefig, plt.savefig. Okay, so plt.savefig, that's how it works. So that's what is with scatter plot. And now next is this histogram. Okay, so is that clear? Next is histogram. So histogram is to show you counts for some numbers. So we have taken a huge data set to show you this counts. Okay, and we have created the histogram using plt.hist function. Okay, next we have passed in the array that we need to plot in histogram, and we have passed in this bins, right? So bins means where these markers will be put in. This is again intuitional, you can put it anywhere you like. So these are the markers, the marker points. So 0, 20, 40, 60, 80, 100, like that we have given. So how to, yeah, bins are intervals only, correct? So how to understand this histogram? So can you check the data? If you check the data set and if you see how many points are there between 0 and 20, 1, 2, 3, 4, 5, 6, 6, right? So if you check this, so 20 we have 1, leave it. So till until 20 we have 5 points, right? If you check from 0 to 20, what is the value? What is the y value? 5, right? For 20, so from 20 to 40, if you count, we will have 7 values. So it will be going up to 7. Okay, 40 to 60, it is really small, right? Only 1. So see here, the height of histogram shows you 1, right? 60 to 80 if you count most of the numbers. So 68, 64, 62, 60, 70, 78, 75, 79 and all those numbers. So almost 7 numbers. 7 numbers almost. So if you check, or 8 numbers, whatever. So you will see 8. Okay, 80 to 100, 3. So 3. That's how to understand histograms. Okay, that's how you need to understand histograms. So that's what histogram denotes. Histogram denotes the frequency of data points between a range. So from 0 to 20, how many? 22. So what happens if we add another bin, right? The graph shape will change radically. Why that will change? Because within 0 and 10 we don't have any point, so it has kept it blank, so we haven't put the marker over there. Now let's say we are plotting a marker in 30. Okay, we are changing this to 30. So see it, from 20 to 30 the bin has changed, right? Because we have created two different markers. So 20 to 30 we have a dip, right? We have a dip. So within 20 and 30 we have 3 points, and 30 and 40 we have 4 points, like that. So that's why between 20 and 40 we have total number of 7 points. Okay, that's how to understand this bins attribute, and that's how to explain a histogram to someone. Yes, right, it will be changing with data, correct. Okay, so this is to color the histogram. We Yeah, so that's what I'm telling, right? So that's what I told earlier only, right? Before starting with the examples. Bar you will see when you just need to, when you have the counts of some data points, you need to display those in a graph. So that's why when you use bar. Linear equations, when fits into scenario, you use line. When you want to see the distribution of data over a plane, you use scatter. And when for image processing kind of thing, and when you need to find out counts of data points, you use histogram, right? You don't know the counts, you want to find out without writing a code. You can, if you plot a histogram, you will have the count. So that I told when I covered the theory part of it, right? Okay, next is customizing histograms. Again, we have provided this bin numbers. Age color we have provided as black, and color we have provided this funky red color. Okay, title, X level, Y level, grid, Cephig, already you know this, right? So same thing, not wasting much of a time. So age color and color, we can do it in all the graphs, and we can customize the graphs. Okay, so that's how this works. That's how this histogram works. Okay. Okay, so that's what we discussed till now. Image plot is not really required. We are not so for now I am skipping it. It's not really required. Do I have it? No, I don't have it. So any images can be plotted into it. Okay, so that much you can remember. So that will be enough for you. Okay, so that's how it is. Okay, so that's what we have till now. So next we will discover box plots and violin plots. So let's have a 20 minutes break and come back. We have a lot of theories in mind. So then we will discuss this. Okay. So box plots and violin plots are hugely used. I will tell you when and where to use it. So any doubts till this bar plot, or is it okay? We can go for a break and then come back and go for this box plot. Is this fine till now? No questions? Then we can break here.
So one question, like each plot has its own significance, right? Exactly, we have to, for a linear we have to use a line plot kind of things, right?
Correct, right.
Histogram we have to use in one place, and bar, where exactly we are going to use the bar and all?
When you have the counts defined, you use bar. When you don't have the count, you use histogram. Okay. See, this is just to this is why we are using data visualization. Again, have the concept clear. This is nothing but showing a showing the data in a graphical way, right? So if you tell this data to the clients, it will be hard for them to understand, and for you also, you would need to read this carefully and all, because in real world data set only you have already seen 300 rows, right? But in real world data set you will have 1 lakh or 2 lakh rows of data. That will be pretty much on the cards. Okay, and me and you don't have the infrastructure to run that, so we are limiting to small examples. So in that case, when you are going to find out all these insights by manually checking, it will be impossible. So that's why this plots. So you need to understand the scenario and you need to apply it. Okay, so that's how. So let's get started. So if you see this box plot, right, box plot contains the quartile information of a data set. Okay, this is the statistical plot that we use heavily. So this below line will be your Q0 and the top line will be Q4. In between, this will be your mean, that is Q2. This will be Q1. This will be Q3. Okay, 4 lines will be there. Now this is how this data will look like. Now how do we calculate those Q1, Q2s? Okay, I have considered this data set and I have calculated all those calculations. I have done all those calculations in my Word doc. Okay, in Word doc we have all these calculations. So what we are doing, we are just having the equation. We are just sorting the array. So if you sort the array that is given, you will get this kind of an array. Okay, this array you will get this one. Okay, so next what we are doing, we are is we are finding out the second quarter. We are finding out the mean of this. So how do we find out mean? What are the number of points? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So we have even number of points. What is the definition of mean? Mean is the middle point of the data set to which all the left values will be less than to that mean, and in the right side we will have greater than or equal to the mean, right? So we have taken, and for odd even number of values we take the middle two values. So we have taken these two values, we found out their average and we found 20, and 20 is our mean. Okay, 20 is our mean, and this 20 is referred to as second quartile also. Okay, now so this is the mean. Okay, so here we split the data set. Okay, here in this 20 point we split the data set. Now as we have two middle points of the data, so 2 point we can consider in the for two parts. First let us take this part. Okay, let us take part from this to this 20 and part from this to this 20. Let us take this two part. Now this is already sorted, so we will again calculate their mean. So here if you see 5 number of data points are there, so that means odd number of data. So we will have the midpoint, that is 10 as our quartile, so 10 as our mean. So this mean is called as Q1. Okay, this is the first quartile. Okay, from 20 to 70 we have 30. This is called Q3, third quartile. So what this does, this gives you this three Q1, Q2, Q3 informations. And if you see Q0 is the minimum number and Q4 is the maximum number. Okay, Q4 is the maximum number. These two are first and fourth quartiles. Okay, so 0th can we say 0? So that is our first quartile, second, third, fourth and fifth quartiles. So we have 5 quartiles. So we generally consider this Q0 to Q3, Q4 is the last one, so we don't really consider this as a quartile, but you can tell it like that. So this information will be pasted in the box plot. Okay, this information will be provided in the box plot that we have in here. Okay, that we have in here. So if you see carefully, for the first, this total, this is the box plot for that. What was the minimum value? 1, correct? So here it is 1. What was the first quartile? 10. What was the mean? 20. What was the third quartile? 30. And this sums it up. Okay, this 30 sums it up. So this is the box plot. This much you focus on, and the max point, that is what I was referring to as Q4, that is not there, that doesn't present, that is not present anyways. So here it is. Okay, how this height is defined? From 10 to 30, how many points are there? 6 points. So that's why this box is a bit bigger. Okay, that box is a bit bigger. So this, the height of it's almost 6. So that is what this height denotes. Okay, from 10 to 30, how many values, like that. Okay, so that's what is this height about. Okay, that's what is this height about, or you can say it like Q1 and Q3, in between this height is given. Okay, so this box means here the maximum number of data points are concentrated in here. So between 10 and 20, how many points are there? If you check, so we have 2 10s and 3 20s. So in a data set of 10, we have 5 values within 10 to 20. right? Within 10 to 20. So that kind of information you can get from there. Okay, that you can get from this box plot. So it basically shows you again the distribution of the data and the basic statistics of the data, the quartile range, and how and where and which part of the data is concentrated. Where the data is more concentrated. Okay, the height of the box is how many points are there, like that. So 10 to 20 or 10 to 30, we have 7-8 data points, so the box is a bit bigger, like that. And from 0 to 10, we have 3 data, so that is the height. Okay, it won't match with the graph, it is just for visualization purpose, it won't match with the graph height. I am just telling you for ease of your understanding. Correct, that is IQR actually. So IQR is, this is between Q0 Q1, this is between Q1 Q2, this is between Q2 Q3. Okay, so that is what is the frequency of the data, right? So that's why we calculate IQR. IQR is to give you a rough idea about how the data is, what is the frequency of the data, how it is spread in a in a range, right? So that's how this works. This won't match with the box line. So this big lines are IQR, interquartile range, and how many data sets are there, like that. So that's what is about this box plot. So here we haven't done many things. We have taken 3 distinct lists. We have taken all those into a single list, and we have plotted the data sets, and we have plotted that using box plot. Okay, that is the command for that. We have told it to show the means. We have passed in that show means to be true, so that's why that orange dots are shown. Okay, those are the means actually. So that's how this box plot works, and that's what kind of information you get from this box plot. Okay, that's what kind of information you get from the box plot. So this is what is about this box plot. Others I have already explained, so not repeating those things. And if you go on this code perspective, we have taken 3 different lists of total, order, and discount, and we have combined all those 3 lists into one using this list command, and we have passed 3 separate lists to plot it. This is just to have the information handy, because this is just to follow the syntax of the box plot, because it takes in the entire data set and it will create 3 boxes for 3 different data sets that it has. Okay, so that's how this box plot works, and that's what kind of information we do have from this box plot. And generally speaking, when you start analyzing data, you will use this box plot to quite some time. Okay, to check the data distribution and to check the quartile range, to check how it is distributed among the quartiles and like that. Okay, so that's what it is. Okay, see, don't think about the height much. So that height is basically the IQR, that is the distance between Q0 Q1, and that shows how many data points can be there. Okay, so that's what is this height reflects. Okay, height doesn't have much of an scenario here. So this is just to connect the plot and show it like a box. That's why the heights are there, and the distance between 2 quartiles are called IQR, that is interquartile ranges. Okay, so the the value of the height is interquartile range. So that is the frequency of the data set. Okay, what does that mean? So say 0 is the minimum value and 10 is the first quartile. So if you check the quartile range for the first quartile, that is 10, right? So the height equals 10. Okay, the mean is 20 and the Q3 is 30. So what is that quartile? That is like 10, right? So that's how this height is there. That is the interquartile range actually. Okay, so that's how it works.
And 70 is outliner. It will exclude that while calculating.
No, it has calculated that, but that is the max value, so that's why it has kept it that far. Okay, that is the max value. But for quartile calculation, we don't take into account the max value. Okay, so that's why it is left out. That is a max value, right? We don't take it into account like that.
So why we don't take into the account? Because it's far away or something like that?
No, because that is what the value of because that is how we calculate the quartiles, and that is what is the IQs are all about. Okay, we don't take the last one. we have only 4 quartiles, Q0 to Q3. Q4 is not taken into account. So that is the max value basically. So that is not taken into account. That is not outlier. That is how stats work.
Okay. Okay.
Okay. So any questions? Okay, so next one is violin plot. It is the same as this box plot, but it is different. It has the same values. Okay, Q0, Q1, Q2, mean, and all those kind of things it has. But what you see here is a violin kind of a shape for all this distribution, right? So that shape that you see, the shaded area that you see outside the middle line, that is the probability density function of the data set. Okay, that is the probability density function of the data set. What does that mean? Okay, what does that mean? So okay, what does that mean? This shaded area. Okay, this shaded area. So this is the probability density function. That means probability of having a number between. So what is probability density function? Probability density function means the probability of a point being in a range or a probability of an event being occurring, right? So let's say we have a range of 0 to 10. What is the probability that in for a particular data set, what is the probability that number 4 will occur? What is the probability of number 4 will be there in the data set? That is what probability density function calculates. Okay, so that means this is the probability of an event being happening in a sample space. You can, if I go by the by default stats terms, that is how it looks like, probability of some event happening in a sample space. So that is what it defines in probability density function, and the same thing reflects in violin plot. So how can you use it? Similarly, as I show you the calculation for Q1, Q2, Q0 to Q3, same lines are there. See, only 4 lines will be in here, right? If you see, there are 4 lines. So those lines are for Q0 to Q4, like that. And then the outside shade is the probability density function. So how can you see, what can you configure from those? Between 1 and 20, how many values are there? If you check the data set carefully, there are 5 to 6 values between 1 and 20. So that's why the curve is thickest at that point, right? So there is a high chance that if any future data comes in, so it will be in that range. So basically you need to think it in a bit other ways. So this static data set won't explain you. So let's say you have built a model. Okay, you have built a model based on some features. Okay, what is model and all, don't go too deep. Model is an algorithm. Okay, that we will discuss in the next class. So how I am trying to explain when you use it and how you use it. So let's say you have built a model without seeing anything. You have put in some features, you have taken into you have assigned the features into the weight to the features. So now how do you validate that? So if some feature values are in between, lying heavily between 0 and 20 or 30, then that means when you get a test data set from that of the same pattern, it will always follow that probability density function. So that way you can understand which feature to have what kind of a weight. Okay, so and which feature is having what kind of a distribution. So these things you can check. So that won't be only a single feature, that will apply for all the features. That is a machine learning data set that you will have. So this applies to all those. For ease of understanding, I explained with one because there is only single arrays are taken into account. So this we will plot for all the features, and we will see how the data is being differing. Okay, what is the probability that in future we can have different set of data. So if we have some true false kind of skewed data set, we will have it often. So 0 and 1 kind of data set if we have, then probability density function will have 2 peaks, one near 0, one near 1. Okay, so that's how it will look like. So let me try and show you. 10 points we have, right? 4, 5, 6, 7, 8, 9, 10. See here, because this is not visible because this is having this large values. So this value, if you enlarge it, you will see the this is stacked between 0 and 1 only, right? So you will see 2 peaks in here between 0 and 1. So that's how this thing works. So let me try this. see, you have two peaks, right, between 0 and 1. So as we have more ones, so the peak is flattened near 1. As we have less number of 0, so it is flattened near 0. But see, between 0 and 1, the curve is getting shortened, and when it goes so 0.6 will be their mean, okay, because that is what we have taken as 0 and 1. Okay, so 0.6 will be their mean, and if you see from 0 to 0.6, that the curve is let's say 0 to 0.4, the curve is wide enough, right? Because till 0.5 we can consider it to be 0. So from 0.4 onwards it started to increase, because if it is greater than 0.5 we can estimate it as 1, right? So and at the 1 it has the maximum width, and at 0 it has a maximum width. Others are just shortened, right? So that's how probability distribution function you can use. So here what you can see, this is a skewed data set, right? This is a skewed data set, so this cannot fit a straight line equation or something like that. So you need to change it, you need to change the thinking, and you need to choose, explore other options. So that's how you can check that. Yes, this is a binomial function. So this is a skewed function. It will be of form e to the power x, right? E to the power x by 1 plus e to the power x. That is sigmoid function. Like that we will have this. Okay, this function will output two values only, 0 and 1. So that's how it works. Okay, so that's how violin plot works. So if this is clear, we will just I don't have examples for this because we won't need that. I will just explain these three plots actually. We won't need that much, so I will explain what are those and how they are used, like that. Okay, next is this quiver and stream plot and area plot. These three we are not gonna use much. I will start with area plot. What is area plot? Area plot will show you the area covered in a line. So how you can see that? You can check like this. So let's say we have a line plot. Okay, we have a line plot. I am drawing some line over here. So let's say we have a line plot like this. So let's say this is the line plot. So area plot, what it will show this area. So it will show this area that we have inside this. Okay, that is the area plot. So that is to show you the area covered by a curve. Okay, area covered by some curve that we have. So that is what is called area plot. Okay, that is what is called area plot. Now if I show you here, like this is the quiver plot, right? So if you see all these individual data points, right, these individual data points are looking like vectors. It has some directions, right? So that is for basically magnetic field analytics and high-end physics needs. These are basically vectors. These are basically directed vectors. This is basically needed by physicians. Okay, this is basically needed by physicians. These two plots, this stream plot, this one up here, and this one down here, these two things are basically required by physicists to analyze the vector and to do vector analysis. Here if you see, this has pointed ends, right? So that is the direction of the vectors that goes in or out. So electrical engineers or physicists can use this plot. So if any electrical engineer is there in class, you will understand this, right? Current inflow, outflow, and all those kind of stuff. So if you have a large circuit, it will something look like this, right? So if you have a midpoint in here, what is the current input, what is the current output, and all those blah blah stuffs of electrical things will be there. So that's how this quiver plots are used. That's how the stream plots are used also. In stream plots, what is the stream plot? What is the difference? The difference is in the stream plot, we won't have that vector direction. We will just have positive or negative value for a vector, and that will be just a representation of the vectors in a 2D plane. Okay, so that's how this quiver and stream plot works. And area plot shows you the area covered under a curve. So these three plots, data scientists are rarely uses. Even if you use area plot somewhere, some down the line, but quiver and stream, let me assure you, you won't use it ever. Okay, because we are not gonna deal with vectors, right? That's how. Okay, so any questions on these three plots? So before that, I will just quickly go through these points. I have told you, but still, see here, where is bar plot used? So bar chart or graph chart is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values they represent, right? That's what. So the bars can be plotted vertically or horizontally. So what is categorical data? When you have counts, count kind of thing. When you have some categorical data means where we have categories defined, right? So here apple, oranges and all those kind of stuff and related to their counts or their price or their anything. So these type of data are called categorical data. So then we do use bar plot. Okay. For scatter plot, where is it? Yeah, scatter plots are used to plot data points on a horizontal and vertical axis in attempt to show how much one variable is affected by another. That is, what is the distribution of the data set, right? What is the distribution of the data points in a 2D plane, right? How the data are distributed. So if the data are very closely stacked, that means x and y values are very closely related. So we will have a high correlation. If if they are widespread, then we will have a low correlation, right? Because they will be independent. If you see very high what sorry, so if you have a very high difference between two data points, so that means if the difference is more, that means the correlation is low and they are independent kind of thing, right? Because in those two, if x and y has a pattern, then they will be following a pattern, right? Either they will be clustered, either they will be having a linear equation like that. Okay, so that's what it helps you to understand. And in a cluster, all the values will be tightly correlated. So if you try and find out a cluster here, you will see 1, then 2, then 3, then 4 clusters, right? Like that. So you can you will see 4 clusters are there, so they are not tightly coupled. But if you see in a cluster, this 3 or 4 data set, they are almost following a line, right? These two are following a line. So that kind of values you can get from scatter plot. I have told this, but it is written beautifully here. So that's why just covering it. The sentencing are good here. That's why. Okay, histogram I explained. So plot used to display frequency across a continuous or discrete variable that I already discussed, right? Box and violin also. Viewing summary statistics and is an efficient way. Also boxplot helps you in doing outlier analysis. So these are outliers, right? This is the outlier because you see the quartile range finishes here and some value is up way there. So these are outliers, right? These are the max values. These are way far high than outlier than the Q3. So that means almost all the data sets lies between this, but this data lies far above that. So this is an outlier, right? That's why it is left out. That's why it is left out. And if it is not an outlier, it will be close to the line, right? If the value is not an outlier, it will be close to the line. So that way we will see. But again, that won't be plotted using dot, because the max will be plotted using dot here. Let's say we have a value of 35, so it will be somewhere around here. So that we can't consider as outlier, right? Because it is pretty close to the Q3 range, right? So that is there. That value is there. So that's how we can use box plot. Violin also same thing, except that we will have a probability distribution function attached to it. Okay. Okay, so that's how we have image plot. Let's leave it. Let's not let's not go into a bit detail. So just know how to do that. If you open a image, okay. So how you can do it? You have image processing library called Pillow inside Python. Okay, you have Pillow library in Python. You can install it. No need to do it. Okay, no need to do it or remember it. This won't be used. So using Pillow library, you can use this image function and you can open an image. All images are what? Arrays, right? They are arrays of pixels. So you can convert it to a NumPy array. You can pass that NumPy. You can plot that NumPy array itself, and that would serve your purpose, right? That will serve your purpose. So this is what ax1.imshow. Imshow is for showing the image. That is again a Matplotlib function. And if you pass in the array, the corresponding values will be shown as a image here. Okay, the corresponding values of the pixels will be shown as an image in the output plot. Okay, so that's what is image plot. And the image plot to histogram also you can do. So that way you will see the distribution of the like that distribution of the colors in that. right? Colors or pixels in that. So see here, this is at 250. This is a very high value, so it might be some pixel having high value, because see, blue is having a pretty dominant color here. Blue is pretty dominant, right? So that's why it might be causing this high value kind of thing, right? So that's how is for image plot. That is not at all used. Quiver scheme, as I already told, the example is not much required. See here, this is a plotting a vector. How can you do? You can do it using quiver, this quiver option. Okay, this quiver option, we have created a subplot, then we have created this quiver option. Okay, using this quiver, if you pass x position, y position, and the directions, so you know, right, the vectors will have two directions, 1 0 1 minus 1. This is the direction of the vector, so it will go from 0 to 1 upwards, and this will go from 1 to minus 1, that is in a downward way. So that's how the vector directions work, and that's how the vector calculations work. That's how you can plot a vector. Okay, you're using quiver plot. So this is a 2D plot. This is a stream plot actually. So stream plot is used for vector calculation, vector algebra, vector physics. I mean, wherever you have a vector involved in physics, electromagnetics, electrical engineering, stream analysis like cyclone analysis, wind trend prediction, like those kind of scenarios, you will have the stream plots into account. Okay, so this is just a bit different from the vector plot. And here also you have the same thing, the stream plot function. Okay, but you won't be, you will use it pretty less. Okay, see here, this is a trend analysis, a wind trend analysis kind of thing. Okay, so that's how this stream plot works. So see, the pie chart is to show you percentage or proportional data. Okay, so this can be this can come handy when you have more than 4 or 5 categories. Then box plot will take up a lot of space, and from the box plots also you will only see the values, right? The counts and the categorical values like that, but you won't see the percentage of the data that is being placed in those each of the categories. So those kind of scenarios pie plot comes into picture. Okay, I will show you the coding example for this pie chart. Okay, but it's not much left for pie chart to be customized. So let's see. So if you see, so now it will be easier for you to understand all these functions. So first, what we have done, we have taken a label array of 4 and size array of 4. So that denotes in a data set what is the what are the number of dog, cats, wolves, and lions that we have. Okay, so if I show you a quick math, that then it will be easier. So let's say what are the values that we have. We have 50, 45, 60, and 80, right? We have 50, 45, 60, 80. So how it calculates? So 50, 45, 60, and 80. So it comes to 140, it comes to 95, this two comes to 275, right? So we have total of 275. Now if you calculate 50 by 275, how much it comes? It comes to 10 by 52. So that is somewhere around 20%, right? If you calculate this, it is somewhere around 20 or 19%, right? 50 is the count of dog. What is the percentage of dog? Percentage of dog is 21.3%, right? So this kind of percentages are calculated and shown over here. Okay, for cat it is 45, so it will be around 90% like that. Okay, so that's what kind of information you can get from this pie chart. Okay, now how do you plot that pie chart? You need to use plt.py function. Within py, if you provide some, and the options I will explain now. So sizes is one variable, labels is another variable. So labels we need to pass it, because otherwise this labels of lion, dog, cat, wolf won't be shown. So and it will be equally, it need to be in the same order as the size array. Okay, otherwise the this labels will be misplaced. Okay, next is auto pct percentage 1.1 f percentage. That means what is the display percentage, what will be the format of it. So we want only one decimal after we want only 1 point after the decimal, right? So that's why we have given 1.1. So that is the number will be whole intact, then after the decimal we want only 1 point. So that's why 1.1. shadow true means you see there is a shadow effect inside. If you give it as false, I will show you, then you will understand the difference between these two, shadow true and false. So if it's a if it's a 3D plot, I mean if so here the shadow is not really visible, but it should be if you use lighter colors. Okay, lighter colors will have you the shadow visible, so it will have a bulging effect actually. So that's how it will look. So that is not much used, you can leave it. Okay, start angle is 90 means then the angle will be 90-degree angled. Okay, so it will have a equal kind of a shape, so it will have a equal kind of a array actually, I mean sorry, equal kind of a shape of the circle. So that's why start angle equals 90. Explode, as you can see, if you mention 0.1 as an explode, then it will be those slices will be cut out from the array and it will be outside the array. So that's how explode function works. And explode, you need to give 1 for each. So where I have mentioned 0.1, those slices, see, they are cut out from the pie chart, right? That's how this pie chart works. Okay, so pie and donut, I will finish it, then I will open for question here. So donut chart is the same thing, just the difference is it shows the area. Instead of showing the percentage, it shows the area. Okay, for that what we do, we create two pie charts and we combine those. Okay, so see here, we create one pie chart here. This pie chart, if I show you one by one, so this is a pie chart, right? We don't have the numbers mentioned, so we haven't mentioned autopacity, so it haven't shown. We haven't mentioned shadow, so this kind of effect is not there. If you see these two, a difference between these two, you will understand what is the difference of the shadow function, right? So this is a pie chart. Okay, we have created a pie chart using this variable that we have. And okay, this is color white, let me make it black. Black is coming as blue. Why? Okay, black, only one what it takes, that's why it's taken blue. Okay, got it. So that's how it will take only one word in the color, so that's why it is taken as black. If I put O is not supported. Y is supported. Okay, so Y for yellow. So you see here we have a yellow kind of a circle. So this circle is to give the blank inner filling. Now if I run this first pie and second pie together, see this effect we want to give, right? So this is a pie chart that is there. So if you remove this second pie chart, what happens? This is the entire chart, correct? This is the entire chart, correct? What is the radius of this? 1.5, right? Now we want to show it as a donut. So what we can do, we can cut out some area, right? So that without saying, if I draw it, it will be easier. So being said that, so let's say this is a bigger circle. Okay, let me change the color. So let's say we have blue here. So this is a bigger circle and we have these three parts. Okay, we have these three parts. Okay, let me change the color again. Let's say I'm taking green. So this part is green. So next I'm changing it. This part is pink. Let's say like that. Okay, and this part is orange. This is filled up. Okay, this is entirely filled up. I am not going to fill it up. So what you can do, you want to show only this much. Let's say only this much you want to show. Oops, sorry. Let me change the pen color. It will be easier for you to understand. I have exhausted all the colors. No. Let me show. Let me just think. We want to show to the viewer this much of value, this much of portion. So what can we do? We can fill it up with some value. We can fill it up with some color. Let's say we are filling this up with orange. Okay, what will happen? This shade will left upon, right? This outer side circle will be left upon. So that's what that's how you can create a donut chart. It is not an option in it. So let's say if I increase this, you will see the donut chart gets shrinked. Okay, the donut chart will get shrink. That's why we have used white here, and that's how it works. Okay, if you use 1.5, the donut chart will vanish and it will have a slight effect over there, right? If you use 1.3, it will be pretty thin, right? So that's how you can create a donut chart in Matplotlib. Okay, that's how you can create a donut chart in Matplotlib. The pie chart you will create and you will empty its center. That's how you can create it. Okay, so two pie charts combined together will give you a donut chart. Okay, so that's how this works. Okay, so for your ease of understanding, I will leave it as yellow only, so that it's better for you to understand how you create donut chart. There is no donut chart, you are fooling the audience. Okay, so next is area chart. So area area chart I have already shown in the last class, right? So what you can do, you can use stack plot function, and if you pass two variables, then it will show you the variable the plot covered. So let me show you using a line equation. Okay, oops, sorry. Let me copy the line equation that we had earlier. Which one? L. Yeah. So that's how this will work. Okay, that's how this will work. So for this color, if you write black, it won't work, but if you do color, it will work. Yeah, so that's how it works. Okay, so see, now we have, let's not give it green, let's give it maroon, let's give it green. So if you increase the transparency, it will be easier for you to show. Yeah, looks nice. So that's how this stack plot works. So see, this is basically denotes the area covered between a curve. Okay, a curve or a straight line or whatever is it. Okay, so that's how this stack plot works. So stack plot is basically for showing you the area. Okay, the area of the plot covered. Okay, so that is how you we have this area plot. So this area plot you might use somewhere, but not much used at all. But this quiver and stream you won't use. Pie donut you will use often. If you have some presentations, you will use this. And without from now on, what I can suggest you, if you are working on some data on Excel and generating some graph on Excel, try to switch to this one, right? Try to switch to this editor like this, like Python. Okay, so just try to switch to Python, and then you will have nice looking charts, nice looking things, and you will learn this Matplotlib library in a vast details. So that will help you. I believe whoever is there, everyone is working on this Excel heavily, so you can try it. Okay, you can try Python for generating those charts also. So that way you will learn it. Okay, you will learn it quite well. So that's how we have. So that is what we have theory portion for this charts and all. Okay, so that's how we have. So if nothing, then let's go for the quiz. So let's go through this quiz. We are plotting a line plot between two variables a and b to add a legend, which will be the following option we need to use. Which one? Can anyone give it a try?
So this project would be on recommendation engine. So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So our dataset for the case study comprises of these four files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Right, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our data sets, guys. So we have the ratings dataset, which comprises of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings dataset by user ID and book ID. After which I am using the mutate function, and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these 2 cases over here. So the user number 4206 has rated the book number 8945 2 times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function, and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book. Right, so this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which should be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given. And I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off. And I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users. And I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So in row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom_bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what you get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we had to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the data set in descending order. And after arranging the data set in descending order, I will also left join the tags data set to the book tags data set. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is, the number of times this genre is present, and this column gives us the total count of all of the genres. This gives us the percentage of the genre, and this is the tag name, which is fantasy. So we've got our data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom_bar function. And the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So up next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order, and that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Alright guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books dataset, I am arranging it in inverse order of the ratings count column. And then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs and I'm also extracting all of the unique book IDs and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose, and I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating math 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating math 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function, and I am converting this rating math 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function I am converting this sparse ratings object into a real rating matrix. So this over here takes in 2 parameters. So the first parameter is basically what we are trying to convert this into, and then we given the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now, and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here. And this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into 2 parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in 2 parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is unrecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then where do you want to predict on top of the test set? So the test set is rec test, and the number of books to be recommended is 6, which is stored in n recommended UBCF, and I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function, and I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF at the rate items 1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274, and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle, and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels, and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @ tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @ item labels, and inside this I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days, and it's been written by R.K. Narayan and Jumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors, and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users. And this brings us to the end of the project.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So, on that note, we need to understand why we would require all these algorithms in machine learning, right? So, before that, why would we even require machine learning? Well, guys, again, the machine learning definition can be given, to the world as the ability for a machine to learn something without it being programmed for that particular thing. Well, how cool is that? It is again basically the field of study where computers use a massive amount of data and they apply all of these algorithms for training themselves. Here's the keyword, training themselves, and again making predictions on that, right? So again, training in machine learning entails feeding a lot of data into the algorithm and allowing the machine itself to learn more about the process information. Well, you're going to just tell the machine a lot of basics probably, or just show it one iteration where the machine pretty much goes on to figure out, say, 9 or 10 more iterations on its own. It's going to learn on its own, it's going to process on its own, and pretty much, you can work with that data later on, right? So again, we can call this a process of converting just raw data into useful information as well. But then we're doing it with the help of these algorithms that we're about to learn, guys. So on that note, we need to check out what the types of machine learning are. So we have three main types of learning which happens when we talk about machine learning, guys. It's supervised learning, it's unsupervised learning, and it's reinforcement learning, guys. So if I were you guys, I would just suggest you guys just take a minute, pause on the slide to note these three types of machine learning, guys. So supervised learning, unsupervised learning, and reinforced learning. If you're already familiar with the concepts, or if you think that you got it in the bag, well, let's move ahead to check out what supervised learning actually means. Well, supervised learning, as the name suggests, requires some sort of supervision, right? Let us talk in terms of variables so we can understand it easily. Again, in supervised machine learning algorithms, let's say we have input variables and our output variables. These input variables are denoted by x and the output variables are denoted by y. So x is input, y is output. The goal of any supervised learning system is to understand how your output variable y changes with respect to the change made in terms of x, guys. So how does the output variable y vary when we go about playing with our input variable? X is pretty much the goal of supervised learning system, guys. And then here we'll also be approximating the mapping function to a point where we'll have new input data coming in which we haven't seen, which the machine hasn't seen, and then we can predict new output variables y with respect to all the new data, the new x data that the machine just saw. So we've trained it for a particular amount of x's, and then it saw a new amount of data, a new amount of input variables, and then it trains itself to pretty much give us new y output values, guys. So how cool is that, right? And then we need to also know that we have dependent variables and the concept of independent variables, right? And our aim here is to pretty much understand how our dependent variable will change with respect to one independent variable. So we have a couple of dependent variable which goes hand in hand with the variable what we call as the independent variable. And then we need to understand what are the changes that goes into these dependent variables when they are mapped across and compared with respect to our independent variables, guys. Just to make sure that you guys are getting the concept out here, here's a very simple example showing you the same. So again, here our independent variable in a particular case is, let's say, our gender of the student. We have a girl and a boy here. The dependent variable can be the outcome of the educational qualification of the student. So let's say if the student either passed an examination or failed an examination, this becomes our dependent variable. So the independent variable is our gender. The dependent variable becomes the output of what the student is trying to do. And at the end of it, what we're trying to do is basically trying to determine whether the student would pass the exam or not based on the person's gender. Let's say we are doing a survey where we need to find out how many girls have passed or how many boys have passed. Here again, the gender becomes the independent variable, and all of that depending on it in our particular case is the outcome. The pass or the fail becomes dependent, right? So here again, we're trying to find out if the student would pass based on the gender or not. So the dependent variable would pretty much here be again, as I've already been mentioning, it's going to be the outcome, and the independent variable is going to be the gender, guys. So, do we have anything more in terms of supervised learning? Well, yes, guys. Here is more classification with respect to supervised learning. Is we have something called as classification and something called as regression. Let us quickly check out what regression is, and then we can come talk about classification, guys. Well, regression is a type of supervised learning where the output variable is a continuous numeric value. So what do we mean by a continuous numeric value, right? So let me again take another quick example to make sure you guys understand this better. I have images of two apples for you guys. One apple costs $4, the other apple costs $3. Here the output variable is the cost of the apple. It is a numeric value, which is a continuous value. You can predict it, right? Is the apple ripe? If it's yes, then it's costly. If it's not yet ripe, then it's cheap. Well, is it a Shimla apple? Is it a Kashmiri apple? Is it a Washington apple? Well, you can pretty much go on adding so many factors around this apple and then come up with one particular outcome out of it, which would be the price, right? So the price depends on all of these factors. And in our case, the price is the output variable. So we're trying to predict the cost of the apple with respect to all these other factors, right? So again, doing this in a real world or in a mathematical situation, and in this situation, pretty much we call it as regression, guys. So with respect to regression, again, there is another type of regression, which what we call it as the logistic regression. And this is basically just a technique, where our dependent variable, instead of it being a continuous numerical value, it is a categorical value, guys. So again, what do we mean by this? Time for an example. If you can take a look at the example on your screen right now, what we're trying to do is we're trying to predict whether if it's going to rain on that particular day or not. And this is being done with respect to two independent variables, right? So how do we check rain? Again, pretty much it's usually done by checking the temperature, checking the humidity, and if all of this is good, we probably just go out, take a look at the sky to check for clouds and so much more, right? And here, coming back to logistic regression, the dependent variable is the categorical variable, right? So it can have only two values. A categorical variable can only have two values. It is mostly binary, guys. So it's going to be either 0 or it's going to be 1. And in this logistic regression model, what we call it, depending on all of these attributes, we get the probability our final answer is going to be either yes or no, right? So if you ask someone a question, is it going to rain? Their answer might be either a yes or a no, right? So it's a binary answer. Again, here it's the same as well. To pretty much to graph out what it would look like, we have an S-shaped curve out of this model, what we call as the logistic regression, guys. So on the left, we have a linear relationship between our dependent variables and the independent variables. It is just a straight line. On the right, since it's a binary value, binary outcome that we are looking at, the curve looks like an S. So again, guys, take a moment, pretty much pause on this slide to understand what a linear regression graph looks like versus what a logistic regression graph looks like. So on that note, let us quickly come back to check out the next subdivision under supervised learning, which is called as classification, guys. You pretty much, as the name suggests, you might already know what classification means. In literal terms, well, again, classification, here the output variable is categorical in nature. So again, it's going to be a binary value. So you can just have a look at the picture on your screen, and then we can categorically analyze if that person is a male or a female, right? So here the binary outcome is again the gender of the person, if the person is either a man or a woman. And then again, the output variable is the gender of the person, which is a categorical value, and we're trying to classify this person into a specific gender, based on all the other factors as well. Well, how do we know it? Well, we could see the beard on the face. It looks like a man. So our brain pretty much told us it is a man, right? Simple as that. So on that note, we've pretty much checked out what supervised learning is. So what is unsupervised learning? Well, guys, in unsupervised learning, here all of the algorithms that we have, right? We have input data which has no labels. So when we mean that the data does not have any labels, then there is nothing that the machine can map to understand the data offhand very easily. So if we can take a look at the raw data ourselves, right? So we can probably tell that there's a couple of fishes in there, there's a couple of birds in there. Well, we know it because we have trained ourselves for that. When the machine sees this, there's not going to be any label which is going to tell that this is a fish or this is a bird. So our unsupervised learning algorithm is pretty much going to run through this again, and at the end of it, with respect to clustering, what we call is the process of clustering, it's going to divide all the fishes for us, divide all the birds for us on its own. So here the input data has no input labels, has no class labels, and it doesn't know what's a fish and what's a bird, right? So again, building a supervised unsupervised model on top of this input data is again very interesting and very fun, guys. So here again, it's going to pretty much be giving out two clusters. First consists of all the fishes, and second consists of all the birds, guys. So coming to clustering, which is again a major part of unsupervised learning, the most important clustering algorithm, the most simple one, is the k-means clustering, guys. Well, k-means clustering again is an unsupervised machine learning algorithm where the aim is to pretty much go about grouping all the similar data points, just like fishes and birds, and making it into one cluster, guys. So again, there must be a very high intra-cluster similarity and low inter-cluster similarity out here, right? So what do we mean by that? Well, all the data points within a cluster should be as similar as possible, and all the data points in between two different clusters must be as different as possible. So all the data in one cluster is simple and similar. All the data when you compare two different clusters are very different to each other, right? So this is pretty much the k-means clustering in just a sentence, guys. Well, what does the k stand for in the k-means clustering, right? Well, k is the number of clusters that you just want the outcome to be. In our particular case, we have cluster A, cluster B, and cluster C. So the k value here is 3 because we have 3 different clusters, right? Very, very, very simple as that, guys. So on that note, the next type of learning that happens is what we call as the reinforcement learning, guys. Again, in reinforcement learning, there is something called as an agent. And this agent pretty much runs up and returns up most effective actions for us by mapping its state at every single moment, guys. So to give you a better clarity, I hope you guys have played Pac-Man in your olden days, guys. So in this particular video game, the space around the figures would what we call as the 2D game space. Again, you have something called as pack dots, you have enemies, you have walls, and so much more, right? So the action here is to again just pretty much move around and make sure you don't touch the bad guys and just finish your entire goal. Here, how do you know who the good guys are and where you need to move and how you're not supposed to get out every single time, right? So that particular thing, you've been playing this game for a while. Let's say you've been playing this game for a couple of hours, couple of days in your childhood, and then you realize how the game actually works. Well, that exactly is reinforcement learning, guys. Again, to give you another example, reinforcement learning is pretty much how a dog or a cat is trained in its real life as well. If the dog does something right, if the dog is given a handshake, let's say we're training a dog to give a handshake, and then if the dog is given a handshake, you might see that the trainer just feeds a biscuit that instant, right? So the dog knows that the outcome of giving a handshake is pretty much the right thing to do because there is a biscuit at the end of it. So the reward is being hunted by the animal, right? So again, to put it all in one single picture, this is what a reinforcement learning environment would look like, guys. So we have an agent who performs an action in an environment. And then here we can actually have two tracks where if the agent does it right, if the task is being performed right, there is a reward with respect to it and everyone's happy. Else, if you do not have that particular reward, then it means that something went wrong, and this will have a state. Because something went wrong, you're eventually not getting the reward. Let's say the dog did not give you a handshake. If you pretty much give it a biscuit at that moment, it will not realize if it's doing the right thing or the wrong thing, right? So that we can have a state of, let's say the dog did not give a handshake. And that's pretty much what ST means, guys. Reward is RT. And this keeps on going in an iteration where you're just training your model better and better and better to hunt more rewards. The more the rewards, then the machine's doing the right thing. It's as simple as that, guys. So on that note, I have two very simple demos which are in Python that I just quickly want to run it by you guys to tell you the use of machine learning algorithms anyway. So on that note, let me quickly jump into Google Colab. Google Colab is basically a Python Jupyter notebook hosted on the Google Cloud, and I use this for most of my Python coding as well. So anyway, coming back to it, here's the first example that I'd like to discuss with you guys. Well, just give me a second. The runtime is being connected, so it's almost connected now. It's initializing, and then it's gonna say connected any minute now. And there it is. So first, let us take out a k-means clustering demo, right? So pretty much we're going to import a couple of packages such as NumPy, Pandas. We have Matplotlib to pretty much give us the output in terms of graphs. We have sklearn to pretty much import what we have the sub library called as the k-means library, and then go on working with it. So let me quickly import all of these libraries that we'll be making use of and then go ahead with that. So to generate data of our own, instead of just picking it up from any data set, for this particular case we'll be making our own data using something called as make_blobs, guys. So we'll have 300 samples here, and then we'll have 4 clusters each. So this is what we means. n_samples is 300. We have 300 dots on your screen right now, and these dots are divided pretty much into 4 clusters for us. So let us use something called as the elbow method, where pretty much it's called as WCSS. I would recommend you guys pretty much Google it. What if you want to know what WCSS means. It is again a very complex part of the k-means algorithm, and I would just suggest you guys to check it out on your own, because it is not in the scope of this particular tutorial. And then so we'll be using that particular method, and we're going to train the entire model for us to make it understand what's going on. So look at this, right? So what is the optimal number of clusters again for us is somewhere around say 3 or 4 as well. So we have 4 clusters, and we have the WCSS all the way from 2500 till 0, right? So we're gonna have to categorize. This is just a graph to tell us what the data might look like, right? So we need to find out the centroid of what we call as the centroid in our k-means clustering algorithm of each different cluster, and then we need to mark that centroid, right? So this is exactly the red dot. What you see is again exactly what's going on there. So we've pretty much found out that there are 4 clusters that exist, and then we've pretty much marked the centroid of the 4 different clusters that you see using k-means clustering, guys. It's as simple as that. So that was a very simple first demo, right? For our second scenario, I will be checking out our logistic regression, and in this particular case we'll be going on to predict heart disease prediction dataset, and we'll be performing our machine learning algorithms, and we'll be using machine learning here to predict if a person is gonna have a heart disease or not. And we're going to be doing this entirely using the process of logistic regression, guys. Again, we're importing a couple of libraries here, Pandas to handle the data, NumPy to handle mathematical operations, SciPy to go on to do our computations. Then we have Matplotlib and Seaborn to pretty much give us visualizations, and we have sklearn, which is a scikit-learn, which is again a very important machine learning library of Python, and we're going to import all of these, guys. So just before that, we need the dataset file, which is called as the Framingham dataset. Well, the dataset is from the town of Framingham in Massachusetts. So let me just quickly import the file which is called as the Framingham dataset, and then we can pretty much go on to working with it, guys. So it's gonna take a second to pretty much get uploaded. It's a small file, and as you can see, it's been uploaded. So now I can go on to pretty much run this code, where this is what our dataset would look like. If it's a binary value for male, it means if it's male equal to 1, then the person is male. If male equal to 0, it means the person is a female. It has the age. It has if the person is a current smoker or not, and how many cigarettes per day. Do you have BP medications, and then blood pressure basically. And then, have you had a stroke in your life? Are you diabetic? What is your total cholesterol? What is your systolic blood pressure? What is your diastolic blood pressure? What is your body mass index? What's your heart rate? What's your glucose at? And then it's gonna check your CHT as well, and so much more. So this is an amazing data set to work with, and pretty much we're going to be just replacing the column of male by sex_male. That's about it, what we're doing here. And then we need to find out how many missing values we have in this particular data set, and there are so many values with zeros in it, right? So we have about 388 missing values when it comes to glucose, 50 missing values when it comes to cholesterol, and so much more. So let us go on to remove all of these missing values and say, hey, look, it found pretty much about 500 total number of rows with missing values, right? And it's fine in our particular case because it's only 12% of the entire data set. So we can exclude that, and we can pretty much drop it, and it wouldn't hurt our analysis at the end of it. So to begin with, you have to perform some exploratory analysis where we need to show what the data is being distributed like, and we need to just hunt into our data to find out what the data is telling us, right? So here's a couple of quick charts which pretty much give us all of our numerical data with respect to graphs. So we have again the sex distribution, we have the age distribution, current smokers, BP medications distribution, cigarettes per day, diabetics, total cholesterols, BMI, systolic blood pressure, again diastolic blood pressure, and so much more, right? So we're just pretty much performing some quick exploratory analytics on it, and then we're going to be going about to find out what the actual this is just a 10-year CHD that I'm printing out, and then we need to go about finding out if the person has a rate has a chance of getting a heart disease or not. Well, here we can check out the count, right? So there are about 500, let's say 600 people who are in risk of getting a heart disease, while there are about 3,500 or let's say 4,000 people who are healthy and quite well. This is what exploratory analysis pretty much helps us to do. It gives us a sort of an analytics number where it can find out if the person might suffer from a heart disease or so in the near future, and so much more, right? So let us quickly go about plotting that, and we can go ahead from that. Well, as you guys could see, that pretty much took about a minute of processing because it has to plot so many values for us, right? I'm sorry, let me quickly scroll down so we can get a better view. Again, this is respect to this is a Seaborn axis grid plot, and then you can see all the concentration of all the values at every particular instant, right? This is for every single aspect that we're using to compare. So let us quickly use describe to pretty much tell us what we're just looking at. And so we have a count of about 3,751 males. It's going to give you the age of so many people. It's going to give you all the cigarettes, BB meds, prevalence, stroke, and so much more, right? So coming to the process of logistic regression out here, from all this data set, we need to have an inference at the end of it, right? So to do that, we pretty much be running a couple of functions. One of those functions is a lambda function. And then we can have this very nicely optimized output printed for us. And then, as you can check out, as it already says, the 10-year CHDs pretty much are dependent variable. We'll be using logistic regression, so much more, right? So it's going to give you all the standard errors, all the values of, we call it the Z method. It's going to give you the Z method values. It's going to check if your probability of your outcome is greater than the value of Z with respect to all of these single categorical variables that we're checking. And then when it comes to backward elimination, we'll pretty much be using our feature selection to go about doing it. And the end of it, we can have a summary, a very nice looking summary printed for us. Well, again, the summary looks nice, right? So we need to make more sense out of it such that, okay, this is the odds, this is the ratio and all. So here we have something called as the p values. We have the odds ratio and the CI 95% values out here. So here we can pretty much go on to analyze what actually causes the outcome of, let's say, a heart disease. And so we can make sense out of it. To use our model to make sense out of it, let's quickly split our one single data set into a training data set and a testing data set, and let us make our model give us the answer for us, right? So checking out model accuracy using our scikit-learn library, again, you can pretty much find out that our model is almost accurate for about 90%, right? So 88.14% is a big number, and it's been training, well, not for many times, right? So the number of iterations again is very less. So here's a subplot, is what we call as an axis subplot. And here as well, you can pretty much check out the actual predicted outcome values, which is predicted 1, predicted 0. The actual outcome values is this color, while the actual value is blue color, right? So the color distribution here again will let you know of what's going on there as well. Well, here is another step to pretty much print out what's what's a true positive rate of the data, true negative rate of the data, and so much more. To put it all into one single print statement to make it sure it looks very nicely, the accuracy of our entire model is about 88%. The misclassification is pretty much 1 minus what the accuracy is, right? So we've missed about 11% of accuracy. True positive rates, we have somewhere about 4%. True negative rates, we have somewhere around 99%. Positive prediction rate is 80%. Negative prediction rate is somewhere around 88%, and so much more, right? So look at this amount of data. Look at this amount of data that our machine learning algorithm is pretty much giving us, right? So if you put it literally, in terms of use cases, in terms of medicine, then that's going to help a lot of people, right? So that was a quick walkthrough, pretty much on how you can go about using k-means clustering and logistic regression algorithms, guys.
Let's have a quick quiz question, guys. And the question is, which of the following evaluation metrics is sensitive to imbalanced classes? And your options are accuracy, precision, recall, or F1 score? Please mention your answers in the comment section below.
The task to be done is, first let's look at the data. So you are a data scientist at a telecom company whose customers are churning out to its competitors. You have to analyze the data from your company and find insights and stop your customers from churning out to other telecom companies. So this is the problem statement that we are having. And this is our data, customer churn data set. We are having customer ID, gender, senior citizen, partner, yes or no, dependents, tenure, phone service, multiple lines. So here are the tasks to be done. So first part is data manipulation. So this is our task, first topic, that is data manipulation. So first task is extract the fifth column and store it in customer 5. So this project is designed accordingly, how you work in a data science model. So first task is to work with the data frame or pandas, and then you have to visualize, then you have to train. So those all things are lined up accordingly. So firstly, what we will do is import pandas as PD. Then we will import NumPy as NP. And lastly, we will import Seaborn as SNS. So as of now, we are going to work on these two only in the first module. So we have to extract and store it in this customer 5. So pd.read CSV, because first of all we have to take our data, customer. So we will make a data frame pd.read CSV customer underscore churn dot CSV, customer underscore 5 is equals to df.ilog 5. So if I execute this, let's execute. This will take us this 5. What it will do is, rather than 5, we will write 4 here, because it is 0, 1, 2, 3, 4 and 5th. Why we are using this 4 here? Everyone understood why we are using this 4 here? So can we move to the next question? This you will be able to do, I guess, now. Extract the 15th column and store it in customer underscore 15. So customer underscore 15 is one variable that I will make, and df.ilog 14. Clear? Then the third one is extract all the male senior citizens who have payment method is electronic and store the result in senior male citizen. Senior citizen equals to 1 and payment method equals to electronic check. Here the question was extract all the male senior citizens. So here you also have to add one more condition, that is df gender should be male. Correct? Now it is correct. So if I look at this, so it is having some rows and columns. Here the gender is males. So senior citizen equals to 1 and payment method equals to electronic check. So the next query or the next statement that we have, extract all those customer whose tenure is greater than 70 or their monthly income. 1 second. Or their monthly income charges more than $100 and store the result in customer total tenure. Okay, so extract all the customer whose contract is of 2 years, payment method is mailed check, and the value of churn is yes, and store the result in 2 mail yes. So how we will go about this is df, and inside we will have contract equals to 2 years, payment method equals to mailed check, and churn also equals to contract is capital C, I guess. Okay. So next is extract 333 random records from the customer churn data frame and store the result in customer underscore 333. So how we can go about it is customer underscore 333 equals to df.sample where n equals to 333. So this will show us 333 samples. Yes. And next is get the count of different labels from churn column. So df churn dot value counts. Okay, this churn is capital C. So 5174 are yes and 1869 are no. So in the visualization, getting 0 for senior. Okay, let's look at this code. So placement is your data. So here you do not need to put this lock. Now it is working, I guess. It is still showing 0. Earlier when we did it, it was not showing 0. df gender equals to male, df senior citizens equals to 1, and payment method equals to electronic check. Is it working now? Yeah, it is working. Capital M, this male. Okay, now it is working. Okay. Because of this is why you need to keep the data with you. Okay, 10 or monthly charge not working for me. Okay, so let us look at the visualization. Okay, so the first question is build a bar plot for the internet service column. Set x-axis label to categories of internet services and y-axis label to count of categories. Right. So x equals to df internet service dot value counts dot keys to a list. So what this x is giving me, it is giving me a list what all the internet service methods are there. Yes. Let's make y as well. Y will be same, but we will not use this keys. Now y is the count and x is the keys. So what I need to do is, first of all, I need to import the Matplotlib library. Import Matplotlib dot pyplot as plt. So now what I will do here is plt dot bar x comma y. I will give color equals to, let's take orange color. It is not forming a graph bar. Let's first put the x label and the y label. Plt dot x label, categories of internet service. Plt dot y label, count of categories. Okay, this x equals to y. Okay, now it is working fine. Now you can see we are making what? First of all, we are internet service dot value counts. What this function will return us, let's see that first. This is returning us fiber optics have this much customers, DSL have this much customers, and no customers have internet service, which are this number. So now we are doing what? We are making keys of it. So now keys are made, and to this keys we are converting them to a list. So now we have a list, fiber optics, DSL, and no. This list we will put on, why not unique? This is n unique you are talking about. You can use that as well. This will just give you a number. Okay, if you want to convert this into keys, okay, not to keys, to list, we have to convert this. This also you can use. Eventually the output should be like this. We have to get a list. Does not matter what you can use, unique, or you can use value counts or anything. So our color was to be orange, x and y level was given, and we have to make a bar plot. Second question is build a histogram from tenure column. Set the number of bins to be 30. Plt dot hist df tenure and bins equals to 30, and color should be green. And title was distribution of tenure. Plt dot show. So now this is creating what? A histogram of tenure column with bins equals to 30 and color equals to green. So some person are having, how many people are having this much tenure? Some people are having more than 70. So rather the people above 800 people are having tenure less than, you can say this will be 2.5, 2 or 2.5 tenure. And mostly people are having in between of 10 to 60, and some are having more than 70 as well. So if I plot this into 50 bins, now you can see 10 to 0 to 10, so many people are there, 10 to 20 are there. It is decreasing. After 50 it is increasing. So third question, build a scatter plot between monthly charges and tenure, and map monthly charges to the y-axis and tenure to the x-axis. Color should be brown. So first two we did with Matplotlib. Now last two we should be doing with SNS, Seaborn. So what we do is SNS dot scatter plot data equals to df, x equals to df dot tenure, because this is given. X label we will fix. X label is tenure of customers. Y label we will fix monthly charges of customers, and the title we will give plt.title, that will be tenure versus monthly charges. SNS is not defined. Okay, so here we have to import one more library, that is import cborn as SNS. So now it is working, and the color also you can give color equals to, let's suppose I'm giving brown. So this is making the last 20, tail 20 we are taking here. We can take 30, we can take the whole column, but then it won't be good to look at. Look, this is working like this. So try with 20 or 30. This last D question, build a box plot between tenure and contract. Map tenure on the y-axis and contract on the x-axis. So you can add one more feature here called as width. So now it is looking better than it was looking before. Because end result of these, the objective of this is that we can look at it and get the output easily. So this is looking better than that. No, you have to just make of contract and tenure. Color, let's suppose we are giving orange, and you can add width here as well. 0.4. TH. So let's start with the next task, that is build a linear regression, simple linear regression model, and some divide the data set into 70-30, build the model on train and predict the values on test set. After predicting the values, find the root mean square error, RMSE, and found out the error in prediction result in the error. Find the root mean square error. So let us take this and put it here. So firstly, how will you go about this? X value or this X train into the linear regression, it will cause you an error, is what I think. Yeah. So let us go step by step. Firstly, we will make X, that will be data frame we will making, because linear regression algorithm does not accept 1D X matrix. And if you do like this will be a 1D matrix. Look. So rather than doing this, make it into a data frame. Data frame is not defined. pd.data frame. Okay. Now if you look at X, it is a data frame. Correct. Then Y you have to take. Y you can take directly because it is your target column. That is monthly charges. Okay. After this, from sklearn import train test split. And after this, you will be dividing X train, Y train, X test, Y test, and you will be dividing your model. And then after you will, from sklearn lot linear model, import linear regression. linear underscore model, I guess. Yes, it is the 5. And let's make linear regression LR. Linear regression. And in this linear regression, we will call dot fit, and we will give X train, comma Y train. This n should be small. And after that, once my model is ready, LR underscore prediction values I will make LR dot predict X test. So these are the values that my model predicted. So now once my model have predicted the values, what I will do is, firstly I will import this RMSE. So from sklearn, dot metrics, import root mean square error. Mean square error. So now I will make one MSE and mean squared error, and inside this I will give LR underscore pred. And Y test. This MSE will look and then we'll calculate RMSE, that is root mean squared error, equals to NP dot SQRT of this MSE. So RMSE here is. After that, we'll move to logistic regression. We are making our X data frame, that is our feature matrix, and Y, that is our target variable. And then we are importing train test split. We are splitting the data in 70-30 ratio. After that, we are importing linear regression, and we are making a model called as LR using linear regression function. And in this LR, we are fitting our X training and Y training data, and then we are predicting our data using the X test. These are the predicted values. So now to check my predicted values with the actual values, we will give this inside root mean squared error. And the result of mean squared error, we will root it out with the help of NumPy, and this will be our RMSE that we wanted. After this, we will be moving to logistic regression. Again, we will be defining X and Y. So dependent is churn and independent variable is monthly charges. So X equals to PD dot data frame. Why are we taking this as data frame? Why are we not taking this as this? Okay, let's do one more thing. When in linear regression, we are defining this X equals to data frame. Let's not define this as a data frame. Let's give it normally. df.tenure, because this one column we wanted to take. And let's run everything. Look, here it is creating an error and it is giving expected 2D array got 1D array instead. So if we are using like normally like this and not making it to a data frame, then it is giving expected 2D array, because linear regression function is not designed to be working with 1D array. It takes only 2D array or a matrix. So if you are taking only one, then you also have to make it into a data frame. If we were to take more than one, then it would have also already became a matrix. Okay, here we are doing what? df. Inside this we will give churn. And in y, what we will give? df monthly charges. From sklearn dot linear model, import logistic regression. After this, what we will do is we will make x train, y train. Dependent variable is the target known. Yeah, this is monthly charges is the dependent variable, the target. Independent, with the help of independent variable or with the help of x, we are trying to predict y or the dependent variable. Now we are making logistic regression model. Logistic regression. And now we are fitting our values. Okay, one second. Build a simple logistic regression model where dependent variable is churn and independent variable is monthly charges. Here we have to take monthly charges and inside this we have to take churn. Yeah, x is independent. Okay. It's a little twisted, but this is, we will be taking this as independent and that as dependent. Okay, so here it is a little twist that the value churn will be taken as y, that is a target variable, and independent variables. Okay, one second. Okay, so guys, what it is written here is, earlier we were having a confusion. Build a simple logistic model where dependent variable, that is churn, so y will be our dependent variable, and independent variable, it is monthly charges. So x is our independent variable, because inside this also, when it is written here, dependent variable is monthly charges. So your y is monthly charges, because dependent variable is what? Your target variable that you are trying to predict on the basis of independent variable, that is x. This is why it is dependent, because we are trying to predict this on the basis of the independent. Okay, so let's predict the values. lgr.predict underscore predict. So now from sklearn matrix, import accuracy score. So accuracy score, we will give y test and lgr underscore predict. So this is the accuracy that we are getting, 73.6. When you do independently logistic regression, that you should be doing all the EDA, because here we are just doing on one column. in one column, how can you apply the VIF? If you are having some one column only, even if you apply VIF, then can you remove that only column? No. Very limited data. It is designed so that your all supervised learning will be revised in one go. Okay, so this next, I want accuracy with 2 columns, and we can also build confusion matrix for this. This multiple logistic regression is what we are working on more than 2 columns. This normal logistic regression, we are working on the single column only. This logistic regression, we are working on a single column only. It will work similarly. In the real time, when you did the hands-on of logistic regression, you only use the multiple logistic regression, because this logistic regression is not used so many ways, because it is only using one. But we generally use more than one column of the data, so we generally go for multiple logistic regression. Because the last time I worked on this project, it was 77. Okay, so let us try to do that. pd.dataframe df.loc monthly charges, comma tenure, and y equals to df churn. Okay, this data frame f have to be capital. Again, it is creating one more error. Too many indexers. This will be a list. I prefer working like this to make it a data frame, because sometimes when you are using one, we forget to make it a data frame. So I generally go with this syntax. X train, Y train, X train, X test, Y train, Y test equals to train test split. And inside we are giving X and Y. Train size equals to 0.8 and random state I will give 0. So now let's make a multiple logistic regression and logistic regression. So this mlr.fit underscore we will give X train, comma Y train. Random state 43 gets me to 79% accuracy. Go with that if it is 79%. I generally check with 0 and sometimes 2. This 40 random, 42, 43 random state is generally not giving the best accuracy. 0 is generally giving the best accuracy, but if in this case it is giving better, you can go with it. mlr.predict underscore predict equals to mlr.predict So now we will print the confusion matrix. With the confusion matrix, you can also calculate that. The accuracy, you guys know, right? The true positive, true negative. So now we'll also calculate accuracy score. Y test, MLR, predicted value 77.3. After this, we have to work on a decision tree model. If we already have logistic regression, then why do we need to build one more algorithm that is called as decision tree? Because the classification we can do with the logistic regression, then why decision tree? Then if we have logistic regression or the multiple logistic regression for classification, then why did we need to go to decision tree? Then why did we develop one more algorithm? You guys have completed the supervised part till here. What I was suggested, after every topic, do search for interview questions and try to see some interview questions based on that topic. So when you reach to the final of your course, so you will be knowing the interview questions of every topic. So one day before the interview, when you are typing or searching interview questions for machine learning interview, something like that, that won't help. The thing is, the logistic regression is for classification. But when the classes start to diversify, when there is more than 1, 2, 3 classes, the categorical data, let's suppose this is our binary or multiple logistic regression, 2 class, yes or no, or 0 or 1. But when classes starts to get the number of classes starts to create be big, like let's suppose this is the classes number you are having now. One customer is saying yes, one is saying no, one is saying don't know, one is saying something else, one is saying nothing. So if the classes are diversified more, the number of classes begin to increase, then logistic regression does not work very well. So for those cases, we have to build decision tree. And why it is called as decision tree? Because in that various classifications are there. This is like a tree, no? This is a tree. So this is one class, this is one class, this is one class, this is one class, this is one class. So on this basis, the decision tree is formed. And when you talk about random forest, so what random forest is? Random forest gives you better accuracy when there is more number of class, better than logistic regression, better than decision tree. Because in the decision tree, what is happening is, if in the easy words you want to explain random forest, then you can say it is a bunch of if-else statements combined. So when there are multiple decision trees, let's suppose this is also a decision tree. This is also a decision tree. When there are multiple decision trees, on the basis of those, when some output is coming, that is called as a forest prediction or the random forest prediction. And why decision tree is developed? Because when the number of classes starts to increase, then these algorithms will not do that good that random forest will do. And it is not like you cannot apply random forest for 2 classes or decision tree for 2 classes. From sklearn dot tree, import decision tree classifier. And now X value have to be PD dot data frame tenure df and tenure. So inside this, you can see we have to divide this into 80-20 ratio. So we will give train size equals to 80.8. So inside this, we will pass the independent variable, that is X, and the dependent variable, that is Y. And the train size that is equals to 0.8. And random state I'm giving 0. So it is a data frame looking like this. So now I will make my model, the decision tree model. So we will give the name DCT, decision tree classifier. Somewhere the spelling mistake. One second. Okay, so dct.fit, and inside fit we will give the training data, that is x and y. Once you have fitted the model, then you can predict the values. So let's dct underscore predict. I'm making one variable that is predicting the value. dct.predict, and inside this predict, what value should I give? X test, x underscore test. So now I can build the confusion matrix and the accuracy score for this as well. Accuracy score, and what the two parameters that I need to give in accuracy score? Y test and dct predict. Yes, y test and dct pred. So 74.66 is the accuracy it is giving me. If I try to run this with 2 random state, 76 it is giving. With 42 it is giving. Okay, with 2 it is giving the best accuracy. 1 is 79. You know why it is varying too much? Because in 76.4 is giving in 1. Generally accuracy do not vary this much according to random state, but here we are not taking actually metrics, we are just taking one column, so it is varying this much. Otherwise 0 is generally, or you can 0 and 2 you can try, and it is the best in general cases. So let's also make confusion matrix for this confusion matrix. dct underscore pred and y test. So this is your confusion matrix that you are getting. So this is how you calculate. This is your true negative, this is your true positive, this is your false negative, and this is your false positive. So this is how you calculate the accuracy from this confusion matrix. So this last task that we have for us is creating a random forest model. Okay, so the x will be pd dot data frame df dot loc, and inside this loc we are giving tenure, monthly charges, comma tenure. And this y we will give df churn. So now we will do x train, comma x test, y train, comma y test. Train test split x comma y, train size equals to 0.7, and random state, let's suppose 0 I'm giving. So now when I have to import, we have to import the random forest from ensemble. From sklearn.ensemble, import random forest classifier. sklearn dot ensemble import random forest classifier. After that random forest model, we will make a random forest classifier, and this rfm.fit we will do, and we'll pass xtrain and ytrain inside this. And after that what we will do is rfm underscore pred one variable we'll make, and this random forest model will predict the values in this, predict on the basis of x test. So now I will print the confusion matrix y test and rfm underscore predict, and accuracy score also we can see by using this y test and rfm underscore predict. This is 75.05. You know, researchers have found this, then that the square root or the logarithm of this number works well in the classification. Either the square root, when you are working on real-time data, let's suppose you are having 1600 columns or something like that, the square root or the logarithm, that will be working better. And if you are doing the random forest regressor, then the average should be working better. No, this square root will be working better if it is a classifier, and this logarithm will be working better if it is a regressor.
So now, moving to the first question, what do you mean by the term normal distribution? Normal distribution, also known as Gaussian distribution, is a type of probability distribution that is symmetric about the mean. Here, mean, median, and mode are equal. Normal distribution appears to be bell curve in a graphical form. So here, you can see this graph. This graph is symmetry, and also mean, median, and mode are equal. So now, let's move forward. So the next question we are having is, what is a skewed distribution? A skewed distribution takes place when one tail is longer than the other. Skewness defines the asymmetry of a distribution. Here, the data is not distributed equally on both sides of the distribution's peak. So basically, there are different types of skewed distributions. The first one is the left skewed distribution, and the another one is the right skewed distribution. So in left skewed distribution, it occurs when the long tail is on the left side of the distribution. That means here the mean is left to the peak, and also mean is less than the median, and the median is less than the mode. Along with that, left skewed distribution is also known as negatively skewed distribution. Coming to the right skewed distribution, it occurs when the long tail is on the right side of the distribution. It is also called as positive skewed distribution. Here the mean is right to the peak, and also mode is greater than median, and median is greater than mean. Now, so let's see in the graphical form. Here you can see that this is a graph of left skewed, right? So clearly mode is greater than median, and median is greater than the mean. So now let's see left and right skewed distribution in graphical form. So here you can see that it's a left skewed graph, right? Because the long tail is on the left side of distribution. Whereas if you are talking about the right skewed distribution, the long tail is on the right side of the distribution. In a left skewed, you can clearly see that mode is greater than median, and median is greater than mean. Similarly, coming to the right skewed, here mean is greater than median, and median is greater than mode. Now, moving ahead, the next question we are having, what is the difference between bias and variance? Coming to the bias, bias is a prediction error that is introduced in the model due to oversimplifying the machine learning algorithms. It is the difference between the predicted values and the actual values. So let's suppose you have created a machine learning model. So while creating a machine learning model, we'll get some predicted values. So basically, the difference between the actual values and the predicted values is known as the bias. Now, coming to the variance, variance occurs when the machine learning model performs well on the training dataset but not on the test dataset. So now, moving to the next question, how will you handle missing values in data? So there are several ways to handle missing values in the given data. The first one is you can replace the values with mean, median, and mode. For example, let's suppose if you are having any numerical column of, let's say, price, and there are a lot of missing values, then you can replace it with the mean. Now, moving next, we are having the dropping the values. So let's suppose if you are having any column that is present in the data set and the null values are present more than 70%, then you can drop that particular column. The last is replacing with arbitrary values. So that means you can choose a random value without any reason or system. So the next question we are having is, what are the techniques used to detect outliers? So there are various techniques that are used to detect outliers. The first one is the box plot. So talking about the box plot, we know the length of the box is IQR, that is nothing but an interquartile range, right? And the minimum and maximum values are represented by the whiskers. So the whiskers are generally extended into 1.5 times of the IQR distance on either side of the box. Therefore, all the data points outside this range values are flagged as outliers. So the next technique that is used as z-score. So z-score is a parametric outlier detection method in a one or low dimensional feature space. This technique assumes a Gaussian distribution of the data. The outliers are the data points that are in the tails of the distribution and therefore far from the mean. So the last method that we are having is interquartile range. As we know, the formula of interquartile range is that it is quartile 3 minus quartile 1. Basically, it is the difference between the third quartile and the first quartile. So to detect the outliers using this method, we define a new range. So let's call it decision range, and any data point lying outside this range is considered as outlier and is accordingly tailed with. So the next question we are having is, what is the difference between overfitting versus underfitting? As we know that overfitting and underfitting are the two key problems in machine learning that decrease the performance of machine learning models. Now, coming to the overfitting, overfitting occurs when our machine learning model attempts to cover all or more than the required number of data points in the given data set. So you can see that in this graph, our machine learning model tries to cover all the data points, right? So now, what happens here? As a result, the model gives inaccurate values in the dataset, and all of these factors reduce the model efficiency and accuracy. The overfitted model has low bias and high variance. The more we train our model, the more likely it is to become overfitted. Told you can see in this graph, the model tries to cover all the data points. So it looks efficient, but in reality, it is not so. Because the goal of the regression model is to find the best fit line. But here, we have not got any best fit, so it will generate the prediction error. So now, let's see how we can avoid the overfitting in model. So there are some ways by which we can reduce the occurrence of overfitting in our model. The first one is the cross-validation. Second, we are having training with more data. So whatever the data is there, we can train it, right? So there are some ways by which we can reduce the occurrence of overfitting in our model. So let's see some of the ways. The first one is the cross-validation. We can also train with more data. Then we can remove features too. We can early stopping the training too. Along with that, we can also apply regularization as well as ensembling. Now, after knowing what is overfitting, now let's see what is underfitting. So underfitting occurs when our machine learning model is unable to capture the underlying trend. So to avoid overfitting in the model, the feeding of the training data can be stopped at an early stage, causing the model to learn insufficiently from the training data. As a result, it may fail to find the best fit of the data's dominant trend. Underfitting occurs when the model is unable to learn enough from the training data, reducing accuracy and producing unreliable predictions. So let's back to the previous slide. So in underfitting, a model that is underfitted has a high bias and a low variance. For example, the following output of the linear regression model can help you understand about the underfitting. So here you can see that the model is unable to capture the data points in the plot, right? So now let's see how we can avoid underfitting in the model. So there are two ways in which we can avoid the underfitting in model. The first one is increase the model's training time, and the another one is the increasing the number of features. Okay guys, so the next question we are having is, what is the difference between supervised and unsupervised learning? Supervised learning is a machine learning method that uses labeled data to train models. For example, here you can see that how a player learns in the presence of his coach. So this is an example of supervised learning. Now, there are two types of problems that can be solved using supervised learning. The first one is the classification and the another one is the regression. So let me give you the example so that you can understand, right? So let's suppose we have an image of different types of cars. The task of our supervised learning model is to identify the cars and classify them accordingly. So to identify the image in supervised learning, we will give the input data as well as the output for that, which means we will train the model by the shape, size, color of each car. Once the training is completed, we will test the model by giving the new sets of car. The model will identify the car and predict the output using a suitable algorithm. So there are different types of supervised learning: linear regression, logistic regression, random forest, decision tree, etc. So now, after understanding supervised learning, let's see what is unsupervised learning. Unsupervised learning seeks to extract structure and patterns from the input data. It requires no supervision like supervised learning. Instead, it discovers pattern in the data on its own. Unsupervised learning can be used for two types of problem. The first one is the clustering and the another one is the association. Here you can see that in this figure, you can see that the model will train itself and divide the groups according to the most similar features between them. So let's take an example. So here we'll not provide any supervision to the model. We'll just provide the input data set to the model and allow the model to find the patterns from the data. With the help of a suitable algorithm, the model will train itself and divide the cars into different groups according to the most similar features between them. So the next question is, what is the difference between regression versus classification? So regression algorithms are used to predict the continuous values. Regression is a process of determining correlations between dependent and independent variables. For example, price, salary, etc. I'll give you the example of price versus experience. So let's understand by taking some examples. So let's suppose I'm having a data set which consists of one dependent variable and one independent variable. So the independent variable contains the years of experience, whereas the dependent variable contains salary. So as we know that as the experience of a person increases, the salary will also increase. So this is the example of the linear regression. So there are different types of regression algorithm: simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree, random forest. Now, talking about classification, classification algorithms are used to predict or classify discrete values. For example, male and female, true or false. Even you can take the example of male, whether the male is a spam male or not spam male, right? So let me explain you how does classification work. So let's suppose a computer program is trained on the training data set, then it will categorize the data into different classes based on that training. Different types of classification algorithms are logistic regression, k-nearest neighbors, support vector machine, and kernel SVM. So guys, let's move further and see what is confusion matrix. So the confusion matrix is a table that used to estimate the performance of a model. It tabulates the actual values and the predicted values into a 2x2 matrix. So now, let's see what is true positive here. So let me give you the definition of true positive. True positive denotes all those records where the actual values are true and the predicted values are true, right? So here you can see that the actual value is 1 and the predicted value is 1, and we got here true positive. Now, coming to the false negative, this denotes all of those records where the actual values are true but the predicted values are false. So you can see that this is false negative, where the actual value was 1 whereas the predicted value was 0. Next, we are having false positive. So in this, the actual values are false but the predicted values are true. So this is our false positive, where the actual value is false. So we are considering false as 0 and true as 1, right? So here we can see that the actual value was false and the predicted value was true, right? So after understanding true positive, false negative, and false positive, now let's see what is true negative. So this is a true negative. Here, the actual values are false and the predicted values are also false. So if you see, this is the true negative. Here the actual value is false and the predicted value is also false. So this is how the confusion matrix works. So now, coming to the 10th question, what is the use of p-value? P-value is the measure of the statistical importance of an observation. It is the probability that shows the significance of output to the data. We compute the p-value to know the test statistics of a model. Typically, it helps us choose whether we can accept or reject the null hypothesis. If the p-value is less than 0.05, then reject null hypothesis or else accept null hypothesis. Moving to the next question, we'll see what is a residual. So residual in a statistical or machine learning model are the differences between observed and predicted values of data. So here you can see that this is our best fit line, right? So these are the predicted values, whereas these values are the actual values. So the difference between the predicted values and the actual values is known as residual, right? So these are the residual, right? Again, this is the point that we have done the prediction, right? These are the actual values. So the difference between the actual values and the predicted values will be our residual. The next question we are having is, what is dimensionality reduction? So the dimensionality reduction or dimension reduction is the transformation of data from a high dimensional space into a low dimensional space so that the low dimensional representation retains some meaningful properties of the original data. So let's take an example to understand in a simpler way. In machine learning classification problems, there are often too many factors on the basis of which the final classification is done. These factors are basically variables called features. The higher the number of features, the harder it gets to visualize the training set and then work on it. Sometimes most of the features are correlated and hence redundant. This is where dimensionality reduction algorithms comes into the picture. So there are various methods that is used for the dimensionality reduction. The first one is the PCA. So PCA stands for Principal Component Analysis, and the another one is the LDA, that is Linear Discriminant Analysis. So the next question is, what are the steps involved in machine learning? So the first step is data collection. Basically, we are defining the problem and assembling a data set. Then moving forward, we are having data preparation. So basically, we are preparing our data. Then we have to choose the model and train it, right? And after that, we will evaluate our model. So while evaluating a model, we will choose a measure of success. Also, we will decide on an evaluation protocol. The next step is parameter tuning. So basically, we are doing here scale up, right? Developing a model that overfits and regularizing your model and tuning your parameters. And at last, we'll do the predictions. So this is the way, and these are the steps that are involved in machine learning. Moving to the next question, what is pruning and the decision tree? So I will give you the simpler definition here. Pruning simply reduces the size of decision tree by removing parts of the tree that do not provide power to classify instances. Here, in this diagram, you can see that before pruning, there are a lot of sections of a decision tree, but after pruning, so here in this figure, you can see that before pruning, there are a lot of sections of the tree that are unnecessary, right? But after pruning, we have removed that particular section. Okay, so let me read the definition for you. Pruning in a decision tree is the process of removing the sections of the tree that are not necessary and redundant, right? So why do we use pruning basically? So why do we do pruning in the decision tree? So that our model performs better and gives a higher accuracy, right? What is RMSE in a linear regression model? RMSE stands for root mean square error. It is computed by taking the square root of MSE. MSE is where mean square error, right? RMSE measures the average magnitude of the errors and is concerned with the deviations from the actual value. RMSE value with 0 indicates that the model has a perfect fit. The lower the RMSE, the better the model and its predictions. A higher RMSE indicates that there is a large deviation from the residual to the ground truth. RMSE can be used with different features as it helps in figuring out if the feature is improving the model's prediction or not. Now coming to the question number 16, what is the use of elbow method in k-means clustering? So first we'll understand what is elbow method. Elbow method is one of the most popular methods to determine this optimal value of k. So what is k here? K means here the number of clusters. As I already told you, it is the most popular method for selecting k for the k-means algorithm, right? So to do this, you need to calculate the within cluster sum of squared error for different k values. So here you can see that it is written as WCSS, which is nothing but a within cluster sum of squared error, right? So it described as the sum of the square of the distance between each data value and its centroid. You will then choose the value of k for which the WCSS error starts to become negligible. So here in this graph, you can see that this is the number of cluster and this is nothing but WCSS, right? And here at this point, this is your elbow. So the number of clusters will be 5. So the next question that we are having is, what is naive Bayes? So naive Bayes classifiers are a collection of classification algorithms based on Bayes theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. So basically you have to keep remember the assumption, right? So the assumption about each feature is that a feature should be independent and equal. So the next question is, what are the disadvantages of linear model? The first disadvantage is prone to underfitting. What does it mean? It means that it is a situation that arises when a machine learning model fails to capture the data properly. So this typically occurs when the hypothesis function can't fit the data well. Next, it is sensitive to outliers. So as you know that outliers of a dataset are anomalies or extreme values that deviate from other data points of the distribution. Data outliers can damage the performance of a machine learning model drastically and can often lead to models with low accuracy. Next, so the next thing is that you have to take the assumption of a linearity between features and the target variables. So here you have to assume that the feature is having a linear relationship with the target variable. Moving to the 19th question, when do we use normalization and standardization? So first we'll see what is normalization. So in normalization, it is used when features are of different scales. Along with that, it is affected by outliers too. So when do we use normalization? It is useful when we don't know about the distribution. Also, it varies from -1 to 1 or sometimes 0 to 1. Along with that, if you want to use it, then there is a scikit-learn library that provides a transformer called min-max scalar. So you can use this transformer and you can apply normalization. Next, we are having standardization. So standardization is used when we want to ensure zero mean and unit standard deviation. Unit standard deviation means standard deviation is equal to 1. Along with that, it is not bounded to a certain range like normalization. So in normalization, the scale was from -1 to 1 or 0 to 1, but here it is not bounded to a certain range. Next, it is much less affected by the outliers. So if you want to use standardization, then there is a library scikit-learn that provides a transformer known as standard scalar. So this is all about normalization and standardization. Next question, explain hypothesis testing. Hypothesis testing is the process of testing assumptions for a population parameter on a sample of data. The process involves different hypotheses and statistical proof to accept or reject the hypothesis. Here, null hypothesis denotes as H0, whereas alternate hypothesis denotes as H1. Now, after understanding what is hypothesis testing, let's see the steps involved in hypothesis testing. So the first step is stating the hypothesis. For example, you can take the example of students with height more than 5 feet have BMI more than 20. Next, collect data. And after that, we will see the evidence to fail or accept the hypothesis. Then we will test the hypothesis, and according to that, we will take the decisions. So as I already told you, that let's suppose there is a student with height more than 5 feet and having BMI more than 20. So this will be your null hypothesis. So what will be your alternate hypothesis? Opposite of it. That is, students with height more than 5 feet do not have BMI more than 20. Now, according to the statistical test, we'll support the alternate hypothesis or null hypothesis, right? So this is how it works. So the next question is, what is the difference between training test, validation set, and a test set? So first, we'll discuss about training test. It is a portion of our actual data set that is fed into the machine learning model to discover and learn patterns. So let's suppose that if you are having 100% values in the data set, so we'll take 70% of the values or 60% of the values to train that data set. Next, we will see about the validation test. So the validation test is used for hyperparameter tuning. And at last, we'll see what is test set. So the test set is used for the final evaluation of the best model. Moving to the next question, what are the different statistical techniques used in data science? The first one is the correlation. So it establishes and measures relationship between different variables. For example, if we are having data set, then we are having a lot of features along with the dependent variable. So it will show the relationship of features with the dependent variables. So next we are having regression. It allows identifying if the evaluation of one variable affects others. You can take the example of experience versus salary, right? Where one variable is affecting the other dependent variable. Next we are having time series. It predicts future values by analyzing sequence of past values. Basically, time series is used for the forecasting. Next, we are having the sentiment analysis. It determines the attitude of specific agents or people towards an issue, often using data from social networks. So the next question we are having, what is box plot? A box and whisker plot, also known as box plot, is used to show the spread and centers of a dataset. It is also used to detect outliers. It shows the dispersion of data across the mean. It summarizes the result as the minimum. So here you can see that. So this is a minimum, which means minimum value in the dataset excluding the outliers. Next, we are having first quartile. So this is the first quartile, or you can also say this as a lower quartile. So it means 25% of the data lies below the first quartile, right? So here, these are the 25% of the data that lies below the first quartile. Next, we are having median. Median is nothing but the midpoint of the dataset. Half of the values lie below it and half above. So this is the median. Next, we are having upper quartile, that we say Q3, right? So it means 75% of the data lies below the third quartile. So here if you can see, this is our upper quartile, right? So 75% of the data lie below this quartile. Next, we are having maximum. So it means maximum value in the dataset excluding the outliers. After that, we are having interquartile range. So this is our interquartile range, which is nothing but the length of the box, right? So it consists 50% of the data. Okay guys? Now, we will see what is whisker. So whisker is nothing but the upper and the lower whisker represent scores outside the middle 50%, right? So here you can see that we are having the lower whisker here, upper whisker is here. So this is all about the box plot. So the next question, what is SVM? So SVM stands for support vector machine. So what is the use of SVM? SVM are used for classification as well as the prediction task, right? So let us understand about SVM. It consists of a separating plane that discriminates between the two classes of variables. And this separating plane is known as hyperplane. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future, right? SVM chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are also called as support vectors. So these are the support vectors. That's why we used to call the algorithm as support vector machine. So after understanding SVM, now let's see some of the kernels used in SVM. So the kernels that are used in SVM are polynomial kernel, Gaussian, sigmoid, and hyperbolic. So moving to the 25th question, what are a z-test, chi-square test, f-test, and t-test? Okay, so first let's see what is t-test. So we use t-test to compare the mean of two given samples. Also, t-test assumes a normal distribution of the sample. So when we have to use t-test, when we don't know the population parameter, that is nothing but mean and standard deviation, right? In that case, we use t-test. So after knowing t-test, let's see what is z-test. So a z-score is calculated with population parameters such as population mean and population standard deviation. So in a z-test, we assume the sample is normally distributed. So what is the use of z-test? So we use this test to validate a hypothesis that states the sample belongs to the same population. So in a simple terms, when we have to use the t-test as well as the z-test, so we will use the t-test for the small sample size, whereas we will use the z-test for the large sample. Coming to the chi-square test, or even you can say chi-square test, it depends, right? So we use the chi-square test to compare the categorical variables. A chi-square test fit for the two independent variables, used to compare two variables in a contingency table to check if the data fits. So let's see the definition here. So chi-square test is used to determine the difference observed and expected frequencies of a certain observation. Alright, so the last test we are having as F-test. So when we use F-test, so when the hypotheses of the interest are about the differences between population means. Okay guys, so the next question that we are having is, what is the difference between correlation and covariance? So now, first we will discuss about the covariance. So covariance shows the extent to which the two variables are dependent on each other. Basically, higher the number, higher the dependency. Now, what is the range of covariance? It varies from -infinity to infinity. Right? Now, moving to the third point, it is affected by scale of a variable. So now, let's see what is correlation. So, in covariance, it indicates the direction of linear relationship between variables. Basically, it shows the extent how two variables are dependent on each other, right? But in correlation, it measures the strength of two variables considering other conditions are constant, right? The next point is the range of correlation is from -1 to 1. So basically here we are having the Pearson correlation whose range is varying from the -1 to 1, right? Along with that, it is not affected by scale unlike covariance. Next question, what is cross-validation? In a simple term, cross-validation is used to validate models' efficiency, right? So let me give you the formal definition of cross-validation. It is a technique for validating model efficiency that involves training the model on a subset of input data and testing it on a previously unseen subset of input data. In a simple term, it is a statistical method of evaluating and comparing learning algorithms by dividing data into two segments, one used to learn or train a model and the other used to validate the model. Next, we are having the cross-validation by k-fold. We can also do the cross-validation with one exception and many more. So this is the idea about the cross-validation. Moving to the next question, what is sampling? Mention some techniques used for sampling. So let me give you the definition of sampling. Sampling is defined as the process of selecting a sample from a group of people or from any particular kind for research purposes. It is one of the most important factors which decide the accuracy of a research or survey result. For example, if you want to take the sample that how many people are affected by COVID, so you will directly go into the population and out of that particular population you will take the sample about 1 or 2%. So this is nothing but known as sampling, right? So mainly there are two types of sampling techniques. The first one is the probability sampling and the another one is the non-probability sampling. So what is probability sampling? It involves random selection which makes every element get a chance to be selected. That was the example just now I have given to you. So what are the different types of probability sampling? So repeat. We will see that probability sampling has various subtypes. We are having the such as simple random sampling, stratified sampling, cluster sampling and many more. Now, after understanding probability sampling, let's see what is non-probability sampling. So non-probability sampling follows non-random selection, which means the selection is done based on your ease or any other required criteria. This helps to collect the data easily, right? So what are the subtypes of non-probability sampling? Convenience sampling, quota sampling, referral sampling and many more. So this was the overall idea about sampling. The next question, what is ROC curve? So ROC stands for Receiver Operating Characteristic. It is basically a plot between a true positive rate and a false positive rate. So here you can see that we are having the graph of true positive rate and false positive rate, right? Also, it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So I will give you the idea about ROC curve. So let's suppose if the curve is closer to the upper left corner, the better the model is. In other words, whichever curve has greater area under it, that would be the better model. Now guys, moving ahead, what do you understand by random forest model? So random forest model is a combination of multiple decision trees. It combines multiple models together to get the final output, or to be more precise, it combines multiple decision trees together to get the final output. So now coming to the question number 31, what do you understand about a decision tree? So as we know that random forest is a combination of multiple decision trees, right? Whereas, let me discuss about the decision tree. A decision tree is a supervised learning algorithm that is used for both classification and regression. The same goes for the random forest also. Here, each node denotes the test on an attribute and each edge denotes the outcome of that attribute, and each leaf node holds the class label. So here, if you see the diagram, this is the root node and these are the leaf nodes. Okay? And this is the edge. So moving to the next question, that is question number 32. What is boosting? Boosting is also a homogeneous weak learners model but works differently from bagging. In this model, learners learn sequentially and adaptively to improve model prediction of a learning algorithm. So let me give you some points about the boosting. Boosting is an ensemble model technique that attempts to build a strong classifier from the number of weak classifiers. It is done by building a model by using weak models in series. So what happens here? Firstly, a model is built from a training data, then the second model is built which tries to correct the errors present in the first model. This procedure is continued and models are added until either the complete training dataset is predicted correctly or the maximum number of models is added. Right? So what is the uses of boosting? It is used to reduce the bias. As I told you here, each new subset contains the components that were misclassified by previous models. It is a way of connecting predictions that belong to the different types. Here, the models are weighted by their performance. Along with that, new models are affected by the performance of the previously developed model. What is bagging? Bagging is also known as bootstrap aggregating. So it is also a machine learning assembling algorithm which is used to design to improve the stability and accuracy of a machine learning algorithm. Right? So what happens here in bagging? It decreases the variance. Right? So bagging is used to reduce the variance of a decision tree. Along with that, it attempts to tackle the overfitting issue. So here every model receives an equal weight. Alright? Unlike boosting, here every model is constructed independently. Right? So this is the overall idea about boosting and bagging. Explain univariate, bivariate and multivariate analysis. So first we will see what is univariate analysis. So univariate analysis involves analyzing data with only one variable, or in other words, a single column or a vector of the data. This analysis allows us to understand the data and extract patterns and trends out of it. For example, analyzing the weight of a group of people. Moving next, we are having bivariate analysis. So here, it involves analyzing the data with exactly two variables so that the data can be put into a two-column table. For example, analyzing the data that contains temperature and altitude. Okay? Also, this kind of analysis allows us to figure out the relationship between the variables. Next, we are having multivariate analysis. Multivariate analysis involves analyzing the data with more than two variables. So here, the number of columns of the data can be anything, even more than two. This kind of analysis allows us to figure out the effects of all other variables on a single variable. For example, analyzing data about house prices, which contains the information about the houses, such as locality, crime rate, area, the number of floors, etc. Next question, what is recall? Recall tells you how many times the model was able to detect a specific category. In a simpler term, out of the total positive, what percentage are predictive positive? So let me give you the definition of it. It is a metric that quantifies the number of correct positive predictions made out of all the positive predictions that could have been made. For example, here you can see that this is a formula of recall, right? So recall formula positive, one false negative. So basically out of the total positive, what percentage are predicted positive? Moving next, we are having precision. Precision is how good the model is at predicting a specific category. Basically, it measures the accuracy of correct positive predictions. So let's see the formula. So precision is equal to true positive upon true positive plus false positive. As I told you, basically it measures the accuracy of correct positive predictions. Also, the precision value lies between 0 and 1.
Let's have a quick quiz question, guys, and the question is, which of the following is not a dimensionality reduction technique? And your options are principal component analysis, linear regression, TSNE or LDA. Please mention your answers in the comment section below.
Now, moving to the question number 37, what are the popular libraries used in data science? So there are popular libraries that are used in data science such as TensorFlow, SciPy, Pandas, Matplotlib, PyTorch, Scikit-learn. Let me explain you some libraries. For example, Pandas. Pandas is used for data analysis. Coming to the Matplotlib, this is a library that is used for data visualization, whereas Scikit-learn is a machine learning library. So moving to the question number 38, what is deep learning? Deep learning is a subset of machine learning, which is essentially a neural network with 3 or more layers. Deep learning is an advanced version of neural networks to make the machine learn from the data. In deep learning, the neural networks comprise many hidden layers that are connected to each other, and the output of the previous layer is the input of the current layer. I will give you the example of deep learning in a simple term. Deep learning teaches computers to do what comes naturally to humans. Along with that, it is a key technology behind the driverless cars, such that enabling them to recognize a stop sign, etc. So now, moving to the question number 39, what do you understand about linear regression? So when I'm talking about the simple linear regression, so there is one independent variable and there is one dependent variable. For example, experience versus the salary. So let's see the points here. So linear regression helps in understanding the linear relationship between the dependent and the independent variable. So as I told you the example of experience versus salary, as you are having the experience more than 3 to 5 years, your salary will be gradually increasing. Next, linear regression is a supervised learning which helps in finding the linear relationship between two variables. So here, one is the predictor or the independent variable and the other is the response or the dependent variable. So this is a basic idea about the linear regression. So now, coming to the last question, how to calculate the accuracy of a binary classification algorithm using its confusion matrix. So first of all, let me give you the definition of accuracy. So accuracy is also a metric that is used for evaluating classification models. So what is the formula of accuracy? Accuracy is basically the number of correct predictions upon the total number of predictions. So here, to calculate the accuracy, we need to divide the sum of the correct classified observation by the number of total observations. So when I'm talking about the number of total observations, so it will include true positive, it will include true negative, it will include false positive as well as false negative. So accuracy will be true positive plus true negative upon the total number of observations. Okay guys, that being said, I wish you good luck on your data science journey. I hope these steps will help you plan your learning schedule.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.